warahmatullahi wabarakatuh. Good morning, everybody. Welcome to the second day. Today's program is municipal. The best way to start the day is by welcome speech from Dr. Buthaina Al-Wahibi, Acting Manager of Research, Development, Innovation, and Sustainability, Oman Water Services.
Assalamu alaikum, Sabah al-Khair. Good morning and welcome everyone to the Municipal Water Program in Oman Water Week 2025. I'm Buthaina Al-Wahibi, Acting Manager of Research, Development,
Innovation and Sustainability at Oman Water Services.
On
behalf of
200
Oman Water Service, it is my great pleasure to welcome you all. And I would like to extend my gratitude to each one of you for taking the time and dedication to join us today. Water is not just a resource, it is a lifeblood.
a vital resource to sustain communities, fuel economies, and protect ecosystem. At Nama Water Services, we take a great pride in leading the charge towards water security, sustainability, and service excellence. Our commitment extends beyond meeting today's needs. We are shaping the future of resilience and innovation. As Oman advances on its journey of progress, water remains a heart of our national priority. With a growing population, climate change, and increasing energy demands, we must continuously reassess how we produce, manage, distribute, and reuse each and every drop of water. This program is designed as an address to discuss the pressing challenges and inspire innovative solutions. At Oman Water Week, we bring together leaders from government, industry, academia, and international organizations. In the strategic day, we discuss and recognize building capacity is an important for sustainable water future in 5 main core areas: financial, infrastructure, human building capacity, innovation, and in-country value. Over the next 2 days, we will explore 4 technical fundamental pillars as a water production, water transmission and distribution, wastewater treatment technologies, and renewed water utilization. This exclusive gathering is an opportunity to exchange cutting-edge insights and groundbreaking solutions, from advanced desalination technologies to AI-driven leak detection, and from strategic infrastructure planning to public-private partnership. We are also honored to showcase of Nama Water Service initiatives and projects presented by some of our leading experts. As we gather today, we recognize that the challenges in the municipal water are complex and ever-changing. No single entities hold all the answers. Success depends on collaboration, knowledge sharing, and collective commitments towards sustainability. Water challenges transcend borders, and so must our solutions. In Oman Water Week is a platform for bridging knowledge gaps, fostering collaboration, and shaping the future of Oman towards the stewardship sustainability. To our international guests, your presence here is a testament to the power of sharing knowledge. To our Omani College, your dedication continues to drive progress of our field. Let us use this gathering as a catalyst for homegrowing solutions, strategies, and innovation to have a global impact. My advice to you all: engage fully, challenge the assumption, and connect with one another, because the true progress happens when we work together. At the end, before we begin, I would like to express my deepest appreciation to the technical committee and the organizing team for their tireless efforts in bringing us together today. Your dedication ensures that Oman Water Week remain a premier forum for water innovation. Thank you all for your dedication, expertise, and unwavering commitments to the critical cause. I wish you all a fruitful and inspiring experience over the next 2 days. Thank you.
Thank you, Dr. Buthaina, for your speech. Now starting with the first session, Advanced Water Production, Innovation in Desalination, Energy, Integration, and Sustainable Practices. Chaired by Dr. Muhammad Al-Abri, Director of Nanotechnology Research Center, Associate Professor, College of Engineering, Sultan Qaboos University.
السلام عليكم ورحمة الله وبركاته. بسم الله الرحمن الرحيم والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. My name is Muhammad. I am a professor of chemical engineering and I'm the director of Nanotechnology Research Center. And of course, in any kind of water presentation such as this, it's always there. I think everybody asks why we have a nanotechnology person in front of here, but I'm a water technologist by heart. This is my field, basically. We have so far 6 patents on water, related to water, and many other work. So no, I am not somebody from outside the field being here and moderating. I am just as interested in water as just like all of you. So thank you very much for being here. And it's a real pleasure and honor to stand in here and present this first session today on advancement in water and energy. Of course, we have a very big, mashallah, talkers. We have 6 in total, and I don't think we have full time to go through all the achievements, but I will try to basically be very brief. Our first talk is by Hawra Zajari. Hawra is a project engineer in Marafiq. She began more than 7 years ago with Marafiq, and starting with the process engineer, now she is a project engineer, and she is a lead in the operations of the DPC unit. I don't know what DPC stands for, but it's a very big thing in there. So Hawra, the floor is yours.
Thank you, Dr. Muhammad, for the introduction, and many thanks for your kind words. Before I begin, I would like to mention that I was a student with Dr. Muhammad Al-Abri in 2017, especially in one course called Desalination Plant. So I'm process engineering, and I took that desalination course with Dr. Muhammad Al-Abri, and I'm really proud today to be here, standing here in front of you, Dr. Muhammad, and in front of you all here, experts in water. So thank you, Dr. Muhammad, for your support and encouragement since 2017. So good morning, everyone. I'm really happy and excited to be here in Oman Water Week. So today I will talk about energy recovery in RO plant. Before I dive deeply in the topic, I would like to go through Marafiq overview and regulated water business, and then we will go to our today topic. So first, Marafiq is a joint venture utilities company owned by 2 major shareholders, OQ. OQ is a leading energy company in Oman, and also the second shareholder is Gulf Energy Development. This company is a international leading utilities company in Thailand. So Marafiq operation facilities located in Duqm, and we are responsible in developing the utilities sectors in special economic zone in Duqm. And we provided key utilities to the investors in the zone. such as the potable water, industrial water, waste management, steam, we have industrial gases, and also power. Coming to our operation facilities in Duqm, at the heart of Marafiq operations, we have Duqm Integrated Water, Power and Water Plan. This is Dr. Mohammed's DBC. This is owned by Duqm Power Company, which is owned by Marafiq. So in this plan, we produce 326 megawatt power and 36,000 meter cube per day industrial water. We supply these utilities to our clients, OQ8 and OTCO. Then we have another operation facilities, 132 kV transmission system to OTCO. And also we have another plant to supply power to the Tanweer company. And also Marafiq has invested in key infrastructure like seawater intake and outfall to support future projects. Then I will start to talk about potable water business. This business is a regulated business where we are responsible for the complete value chain of potable water service in Duqm. So starting with production, Marafiq RO plant, we have our own facilities in Duqm to provide potable water from the seawater using the RO technologies with capacity of 9,000 meter cube per day. The produced potable water transport to the customers through our transmission and distribution pipeline system. And also we have our sufficient storage and facilities in Duqm to ensure that the water, potable water is stable and continuous to be supplied to our customers. And also Marafiq has focused on maintaining and monitoring the quality of the produced potable water to meet Oman standards for the water, for the quality of the water. And in addition, we are responsible for the customer service as well. So we have our office in Duqm Center where we assist the customer to complete their application regarding the water service connections and other services. And also we are doing billing and collections systems. And here it's worth to mention that Marafiq is comply with the all license requirements that listed by the regulator. So from the previous slides and explanation, it's clear that RO is critical in our water supply in Duqm. However, RO it requires huge energy consumptions in order to produce the potable water. So I'm here to touch base in energy recovery in RO plant to enhance our optimization and efficiency of our plant in order to ensure the overall sustainability of water production in Duqm. So let's begin with our topic today. So first, why we implement the energy recovery system in our RO? Basically, this is because of Marafiq commitment to the ESG goals. And also, we note that there is an beneficial impact by using the system in terms of environment and cost. Additionally, Marafiq is aligned with Oman Vision 2040 to reduce the carbon footprint. Then why, how we implement this system in our RO? Actually, during the design phase of our RO, we consider energy recovery device to use a pressure exchanger device to transfer the energy that comes out of the brine stream and transfer it to the feed water. I will explain this more in coming slides. In summary, the benefits of this system is to reduce the energy consumptions, and then operational costs will be reduced accordingly. Additionally, we will reduce the carbon footprints, and also the RO plant footprint itself will be decreased. It's worth to mention that transfer the energy from the brine to the feed itself will downsize the high pressure pump capacity and material. So coming here to our system, so I don't think that nothing is, because I want to show you the process. Okay, I will come here just to explain. So here, if you will see, this is our RO unit, 1,000 meter cube per day. Here, I will explain to you the system without PX, the device that reduce that transfer the pressure. If you will see here that feed water is enter the high pressure pump and then pressurized to enter our RO module, and then the water is separated to the permeate and the brine. Here, for this system, the used energy is around 300 kilowatt. And the brine itself comes out of the RO with the high energy of the pressure, and this energy is wasted without get benefits of it. So our actual case where we install that the BX device, so we put that device. If you will see, that device has 2 inlets and 2 outlets. The inlets, it comes from the brine that comes out of the RO with high pressure, and the feed that comes before the high pressure pump with low pressure. And then the device is transferring the energy. So the energy in the brine with high energy, it comes to the feed with high energy, and then enters to the feed stream. And the feed stream has pressurized already by the PX, and the required energy for the high pressure pump is reduced to 126. So previously we said that the energy consumption was 300, but here, because we reuse the energy, we have only the consumption of 126. Then the other outlet from the PX device is the brine with low pressure energy. So here I have a comparison between the system without PX and the system with PX. If you will see here that for our 1,000 meter cube per day RO unit, the specific energy consumptions without PX device was 7.1. But once we install the PX, we have 3.1. So we have energy consumption reduction of approximately 60%. Now, I give you the benefits in statics. So if you will see here that the specific power consumptions for the whole capacity of Marafiq RO plant, we have it around 64 kilowatt hour per day. But with PX, we have energy consumptions of 27 kilowatt hour per day. So the power savings by implementing the PX, we have around 37 kilowatt hour per day. So if we will convert that power consumption saving to the money, considering the tariff of 30 paisa, we will have around cost saving of 0.5 million Omani Riyal per year. And then, of course, the CO2 emissions will be decreased, and we calculated is approximately around 554,000 kilogram per month. So, do you think that we stop here? Definitely no. Marafiq, I'm really proudly stands here in front of you to share that Marafiq has recognized as the utility company of the year and received energy efficiency award for implementing this system, energy recovery system in RO. Marafiq will continue to explore more technologies in terms of energy consumptions and other sustainability practice to position Marafiq as a leading sustainable utility provider in Oman and globally. So that's all from my side. I hope that you enjoy. my presentations. And if you have any technical questions regarding our system and our innovative approach, you are welcome to visit us in our booth, number E300, to discuss further the technical details about this system, and also we will show you our achievements and marafiq operation in Duqm. So thank you.
Thank you, Hawra. Very interesting talk. I've been an advocate for pressure exchange. It's extremely important, and I think the way that it's implemented is great, especially going to 3 kilowatts per cubic meter, right, which is excellent. Don't know how you can make it better, but good luck with that. Our second talk is by Nicholas Legaf, who is the Chief Operating Officer of Veolia. Veolia, of course, is one of the biggest international companies in water, wastewater, desalination, industrial wastewater, all kind of things. He has more than 28 years of experience, mashallah, in many different countries, and now he's stationed in Muscat. He has experience with desalination, wastewater, and hazardous waste, all kind of things related to water. So, Nicholas, the floor is yours.
Dear NAMA employees, dear madam, dear gents, dear colleague, as Veolia, would like to thank NAMA Water Service for their invitation to participate to the Oman Water Week, which is always the occasion to share experience and to connect with people within the water sector in Oman. So now we will talk about advanced water production with few innovations and examples in Oman, especially in the desalination sector. How to apply energy integration, operation optimization, and digital transformation. Which button? Okay, I'm good. Green Up. For Veolia, Green Up is our new strategic program. Its goal is to quickly implement affordable, repeatable solutions that reduce pollution, lower carbon emission, and renew natural resources. Green Up is our roadmap to becoming the missing link in the ecological transformation. Green Up means accelerating with an ecology that transforms and protects. Green Up means reconciling the economy with the ecology. Green Up means accelerating our innovation capacity. Green Up means greening for real and for long term. And Green Up is aligned with Oman 2040 vision. Veolia, who is Veolia? So Veolia Group, with 170 years of histories and nearly 220,000 employees worldwide, is dedicated to design and provide innovative solutions for water, waste, and energy management. Our mission is to decarbonize, depollute, and regenerate. In 2023, Veolia team supplied 113 million people with drinking water and 103 million people with wastewater services worldwide. Veolia is actually operating more than 3,800 drinking water plants and more than 3,200 treatment plants worldwide. We also provide waste and hazardous waste management solution and energy solution. A few years ago, we had an idea to power the Sour desalination plant using locally produced solar power. Today, we are proud to share with you that this idea has become reality. What you see in this picture is the Oman largest photovoltaic system dedicated to a desalination plant located in Sour. So the front portion of the picture shows the 12 megawatt solar farm, while the desalination plant is at the rear. During daylight hours, the water produced by the desalination plant is powered by solar energy from the farm, from this farm. This project has significantly reduced our carbon footprint. So by using the solar power instead of fossil fuel, we have cut down CO2 emission by 30%. So this reduces our CO2 emission by 25 to 30,000 tons of CO2. It's a demonstration of our commitment to produce local, low carbon energy and decarbonize our activities. We are exploring the means to copy this affordable and adaptable solution to other plants. This slide shows the key figures of the Sour desalination plant. So with daily production capacity of 130,000 cubic per day, energy efficiency, also with energy recovery device, population supply approximately 500,000, and we also have an energy reduction plan to reduce by 10% more within the 2 next years. It's also showing technology used like beach well catchment and dissolved air flotation system to reduce the chemical on the pretreatment. The environmental impact of our activity is also monitored closely with the objective of ecosystem preservation and marine life protection. The Veolia upgrade digital system is the integration of artificial intelligence in our daily operation and maintenance in order to optimize the performance, reduce the cost, accelerate decision-making process, and of course to support the operators. As mentioned on the previous slide, in the Sour plant, there are more than 3,000 equipment connected to the SCADA and to the upgrade digital system, providing real-time information and operating data. Those real-time data are connected, are computed, normalized, consolidated, and translated into operational decision-making tools in order to predict events and to optimize operation. As an example on this slide, one of those decision-making tools is called smart membranes. Its objective is to integrate multi and external parameters like feed flow, permeate flow, water temperature, TDS, energy recovery, differential pressure, cycle duration, age of membrane, and a lot more information to assess the performance, to optimize membrane life cycle, and to reduce chemical use, and of course, to optimize OPEX. We know that the risk of full and aging membrane is estimated to be up to 25% increase in OPEX. We are using data, cloud, modeling, artificial intelligence, machine learning in operation, in asset management, in maintenance, in water quality, in operational efficiency, energy efficiency. We have upgrade system solution for almost every step of our activities. Of course, we are considering the cybersecurity risk very seriously, and it's fully integrated in our digital strategy. Another example of innovation in the sewer plant is the barrel technology. The barrel technology offers numerous benefits. It increases safety by limiting personal exposure to high pressure and allow for outdoor installation even in critical environment condition. It also offers compactness of facilities, providing economic advantage in urban, industrial, and coastal areas. It reduces the construction and maintenance cost and lessen environmental impact. The system is more robust than conventional aero plant and requires limited maintenance. It's a competitive solution. The development of the barrel is also a testament to Veolia commitment to innovation and continuous improvement in the water technology. So in conclusion, we have showcased 3 remarkable innovations implemented in a single desalination plant. So local, low-carbon production to decarbonize our activities, membrane life cycle and OPEX optimization through digital tools, machine learning and artificial intelligence, reduced capital and operating cost with safety through the new barrel aero system, limiting high pressure and reducing the capex cost. So these innovations deployed at the sewer plant are part of our broader presence in Oman, where Veolia operates 3 major plants, Barka, the country's largest, with 2.8 kilowatt per cubic meters of energy consumption, Sur, Salalah. Our commitment extends also to remote area with several small capacities facilities in South and North Sharqiya, Darlia also, ensuring water access everywhere. Our expertise also covers municipal wastewater treatment operating the Al Amirat STP, and 36 STPs in Zone 1 and Zone 2. Our 37 treatment units present in 4 governorates demonstrate our commitment to essential services. We also provide conventional and hazardous solid waste management in Barka landfill, Al Mutaka, Soar, Bouraimi, Daïra, Doukoum, complemented by industrial services for the oil and gas through the country. So thank you for your attention. It's a pleasure to share our innovative solution and contribute to the sustainable development of Oman. So feel free to come to the booth for if you have some questions. Thank you.
Thank you, Nicholas, for shedding the light on solar desalination. It's great to look at also the implementation of renewable energy, solar and photovoltaic and desalination. I really hope that it can also be implemented in other desalination plants. Our third talk of the day is by Saif Al-Ghafri, who is a business unit head. We just talked about RO desalination. And of course, Saif, just like the previous talk, is an expert in advanced desalination units and specifically in reverse osmosis. He is the business unit head of Aqua Power in Oman, and he has a very long experience with combined cycle gas turbines and with desalination and advanced desalination. So Saif, the floor is yours.
Assalamu alaikum. Good morning, all. Thank you for being here today. Today I'm going to talk about Aqua Power journey with regards to achieving the lowest specific power consumption, as well as achieving the lowest the cubic meter cost of water desalination. So in this presentation, I'm going to take you through what is Aqua Power. We are going to touch base about the growth of water desalination, the future need of water desalination, and the comparison between the shift from the thermal desalination to the RO technology and the membrane technology, and that shift really reduced the cost of water production, since we all believe that water is something or is a need that it has to be available in every house in our country and the rest of the countries. So I will start by giving an overview about what is Aqua Power. So Aqua Power is a Saudi Arabian company established in 2004. The headquarters of Aqua Power is in Riyadh, Saudi Arabia. Then there was an expansion started in Oman and Jordan from 2008 and 2010. Then Aqua Power continued the expansion journey in Morocco, South Africa, Turkey, and then at the moment Aqua Power is very active in countries like Azerbaijan, Uzbekistan, Bahrain, UAE, Indonesia, and Senegal. So Aqua Power at the moment is having 101 assets in these countries. So we are in 14 countries with plus 4,000 employees. Aqua Power is producing 9.5 million cubic meter of water per day with different technologies, majority from the RO technology. we also actively in power generation by producing 79 gigawatt of power. Aqua Power is also very active in renewable. When we talk about renewable, it's not about the wind power and the PV, but also very active in the new technologies related to renewable, mainly the battery systems. So basically, in this slide, you can see the historical growth of desalination water globally from 1960 to 2010, and expected that this growth will continue, mainly in the countries which are highlighted in red. From the recent studies, there are 600 people in 150 countries. They rely on water desalination due to lack of natural resources of water. So these statistics and the next, the previous statistics keep us under, a big responsibility towards the society, and that responsibility is to continue the innovation in the water technology and to reduce further the cost of the desalination, beside as well reducing the impact of carbon emissions. Here is a quick recap on the water transition via the technology. So if we can see in 1993, around 70% of water desalination was through thermal desalination, where if we see from 2021, 2023, and today, there's a big shift, a huge shift, where the water desalination is now produced via the membrane technology for the reason which we all know. It's mainly driven by the cost. And there are some other comparison which I'm going to go into details in the second slides. I will skip this one. I'll skip this one as well. So here you have, the clear comparison between the distillation thermal process and the RO process. In the thermal, the driving force is the heat, where in the RO membrane, the driving force is the pressure. And the key element of the specific power consumption on the membrane technology is the process within the RO trains, because 60% to 75% of the energy consumed in the complete RO process is in the RO high pressure membrane section. And that is the major opportunity for any developer or any operator. If we want to reduce further the specific consumption, which is at the moment it is at 3 kilowatt hour per cubic meter, there are some plants in Aqua Power we achieve 2.7 kilowatt hour per cubic meter of specific power consumption. So the key focus area would be the RO membrane section. Again, this is another comparison, historical comparison between the MSF, MAD, and the RO. And then here, there's another clear reflection that RO is the most efficient, and the technology which allow Aqua Power and the rest of the developer to achieve the lowest levelized cost of water. Again, here there's a comparison between RO and MSF and MED. In terms of specific power consumption, the RO technology is below 3. Again, one of the important elements in water production is the reliability. So we can see, based on our statistics, the RO reliability is at 96 to 98. we have challenges. I mean, in the RO technology, we have challenges, and the challenge, if I talk specifically, is driven by the seawater quality, because we don't have a control on the seawater quality. The water quality in the sea, it can change in 1 minute, in 2 minutes, in 1 hour, in different seasons. So at the moment, there are so many studies on having advanced membranes, nano-ceramic membranes, still under piloting. And I believe once the RO technology find a solution on the issues related to water, seawater quality, this reliability can even go above 98%. In terms of CapEx and OpEx, the RO is still attractive compared to the thermal technologies. Here, just to give you, an overview about the water desalination leaders globe, and you can see Aqua Power is at the top, and we are producing more than 8 million cubic meter, which is around 9.5 million cubic meter per day. Here, just a highlight about Aqua Power. We are operating the biggest RO plant, which is in Tawila, Abu Dhabi, with 909 cubic meter per day. I'll be giving you a high overview about Tawila plant and the integration between the RO technology and also the PV technology, the renewable. We also operating the largest MSF unit, SWEC, 180,000 cubic meter. And concerning the MAD technology, we operate Jawab with 100,000 cubic meter per day. And we can proudly say that at Aqua Power, we achieved the lowest water desalination tariff, which I'm going to give you some examples in the coming slides. So these are the Aqua Power desalination units in the geographical area which we operate with the different capacities, different technologies. This is some of the awards which we received from 2017, 2023. So here, when we talk about the innovation leader, I would like to focus on the integration between the RO and the renewable. We are also doing some experiments on forward osmosis, as well as integrating the CSP technology with the RO. This is in Saudi Arabia. So here we can see the trend of the specific power consumption or specific power energy. We can see from 1997 to 2023, there is a sharp drop in the specific power consumption, and also there is a drop in the cost. And this is a good news, in fact, for the developer as well, for the government or the authorities. If I can give you some examples, recent examples, we have Tawila RO plant, which is operating at the moment with SPC below 3. We have Jazla also at the same point, and Hasyan Water, which is in Dubai, is still under the commissioning, but the target is to achieve the specific power consumption at 3. When it comes to the cost per cubic meter, we are at 0.5 USD per cubic meter in Tawila, and Jizla is below that, and Hasyan is also targeted to be below 0.5. So this is achievement driven by the aqua power expertise, the in-house expertise, the integration with the experts in the market. So here we can see that there are phases of achieving lower SPC. It was driven with many factors. See, the factor number one is common. I mean, this is something which is available with any developer. I mean, which is the movement from the thermal desalination to the RO. So it is a straightforward reduction. The other reduction is at Aqua Power. From early stages, we have introduced the configuration of N-1. So N-1 means that you will always have a clean unit, a clean train with a clean membrane, which is ready to be part of the operation at any time. And that will allow you to maintain the specific power consumption within the target. The third wave is the continuous optimization, continuous improvement in the process. And one of the recent improvements which we made at Aqua Power is introducing the pressure center operation. Pressure center operations means that you don't have a specific RO high feed pressure pumps for each train, where you have a common pumps for a certain number of RO trains. In our case, we have one pump for 3 RO trains, and that really helped in reducing the specific power consumption. And the example was Tawila RO and Jazla as well, and Rabagh. The other initiative is the integration of RO and renewable. Also, that helps in having two targets. One target is without the renewable, and the another target is with the renewable. I will skip because this is just a repeated information. I will go on the reducing the carbon emissions. Those are the examples of the impact of the integration between renewable and RO. So there's a huge saving in the reducing the carbon emissions. I will just go through last slide and okay, this is a Tawila plant. So Tawila is the largest water desalination. I'm proud to say that I was part of the construction of this plant in Abu Dhabi. I was part of the commissioning team and the operation team of Tawila RO. If you see Tawila RO, as I've said, the two new things is the center pressure system, as well as integrating the renewable. If you see, we have integrated the PV panels in almost 100% of the areas. You can see you have ground-mounted PV panels. At the top of the buildings as well, there are PV panels are installed. So this is, helped in reducing the power consumption, overall power consumption, at least in the day from the grid, reducing the carbon emissions. So this is a real, example of innovation. I think I took much time, Doctor. So if you have any question, we are available at Aqua Power booth. We can share the knowledge, we can share our experience, and we can learn from your experience as well. Thank you so much.
Thank you, Saif. It's really just mind-blowing how big these desalination plants are coming. I remember we were talking about first 10,000, 15, 30,000, and then 100, 200, and 300,000. And suddenly we are close to 1 million. It's amazing. So thank you, Saif. So we reached the first half. Now we'll begin the second half of this session. And of course, with my good friend, Dr. Abdel Nasser Mabrouk. Dr. Abdel Nasser is an expert in desalination and brine concentration technology. He is also the director of Gulf Core Company. His expertise is in, again, desalination, RO, and of course, concentration of brine from desalination plants. Abdel Nasser.
Assalamu alaikum. Thank you, Dr. Muhammad, for a kind introduction. Also, deep thank to organization committee and hosting NAMA for their invitation to share with you my insight in innovation in desalination and the beyond future of desalination. Also, I would like to thank the previous three speakers. Actually, Hawra from Marafiq, Nicholas from Veolia, Saif from Aqua Power. Actually, their presentation prepared the basis of my presentation. So, raised the question, what is the next? Is it possible to reduce energy consumption below 3 kilowatt? The first question. Second question is, what is beyond the desalination technology? Since this technology almost reached the maturity phase, and especially in Gulf, and there is accumulation experience, almost about 100 years are now desalination working in Gulf, right? So a huge accumulation experience. Can we use this experience to move beyond? I mean, or find out new strategy line, not only desalination, like salt production. Can we use this technology and this experience to open new business and generate salt from sea water or mining of sea water? This is actually my talk. Hopefully, I can share with you some insight in this point. Which one is okay? Okay. Actually, this is the motivation behind my presentation. I can start with this is a common, usually this large-scale desalination plant usually built in the campus of power generation, usually built in the same site. I'm talking about large scale. And this is a good example in Al from Qatar, about 2.5 gigawatt power, and this power plant provide electricity to run RO, about 120 Majidira now after expansion, and of course provide thermal energy to this thermal plant. And this model actually very common in Gulf. But of course, the brine of this desalination plant has a really big impact on the marine and aquifer. Is it possible also to minimize this impact of this brine on the marine of the marine lives? And the second question: can we localize the salt production in Gulf or in Oman? And how to build dependent knowledge on how of this technology. So, as you expect in my talk, it will be go from the big, large-scale plant to the R&D level. Because if you want to talk about future, you have to come back to R&D to define what is the limitation of existing technology and where is the gap. If we could understand the gap, so we can easily find solution and and find solution. So from thermodynamics, and we could define what is the gap of existing technology in terms of a specific energy. To define the gap, you have to calculate the ideal energy required for our energy consumption from sorry. So as you can see, the ideal case of the energy required for separation is the blue curve, about 1 kilowatt hour per cubic meter. This is the minimum energy required just to push the water through membrane, but still the water production is zero. This is the minimum energy required, about 1 kilowatt. But the reality is about 3 kilowatt, as Hawra mentioned, and Saif, about 3 kilowatt now, the practical case. And so the real case, energy consumption, about 3 times the ideal case. As a process engineer, this is a potential for us, how to minimize this gap. Of course, we cannot reach ideal, that's impossible. But is it possible we can reduce this gap? This is what I'm going to talk about. Actually, the concept or the main basic behind this high energy consumption of membrane is osmotic pressure. And the osmotic pressure came from the salt gradient. About the salt concentration in the brine. As the salt concentration increase, the osmotic pressure increase, and you need to apply higher pressure for osmotic pressure. So as you can see, the relation between salinity and the osmotic pressure, for the salinity reach about 70 gram per liter, the osmotic pressure about 70 bar, right? So to push water in the membrane, I think this is after element number 7 in the pressure vessel. So to push the water in the, to start the generation, you have to apply above 70 bar, could be 80 bar, could be 65 bar. It depends on the seawater feed. The only way to reduce this one, so I'm talking now solution, reduce energy consumption from the process development side. I know a huge amount of work, R&D, try to focus on material development for the membrane. But most of this work just to improve the reliability of the membrane, but still cannot go beyond 3 kilowatt. The only way to go through process development, how to minimize the osmotic pressure. If you could minimize the osmotic pressure, you can reduce energy consumption. This is applied pressure, as I said. If you can divide the osmotic pressure in the green line, 2 parts. First part of or I can see stage number 1, running in osmotic pressure only 40. If you can design the pressure vessel about 40, so it means you can need only about 50 bar instead of 80 bar. If you can control the second phase or second stage RO running under osmotic pressure about 10, it means you can need only about 20 bar. So how can, from the process view, how can you make this 2 stage? Here just to show the very simple, just a very snapshot of the process. We call it osmotic-less membrane. In some literature or in academia, sometimes said osmotic RO, osmotic assistant RO, or osmotic assistant FO. I'm calling it osmotic-less membrane because just to be away from confusion, it is FO or it is RO. Yeah, from thermodynamics, it's osmotic-less membrane. So in this way, you can reduce energy consumption. Very quick. Another feature of this kind of membrane, you can increase the water permeability factor. For current membrane, mostly around 1 liter, 1 LMH, the water coefficients. Since now you are going to run under low pressure, not 80 bar, could be less than, could be about 20 bar only. This means you don't need to high, you can easily reduce the thickness of the membrane. So you need, again, material development. So in that case, if you reduce the thickness of the membrane, accordingly, you can increase the water permeability coefficient as per this curve. So you can duplicate the water productivity or water flux, as you can see. Of course, there is some analytical solution for that. Here in this curve, we summarize, yes, as answering the first question, how can we minimize the gap? So now we come up with a new process, the blue line, between the gap between RO, existing technology, and the idle case. So here we can reach now 2.5 kilowatt. Of course, this assuming here the feed is 45 gram per liter. Of course, if you apply this one for Red Sea and Saudi Arabia and other side, the salinity could be lower than 45. So maybe it can go beyond 2.5. So it depends on the feed. Okay. The second technology I'm talking about, so what after 70 gram per liter? Of course, RO cannot work above 70 gram per liter unless you call it this technology ultra high pressure RO. And this work is still under development. But again, energy consumption will be higher than 3 kilowatt, of course. So there is another trend right now. There are some pilot cases in Saudi Arabia, in Indonesia, already applying such technology. We call it membrane brine concentration. In this technology, you can use existing RO, running RO at 80 bar, but high concentration. So in that case, you can run it in the concept of FO. I mean, there are two streams. You can concentrate from 70 gram per liter up to 210 gram per liter the brine by using this combination. In that, we can compare now between this technology and the ultra high pressure. Still lower ultra high pressure, but the problem with high pressure RO is you need to work at 180 bar, very, very high. I mean, as a safety, and need a specific material for development for such kind is very expensive, of course. So this is the second technology for brine concentration. Still, the third one for coming back to thermal, because again, even membrane brine concentration has also limitation. Cannot go beyond 17.5%. Only thermal can sustain in this range. So we have, in a brine concentration, we have to come back to thermal. With thermal, this is no competition. RO or membrane brine concentration has a limitation by thermodynamics. So all the way thermal. But thermal, existing thermal or historical thermal really intensive. So we came up with new design for multi-effect distillation. Of course, this patent idea, as you can see, lower compared with mechanical vapor compression, about 60% reduction. So you can use this technology, you can come back to 5.5 kilowatt. And of course, membrane cannot sustain in this area. So it will be unique, and breakthrough development for thermal, and can calling thermal back again. And they can utilize 100 years experience here in Gulf to return to the thermal, but for this journey about brine concentration, not competition with, for desalination, RO is the best, no way, no debate on that. So I'm not talking to compete with RO in desalination, I'm talking about but higher than 7 gram per liter or 7 like this, okay? Now I can, how to utilize this technology or for salt production. The strategy here, as I said, we can utilize part of the brine. This is such, assuming we have 120 MIGD RO. So if we can take only 8 million ton per year brine, if we assume, for example, for Oman here, market demand for salt about 500 ton per year. For just example, could be for oil and gas application, could be for domestic market. So you need this such mass balance. Just you need this part of this brine to get salt about 500 ton per year. So how can make this one? Actually, I filed a patent idea for this train of technology because you cannot make this by only one technology. Actually, it should be hybrid between membrane and thermal. But I'm talking about advanced thermal and advanced RO or membrane brine concentration. Part of this, the claims of this patent tested in pilot scale, advanced MED, as I mentioned, already working large scale, pilot scale, nanofiltration, and also laboratory scale, Membrane brine constitution is still in a small bench scale, but we are not talking about new membrane. We can use the existing technology membrane in the market. Little bit, we can use some loose membrane. Of course, in my calculation, I have to use some tools to validate this concept. I used developed the software 20 years back for all technology, can handle all technology, nanofiltration, RO, membrane brine concentration, multi-effect crystallizers even, to perform mass and heat balance, power consumption, CAPEX, OPEX, all projects. I'm using this tool to calculate what is the financials at the end. But before going to that, we have to understand, to choose the right technology in the right zone, you have to understand what is the sequence of precipitation of salt. Oh yeah, I almost reached in. So here, the first salt, while you are going for concentration, first salt is calcium carbonate. And actually this challenge for desalination also zone. Mostly RO and thermal, the first salt is calcium carbonate, can easily, because it's early. At recovery ratio 50%, this can be precipitating within the membrane or thermal. The second salt is calcium sulfate. Also, this is challenging for desalination. The third one, or major one, is sodium chloride. When concentration factor reaches 10, at about 9%, the salt in SL will precipitate, and this is our target, actually. After that, there are other minerals, like sodium, magnesium sulfate, magnesium chloride, and at the end, sodium bromide. Okay, based on this understanding, I here to make the easy comparison, I make two options. First option, assuming we are going to use the thermal, all journey from thermal, because this thermal technology is mature and no risk at all, just energy intensive. See here also assume the production we are going to produce 600 tons per day, which about about 500 tons per year. So the calculation show that, oh yeah, so here as you can see, we can take the brine from the RO at 7% and this mass flow rate, just to go through MEVR or called MVC. But as you can see, energy intensive is 30 megawatt. The second option, the last, almost one slide before end. This is modified, and what's I'm dedicated. You can see the energy consumption only 19 from 30 megawatt about reach about 19. And this comparison between, and this is the conclusion. This is a roadmap. We can use in desalination, osmotic-less RO, osmotic-less membrane concentration for this range, low temperature in that range. This is a new roadmap for this technology, and this is the conclusion, about 25% lower in energy consumption for RO. For advanced MED, 55% lower, and this is for brine concentration. Thank you, and sorry for taking my time. It's okay on time.
Thank you, Dr. Abdel Nasser. Thank you very much. It's good to see new kind of technologies that has been developed for something like this. I remember been talking about this many years now, and unfortunately we still cannot get into the industry, although it's very important. Well, our next talk is by Prof. Frank Lipinski. Prof. Frank is from Denmark or Sweden? I don't know. He worked in both, and I wish that I knew you last year, because I was there in the World Water Week in Stockholm. So he's stationed in Lund, and he's the head of the membrane group in Lund University in the Industrial Membrane Process Research. His expertise is in, well, he is actually the largest membrane group in Sweden. And his work is on energy, food security nexus, combined, basically in the optimization and integration of separation processes. So, Prof. Frank, floor is yours.
Yes. Thank you very much for the kind introduction. It's really a pleasure to be here. It's the first time for me to be in Oman, so I'm really looking forward. And it's also a pleasure actually to talk about one of my topics I like to talk about, actually the desalination project, which is actually an innovative desalination concept, coupling actually desalination with solar power. And this is actually part of a much larger project. It's part of a Horizon 2020 project. It's coordinated by actually Politecnico Milano in Italy. And we actually 21 partners in 13 countries. Not only in Europe, as you can see, but also we have partners actually here in the Middle East. Even here we work together with Gutek here in Oman. And the project actually comes slowly to an end. We started in 2021 and we will finish around 2026. And it's quite a huge project. Actually, we invested more than 13.5 million euros. I mean, what is actually the background of the project? I mean, we know all water scarcity. I mean, we have a problem. A lot of the world population faces water shortage, and we have a very limited supply of fresh water. However, in recent years, actually solar energy became really a key player in reducing carbon emission, and there's a growth in solar power all over the world. Even on my house in Sweden, I have now solar panels, and they're actually delivering me quite a bit of energy for my house. Actually, in the desalination project, we wanted to actually combine solar power with desalination. And therefore, we integrated a concentrated solar power cycle with advanced membrane processes. And certainly, as also my previous speaker highlighted, we look also on zero liquid discharge to make this really a sustainable zero carbon desalination system. So what is our approach? I mean, we integrate membrane systems. We combine forward osmosis, nanofiltration, membrane distillation with zero liquid discharge, including multi-stage crystallization for the mineral recovery. And we use advanced membranes, so we actually develop in the project and test new membranes for forward osmosis, membrane distillation, and nanofiltration. And also when it comes to forward osmosis, we look at thermoresponsive polymers, and that's really interesting. We try to use them on pilot scale. And last but not least, actually, we move away from small-scale lab experiments. We really go on pilot scale. So we will actually install an optimized system connected to an air Brandon cycle, solar power cycle, at King Saud University in Saudi Arabia, and we will do this actually in September of this year. So there's actually some progress also to report next year. I mean, this is the process as you can see it. I mean, what you can see nicely, I mean, you see the complete overview. We have forward osmosis, coalescer, nanofiltration on the one side of the forward osmosis, and then we have membrane distillation and zero liquid discharge processes on the other side of the forward osmosis. I don't want to go through this in this slide through the process, but I would like to go step by step through the process so that you can see the advances we do with the different units of operation. Let me start with forward osmosis. As you can see, I mean, forward osmosis is a process where you have, on the one side of the membrane, you have the seawater coming in. On the other side of the membrane, you have a draw solution. And basically, based on the osmotic pressure difference, actually you will have actually water going from the sea side to the draw solution side. So you dilute, on the one hand, the draw solution. On the other hand, you actually concentrate the seawater that you have a brine. What we do here is actually we look at two important aspects. We look at the forward osmosis membrane. So we look actually on developing two new concepts for the forward osmosis membranes based on polymerics. One is actually we use electrospun polyacrylnitride support layers, and on top of these support layers we put actually layer by layer actually the selective layer. The other technology we investigate is actually we look again at electrospun membranes, but in this case we use polysulfone as material, And here we try actually a more traditional approach. We go for the thin film composite. Basically, we put on top of this electrospun support a thin film polyamide layer. We look also at raw solutions. I mean, where we especially look at thermoresponsive polymers. And that's actually, it's quite important, the selection criteria. One selection criteria, which is quite often underestimated, is actually the compatibility of the draw solution with actually the membranes. Because what we found out with some of the draw solutions, actually, the draw solution and the membrane fell in love, so they stick together forever. In other words, they are fouling, and therefore such combinations are not really good. So one has to consider this, but also then really what is the viscosity of the draw solution at high concentration and what is actually the osmotic pressure we can achieve. I mean, in the pilot unit we're going to build up in Saudi Arabia, we will use actually commercial membranes, and we selected actually two of the market leaders, Aquaporine and Toyobo, for further testing. And Aquaporine, they're basically polyamide membranes as a selective layer with aquaporines integrated, and Toyobo, they are cellulosic triacetate membranes, both in hollow fiber configuration. And we used our pilot unit in Lund actually to do testing using a thermoresponsive draw solution. And what we found out is actually that when you look at the flux per square meter hour, that actually the aquaporine membrane had a higher flux than the Toyobo. And so we decided actually to use the aquaporine membranes for our plant in Saudi Arabia. Now, after we have the FO, when we look at the diluted draw solution side, we heat up the draw solution, and then we go into a coalescer. And in the coalescer, what is happening there is happening a phase separation. So we actually separated the diluted draw solution in the coalescer into a polymer-rich phase and into a water-rich phase. And the heat we need to heat up the draw solution, we take actually directly from the Brighton cycle. We did some experiments for the coalescer, and we were very glad to use actually the pilot scale coalescer at the Politecnico Milano. So as you can see here, I mean, we have basically the coalescer where we have the solution, the heating unit, and then the coalescing unit. And some of the experiments we did is, for example, we looked at the lower critical solution temperature, in this case for PHA 2000, which is actually the draw solution we selected for our larger scale pilot. And we looked at the impact of regeneration temperature, residence time, and initial draw solution concentration. And what we found out at about 70 degrees C, I mean, we achieved quite a good separation between water and the polymer. However, the coalescer does quite an important part in the separation of the draw solution into a polymer-rich phase and into a water-rich phase, but certainly we want to have optimal water quality. Therefore, we take the water-rich phase from the coalescer to a nanofiltration unit. And with this nanofiltration unit separates then actually the remaining polymers and the purified water. The remaining polymers are then recycled, and then we take out the pure water from the process. For this nanofiltration, we use actually ceramic nanofiltration membranes produced by our partner in the project, Fraunhofer from Germany. And using actually the ceramic membranes, we have actually the key advantage actually that we reduce the need for cooling, because ceramic membranes can operate actually at quite high temperatures. Moving further in the process, now looking actually at the brine side of the forward osmosis, we installed actually membrane distillation. And the idea is actually to increase brine concentration and improve water recovery. What we do here is actually we're using new super hydrophobic ceramic membrane distillation membranes. And the membranes are actually with silicone rafting, and they have a very, very high water flux compared to polymeric equivalents on the market. Moving further in the process, after the membrane distillation, we have now the concentrated brine, and then we go actually into a zero liquid discharge process, where we then take out the minerals and have a extra purified water stream. And here we did some simulations using Aspen Plus to predict basically what is the recoveries we can achieve. And what we saw actually is we can achieve about a water recovery of 100%. and we recover a lot of the magnesium, calcium, NaCl, and also lithium. And when you look about the amount of minerals we can actually recover from the brine with this method, I mean, we are talking over 50 kilograms of minerals from a cubic meter of brine. We looked also if brine mining is profitable. This is a preliminary study, and we use actually data from a multi-effect distillation plant on Tenerife Island. And actually, we looked at 3 different scenarios. The first scenario was actually when we use actually a solar field as source, when we use a solar field with hot and cold storage, and when you use a geothermal well for the heat. And these scenarios we investigated with a capacity of 100,000 cubic meters per day. And then we try to get some conclusions and also little outlook. And these are some preliminary results. And quite encouraging is certainly that we get up there quite high in the water recovery. And also the financials are actually not so bad when you look at the payback times. Overall, I mean, when we include the mineral recovery, we actually increase revenues quite significantly. And when we look also on the CO2 emission, we can actually reduce it quite drastically. So actually, there is actually a good possibility, as this is preliminary results, that brine mining can actually really improve profitability and sustainability. So in conclusion, what I wanted to show to you is actually that desalination provides a sustainable solution to water scarcity by really integrating solar power with advanced membrane desalination technology. We develop advanced membranes for forward osmosis, membrane distillation, and nanofiltration. Along the side, we look at permeable responsible polymers, and we really try to enhance water production and reduce environmental impact. And also when we look at the zero liquid discharge, which really enables us then to recover valuable salt and really push up the limits of water recovery close to 100%. Overall, we hope to develop a sustainable and cost-efficient solution, which is actually quite interesting, especially for the countries here in the Middle East where you have water scarcity. To look out in the future a little bit, what you can see here is basically this container is actually at the moment under construction at our partner Protarget in Germany. And before the summer, it should be finished and be shipped to the King Saud University in Saudi Arabia. And the plan is basically end of September, we will have a big startup of the whole installation in Saudi Arabia. And with this, I would like to thank the desalination team for all their excellent work related to the project. And certainly I would like to thank also the European Union as a sponsor of this project. And finally, I would like to thank you for your attention, and thank you.
Thank you, Prof. Frank. Forward osmosis is a very bittersweet experience for me. You are in the right place because Oman was the first country to implement forward osmosis. In 2010, we had a plant in Al Khuluf. We are currently working also, I think Arab Petroleum is working with Trevi also in a forward osmosis plant for produced water. So modern water went bankrupt 2-3 years afterwards, so I don't know. I really hope that we can see something beneficial for forward osmosis. I think it's good, but it's, again, with your work, hopefully we'll get somewhere. So our last talk is by Ashraf Ali Hassan. I think, Dr. Ashraf is associate professor in United Arab Emirates University. He's a faculty member in the university, and he was in the University of Nebraska, Lincoln. So, Dr. Ashraf, the floor is yours.
Assalamu alaikum. I'm very glad to be here, and I'll gear a little bit the talk towards something hopefully new and exciting. Okay. So what I'll be talking about today is the concept of biodesalination. And biodesalination is a newish concept. We developed this in 2010 at the laboratories of the US Environmental Protection Agencies in Cincinnati. We took a seed grant to develop this high-risk, high-gain project. The whole idea of this work came from some publications where they mentioned something about having reduced salinity when dealing with algae in water. So this led me to think about how can nature actually deal with its salts? How can ecosystems work in marine environment? We see that there is a lot of mangroves in UAE, in Oman. We see that there are a lot of algae that grows into the water. But how does this microorganism can work with this high salinity is what we will try to delve into this talk. So I just don't know how. All right. So what is biodesalination? Biodesalination is a process that utilizes organisms, in this case, green algae or cyanobacteria, which are two different kingdoms, by the way, and they uptake the salt down into or inside the cell so that to balance the pressure between the cell inside and out. So it can work in a lot of things, not only with algae. So for example, it can also work with plants, which I know that there is a farm here working on produced water, on saline produced water. Working with plants, while it works, it's not as efficient as microorganisms. Why? Because microorganisms, they populate and they multiply very fast, much faster than plants. So while they are very small in size, however, the capacity or the throughput that you can do through the system is really high. So what can we gain out of it? Not only that it's energy efficient, because it's actually nature's way of doing the work, it's virtually green, sustainable, and it is cost effective, and it can be used anywhere without any external equipment. So when we started this project, I told you that was almost now 12 years ago, I started with screening so many types of algae. So I took 20 or 15 to 20 at that time. Well, 20, but 5 didn't work. So, and I kept growing them at different salinities and kept trying to see what's going on. The lowest salt uptake I got was 5%, and the highest was 20%. And I was really happy at that time with what we got, just to prove the concept that we can remove the salt this way. So I'll just try to explain to you a little bit how it works. There are three mechanisms that are involved. There is adsorption, accumulation, and then mineralization. So, and they happen at different time scales. So the very first thing, when you put algae together in saline water, what happens? That their salt particles will very fast try to find the cell wall of this algal thing. And we're talking about really tiny, small, microscopic thing. So the salt will try to find its way to the surface. What happens first is it binds to the surface. This is what we call the bioadsorption. And this happens in the first few minutes. Now, as a biological process, algal cells are being created, multiplied all the time. So, and some algae we have in a matter of minutes that we have doubling of the culture. So what happens? That these salt ions that are on the cell wall, they try to penetrate the cell wall and find themselves inside the cell. And does it remind us of osmosis? It is actually an osmosis process. But now with this, why I said it's energy efficient, because now we're doing it with very little energy. but it takes time. So salt particles, they penetrate the cell wall and try to lay inside the cell in a process balancing the osmotic pressure inside and outside. Otherwise, the new cells will collapse if there is so much salt outside and no much salt inside. The third process is biomineralization, where we actually can collect the salt from the algae, from the dead algae. Now, and this is still a matter of research that we're currently doing, because once the cell wall, once the algae itself dies, the cell wall opens, and then you can get more flux into the system, or we can also mineralize the salt and collect this algae. So this is, in this schematic here, we can see how this actually works, the NaCl going through the cell wall in attraction first, and then ion exchange, complexation, they bind into the EPS with the van der Waals forces. In the bioaccumulation, they penetrate inside the cell. And finally, with the biomineralization. So this research, over now a decade that I've been working on with my team, we have tested so many things. We have tested so many algae, and I will go with you through some of the things that we've tested, and I see when we went from 5% now to, I will not say it right now, but to the highest efficiency that we've reached so far. So we tested salinity levels. So now, is this technology working on low salinity, on brackish water, on seawater, on brine? Actually, we've tested it, all of them, and surprise, it works for all of them. It just depends on the type, the right type of algae that we can employ to do the process. pH levels. Now, as algae is a living organism, you just have to give it its right conditions for growth. So if you manage to make the species itself satisfied in its medium, you can grow the algae in any pH you want, so that also leaves or lifts a lot of restrictions. Temperature, that's the challenge that we've been dealing with in UAE in last summer. We have this very nice climate in the winter, but in the summer it gets a little bit hot. So I had logged a temperature of 62 in May inside the tubular photobioreactor that we have. So we are now working on temperature tolerant species where we can also have that to work in harsh conditions. For sure, nutrients are essential life for algae. So in some types of water, we will have to add some nutrients to make this process work. But the good news, if you are just taking seawater, probably it has everything that it needs for the algae to flourish. Light, while this is a photosynthetic organism, and you expect that you need a lot of light, actually, we had to shade the reactors because in our area we get too much light, more than the organism would actually need. So we're actually now trying to reduce the light. Maybe we'll have to go indoors. Also, that will help with the temperature. And finally, hydrodynamics, because of shear stresses that will go with the algae. So what are the applications? Now we can do this in agriculture. We can do this for drinking water or for wastewater treatment. So depending where you want to go, you can have different stages of treatment. So not every process that we want to apply biodesalination needs to go 95% or 99% salt removal. While you can sometimes tolerate high salinity for agriculture, so that would be even cheaper, and it will work. If you really want to go drinking water, it can be done. However, right now the challenge, it needs large reactors. So it could be combined with any other technologies as polishing or as pre-treatment. And for sure, algae has been used for wastewater treatment for a long time. But what we what we can offer with this technology is actually dealing with saline wastewater. So wastewater that is brackish, which we see in the GCC. So this is the photobioreactor that I was mentioning earlier. We have built in the UAE University. This is a 1,000 liter photobioreactor, and we grow the algae inside. We try to do it in several ways. We can have, as you can see in the picture here, in the large reactor, we can have what you call suspended growth, where you have green water going around. Now, the disadvantage of this one is that you end up having to remove the algae from the water for the application. Not very big problem if it's agriculture, but if it's drinking water, you need to do some more step. In another way, we do what we call immobilization, and this is patented technology. We got the U.S. patent for that. So what we do here, we have this, what you can see on the left, you have this hydrogel where the algae is immobilized on this jelly-like thing. This is, by the way, food grade, so there is no chemicals, harmful chemicals involved. So, but what it is actually we are attaching the algae in a medium where the algae is stationary and the water is moving. So now we can have the treatment, and at the same time, we don't have to have the separation step that happens later. So what did we find here? We tested so many strains. These are the strains that worked the best in our experiments, and especially the formedium. Formedium showed very high removal efficiency. We reached, well, that's not yet published, but we reached more than 50%. What's published in literature so far is maximum of 46% salt removal. So that's already peer-reviewed and out there. So comes the next step where I was telling you about how to deal with this algae. In suspension, centrifugation, during that time, last year, a study that was done in China, they came up with a new concept that if you centrifuge the algae, then and take the pellets and resuspend them into the water, then it will work in a shorter time. I tried to replicate it several times, didn't really work. However, we came up with our own ways of attached growth and immobilized growth, and that's our patented technology. So this is really how we do it in the lab. We take our salt with the nutrients. We do different salinities. We grow the algae inside the salinities, and then we test it with the ion chromatography to look at chloride concentrations inside the cell. So let's look here at this graph. This is what I was telling you earlier about the 45.7%. Yes, 1 minute. Okay, now I have to run really fast. So so this is, we've done this at 2 gram per liter, 4 gram per liter, 10 gram per liter, 30, 70, 100, even more than 100. We've even done that on saline produced water that's coming out of undisclosed source, but actual produced water, 3 types of from 3 different concessions. And it worked on all of them. So we can see that the algae here is flourishing up to 70 grams per liter. This shows you how the in this SEM images on the left shows you where the ions and how they attach to the surface. So I will run through through a lot of the results, but let me just tell you what is our next steps. So right now, as I'm telling you, we are still working on screening algae, and algae is there are thousands, hundreds of thousands of species that are out there, and they are very resilient. So this will never stop, and this will require a lot of other researchers also to help and work with that. So the main challenge here is to bring that from the laboratory to commercialization. So, and this is how we are teaming up with an Omani company, an international Omani company, to form a new startup called Tahalib, where we are actually trying to use this technology for treatment of brackish, for the seawater, but working on the reactor design, which is very challenging, because now you need a reactor that has the carbon dioxide, that has the sun, that does not have a lot of evaporation, and can do good separation, and can resist our temperature and our light conditions. So it's a little bit of a challenging process. I try to be inside the 1 minute, and thank you for listening.
Thank you, Dr. Ashraf. Another new technology, which is interesting, biodesalination. So this is the end of the talks, but we are not finished yet. I would like to first thank all of the participants, but also invite them for a quick and brief Q&A session. So all of the presenters, please join me in the front seats here. Thank you very much once again. I have many questions, but I think it's better to leave first questions to the floor and see, because we have a very brief time, and unfortunately we went a little bit over. So if there are any questions, you're welcome to ask.
Thank you for the question. So the question was if we can do other stages, like multiple stages, so we can go further than 45%. And definitely the answer is yes. So but the idea here is that with every treatment that you're doing, you're changing the culture. You need different strains, because the algae that will work on the first stage, the high saline, is different than what will work on the second stage. But definitely that's part of the concept that we're exploring right now. Thank you.
Okay, thank you, Dr. Salam. Thank you. Yes. We have a mic? Yeah.
Thank you very much. This is Khalid Hashim from Bahrain. I have 3 questions, if you allow me. Question number 1 is regarding the specific energy of desalination shown in the presentation of Veolia. specifically regarding the thermal desalination. The figures shown, I just want to confirm, these figures are measured from the brine heater or from the boiler, or where exactly? Just to be, just to compare it with the other figures I have. Question number 2 is regarding the pressure center operation. I'm coming from a very traditional RO plant where we run one high pressure pump for each train. So I just need to know the pros and cons of this type of operation. Question number 3 is regarding the forward osmosis. Modern Water also came to Bahrain after the success pilot in Oman, and I didn't hear about them since that. So I'm wondering, is forward osmosis a mature technology now? And what's the largest plant available using this forward osmosis? Thank you very much.
Yes, so the first question is to Veolia.
Yes,
we'll
thank
go
you
to
for
the
this
third
question.
one.
I think it's not for Veolia, it's more for Mr. for Aqua Power.
Yes. Yeah.
Yeah, so the first question, which is related to the MSFE specific power consumption. So this is only measured, for the auxiliary systems which are linked with the MSFE units and not linked with the boiler or the power plant. So we are talking here about the brine heater, the brine recycle pumps, and the desalination pumps, and the condensate extraction pumps. So it is limited to the MSFE process. The other question you have asked about the configuration of the pressure center. There are few disadvantages of the pressure center. Is mainly the trains are connected to one header, and if you have an issue with that header, so it means that there's an impact of the operation of those specific trains. But this risk is mitigated through a quality of the construction, a quality of installation, as well as it is mitigated by having N-1 train, which is a standby unit. In overall, if I compare the risk and the benefits are more far than the risk.
I would like to comment. Really, I would add a comment about the way of calculating a specific energy consumption of or thermal desalination plant. Usually, to make really fair comparison, most of the figure right now I have seen it is for all the thermal. But we have a good figure in Qatar, recent MSF, the specific energy consumption about 11 kilowatt. Compared to what presented, actually this is very, it depends on GOR. If you increase the GOR of thermal, of course, will reduce the specific energy consumption. So GR actually for recent MSF about 11. So that's why the equivalent energy, including electrical power, which about 3-4 kilowatt as electrical for pump, running pump, and for thermal using low pressure steam about 9. So the total between 11-12. This is a recent figure. Unfortunately, this is not published, and most of the comparison, the literature compare recent RO with all the GR about 6-7 MSF. So this is what I just need to update this information. Thank you for your question. Yeah, I think yes. Thank you. Thank you for this comment.
Sorry, I can leave it. Yeah, sure. And the last one is the forward osmosis.
Yes, I think it's probably me who have to answer it. To my knowledge, at the moment, the largest reverse osmosis plant is on Hawaii in the US. But we talk about a couple of cubic meters, and they're using actually Toyobo hollow fiber membranes for the forward osmosis step, and then they have a nanofiltration step. And to my knowledge, they use also thermoresponsive polymer. But I mean, it's still from on very small scale to other desalination technology. I think one of the problems I see personally also with the thermoresponsive polymers, if you have high concentration, they're becoming very viscous, and you need high concentration to have basically a high desalination, so getting to high recovery values. So, I mean, there are some challenges. We look at this and try to improve it, but I mean, it's definitely not a straightforward, mature technology at that stage in time. That's my opinion about it.
Allow me also to add some comments, since I touched this in my presentation. Actually, as Frank presented, in this approach, the energy recovery or energy consumption for draw solution is still high. Make this technology even for large scale still will be some challenge. So that's why the new trend right now to using assistant FO. Instead, rely on high potential chemical or draw solution. You can use brine of seawater. You don't need to use a specific draw solution. If you use the brine itself as a draw solution, no cost in that, no need to develop. Just you need to add some bomb in one side of the membrane. I call it osmoticless, as I presented my presentation. In that case, you don't need specific development, and very quick you can use whatever available technology for in the market with less energy consumption. Thank you for your question again.
Thank you, Doctor. Okay. Yes, please.
Hi, my name is Dalia Sabri. I'm from IWRA Egypt. Thank you for all these interesting presentations. But my question is to Dr. Ashraf. I want to ask about this, the scalability and to have, because we have seen a lot of experiments and lab works on algae, but until now we haven't seen in the field real work like on a bigger scale. Like I worked on water reuse and drainage water reuse for irrigation, and also the main problem is this is the salinity of irrigation water. So can we have it like on remote areas, like in small units, and how about the cost, and can we apply this in different areas, like in rural areas, or to solve this problem? So, thank you.
I'll try to. It's a big question. So I'll try to narrow it down a little bit. So yes, it can be used in remote areas. Yes, it can deal with the salinity and for water reuse. So the answer of this is all yes. Has it been done? No, it has not been done on a large scale. Now, algae itself is a mature technology. It's been really used like you have the raceway ponds have been out there since the 60s. So, and they've been used for wastewater treatment. So the idea here is that we are changing the focus and changing the shift with the new technology. So we need the new reactor that actually can work. As I was saying, one of the main things is the evaporation. So even if you get the salt out and the water evaporates, you will end up having high salinity. So it's not solution. So the reactor design is really important for this to be upscaled. So for example, one of the concepts that we dealt with is attached growth over zeolite media. So and this I think will work very well. Upflow reactor with the packed zeolites, and algae is growing on the outside of the and we've proven it on pilot scale, not industrial scale. So I guess hopefully in the next few years you will see a lot of expansions in the size that could be used hopefully for industrial scale.
Yes, please.
Thank you. My name is Marco Archier, the president of ICID, International Commission on Irrigation and Drainage. I have a general question for all of the panelists, but especially for the companies. Is there any trend regarding the possibility, from an industrial point of view, of using green hydrogen to reduce the carbon footprint to reduce the cost of desalination? Because I think Oman, for instance, has many positive aspects regarding the possibility of using hydrogen, green hydrogen, for reducing carbon footprint and reducing the cost of desalination. Thank you.
Yeah. I will try to answer to this question, which is not an easy question. Thank you for making it. There are different examples. Of course, the hydrogen is a source of energy which is really powerful, and one of the main points of each aeroplant is the energy consumption, because it's approximately 45% or 40 to 45% of the cost of the plant, the consumption of energy. We have now in some example within Veolia in France, where we are working to do reuse, to supply we call that the south hydrogen corridor, to supply the electrolyzer with seawater offshore windmill, so to produce the energy, and to supply to provide the electrolyzer with reused water from wastewater treatment plant, reused stage, to produce basically hydrogen. At this step, we could imagine using this hydrogen to produce energy and to reduce to green the consumption of the aeroplant or the desalination plant. But we can say that since the beginning, and I think all my colleagues have talked about, since the beginning of desalination, the progress which have been made, all technology included, it's the energy consumption has been reduced by approximately 85%. And all of us, our target, it's also to improve those next step and to improve the energy consumption, and of course to decarbonize. So this is one of the solutions, and I'm sure in the future we will go through this type of solution.
And also I want to add here that I will answer your questions in something around that. One of the research that have been done in Geotech University, that the treated wastewater itself is used to produce hydrogen. So here we, instead of use distilled water, which is, we need to use RO technology, which is energy consumption. So here we will use the treated wastewater to produce hydrogen in effective way without, using more energy consumptions.
Can I allow? I would like to add something also. I was about to highlight in my presentation, but Dr. Muhammad already make it enough. So actually, yes, you're right. As I mentioned, future of desalination and the reduced cost, you have to think either produce another product like hydrogen in the journey of desalination. I mean, the way of while you are producing salt production, you can produce hydrogen from chloralkali, and this chloralkali, you can use the brine concentration at 25%. So this is one product of desalination. You can use it for chloralkali. You can generate chlorine and hydrogen and sodium hydroxide. By selling this byproduct, you can reduce the overall cost of the desalination. So yeah, this is the future of desalination, and we have to invest in this way. And thank you, very good, valuable question.
Yeah. Okay, thank you. Unfortunately, as I said, I have really many questions, but we've reached the end of the talk. So I'll keep them with me. I will probably, no, not you, the other ones. Yeah. Yes. So once again, thank you all for all of the interesting talks. We began with sustainability, the overall perspective of the desalination, especially the pressure exchanger, And then we talked with Aqua Power and Veolia on the overall and the energy, the renewable energy, which is something really great. Then we moved to Dr. Abdel Nasser, talking about osmosis, which is very interesting talk there. And we ended the talk with two sort of research-based moving into the application-based of forward osmosis and bio. So new technologies, two new technologies. We expect, we hope that we can get breakthroughs in there in both in the biological desalination and of course with forward osmosis. Personally, I am more into forward osmosis because I worked on it. We have a group in SQU working on bio, and I really hope that we can achieve something with all of these. Very interesting talks. I really enjoyed all of them. Thank you all. And I think before we go to, I think we no longer have half an hour of only 20 minutes of break. But we also have, I think the organizers and NAMAD, they have sort of appreciation for the presenters. Okay. So a group photo of all of the presenters. Dr. Buthaina.
Thank you, Dr. Muhammad, for the excellent moderation. And we invite you to give the appreciation certificate to our speakers. Starting with Hawra al-Zajali. Nicholas Lijov. Saif Al-Ghafri. Prof. Frank. Prof. Ashraf. Thank you for attending this session. We will have a break for 20 minutes. And then we will continue the second session, inshallah. And we have a bag for the delegates in our registration. Thank you all.
شكرا جزيلا حسام. Thanks a lot. Thank you everyone. Again, as Hussam mentioned, we will continue our session at 11:30. As of now, we'll have a short break. As well, I would like to notify you that the delegate bags can be collected from registration counter, so please visit the counter to get your delegate kit and bag. Thank you so much.
You want me to talk or just standing?
وين يصوروني ما صوروني الصبح. Take it from this side. لا لا wait خليني كني أتكلم. I have to talk. So welcome everyone again. Good morning and welcome أشقلكم to the Municipal Water Program in 2025. The program this year will discuss the two approach of the municipal and the produced water as a desalination, water treatment, wastewater treatment, and the utilization of the treated water. It's okay.
Also with the display. I look to you? Okay, okay. This is a test for separation of things. This is a test for separation of things. Thank you.
We will start in 1 minute. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back. We are starting the second session, strategies and economic viability in water production, infrastructure, investment and partnership. It will be chaired by Dr. Salim Al-Ma'mari, Project Manager at Authority of Public Services Regulation. Please welcome.
بسم الله الرحمن الرحيم والصلاة والسلام على أشرف المرسلين سيدنا محمد وعلى آله وصحبه وسلم. Welcome you all, and thank for the organization committee and the sponsorship for all to organize such a conference. I will take you now to session 2. We have listening to desalination plant at the session 1 and the energy recovery and other interesting topic, and we'll take you now to the session 2 about the strategic and economic viability in water production, investment, and there is a 6 presentation, and I would like to welcome you all for this session. The first start on this session will be on desalination in Oman, an overview of key desalination plant and their impact on water security by engineer Qawla Al-Barawani. She is a water engineer in the Authority of Public Services. Qawla, she is a water engineer in project department in the Authority of Public Service. She have graduate from Sultan Qaboos University, and she is having a civil engineer bachelor. She is currently working in the public authority. Her responsibility include working on a permit for desalination plant, and also she is conducting a site visit to the desalination plant. Welcome, Qawla, for your presentation. The floor is yours.
Thank you, Dr. Salim, for the introduction. Actually, Dr. Salim is my manager, so no pressure at all. Okay, let's get started. Key desalination plants in Oman and how would, they affect the water security. First, I'll give you all a brief on, just let me. Okay. Today we will talk about the water sector in general. I'll give you a brief on the water sector in Oman and how it works. Then we will talk briefly about the authority, what it does, and what is the authority's role in the sector. Then we will talk about the APC, which is the appropriate person criteria. Then we will move to the license and examination procedure, which is implemented in the authority as well. After that, we will move to the desalination techniques in Oman, how it all started and where it is now. Then we will talk about the key desalination plants, and then we will end with water demand planning and how are decisions made on the industry for new plants. Okay. Let me give you the overview on the water sector. Water sector in Oman has three main components. First of all, we have the policymaker, which is the Ministry of Agriculture, Fisheries and Water Resources. The ministry being the main player in the water sector. The ministry mixes the policies, the regulations, and the rules. Then comes our part. We are the regulator. I work for the regulator. And we make sure these rules and conditions are met by the companies. We make sure these companies are compliant to the rules and regulations as a regulator, which is the Authority for Public Service Regulations. Then we have the service providers, which are the companies that actually do the work, the companies that make sure the water is actually delivered to the houses and other facilities safely and without any shortages. Among the companies, we have, of course, Nama, Power and Water Procurement Company. We have Nama Water Services operating North Oman. We have Nama Dhufar Services operating in South Oman. Then we have Marafiq Company as well, operating in Duqm. We have Majis Industrial Services Company, operating in or located in Sohar. We have independent water plants as well that do the treatment and provide water. We have other service providers also, like some other entities that do the treatment and supply. Okay, talking about the Authority of Public Service Regulations, we are regulating three main sectors, which are gas transmission, water and wastewater, and electricity. We have some regulated activities among water and wastewater, which is the main theme here. Wastewater collection and transmission, also supply and treatment. We have drinking unbottled water, also treatment and supply, and collection and transmission. We also have treated effluent, TE, also the treatment and supply. We have also water import or export to Oman, and any international water connections between Oman and other entities must be regulated by the authority. Also, any activities set by the regulator. Of course, all of these activities require the license from the authority. Now let's talk about how to get this license. To get this license, you'll have to go through two main procedures. We have the APC, the appropriate person criteria, and we have the license and examination procedure implemented in the authority. About the appropriate person criteria, in the authority, they make sure that every entity or applicant is meeting the terms highlighted in Article 2218 from sector law. And then there is a board formed in the authority just to assess and approve any applicant. This board consisting people from the energy department, from water and wastewater, and also from customer and legal affairs. To talk more deeply about the APC, or the appropriate person criteria, it has many aspects. They do a deep dive on the applicant. So to check the legal criteria, compliance criteria, financial and technical and economic criteria, making sure that the applicant is well experienced, has expertise and has the equipment to meet what is required, and also has a good legal standing and has good funding to carry on this project. Now I'll give you a brief on the license and examination procedure done in the authority. The respected team in the authority receives the documents, then they do revision on the documents. After they do the revision on the documents and it's all okay, they move to the public consultation. What is the public consultation? Is that they publish a consultation in the newspaper in both languages, Arabic and English, aiming for information from the public whether the applicant is okay or not. After doing that, they move to the authorities board approval. The authorities board assess and approves the documents from the applicant. After it's all cleared, we move to the final decision. Usually His Excellency is deciding the final call. This procedure usually takes around 7 weeks. Now let's talk about desalination techniques here in Oman. As most of you know, and as my colleagues explained in the previous sessions, most of the countries started with MSF, as well as Oman, which is multi-stage flash. Multi-stage flash depends on the thermal energy to reheat water, and then we collect the steam water and condensate it to fresh water. Of course, we moved later on to RO technique because RO is much more economic and it's also much more scalable, reaching a tariff of up to 144 Paisa in Qarayat desalination plant. And we are hoping to get it lower. The key desalination plants here in Oman, we have 11 key desalination plants in Oman. 2 are under construction, demonstrated in this graph. Barka 1, Barka 2, Barka 4, and Barka 5. Barka 4 being the largest until now. Of course, Al-Ghabra 4 Al-Ghabra 3, sorry, will beat that later on. We have also Suhar 4, Sur, and Al-Sharqiyya. We have Al-Ghabra 2, Qarayat, Salala 1, and Salala 3. Al-Ghabra 3 and Wadi Dhiqa is currently under construction. Al-Ghabra 3 will be the biggest desalination plant here in Oman, with capacity of 300,000 meter cube per day. This map shows you the desalination plants with their locations and the areas they are feeding. Well, let's start with Suhar. Suhar, with a capacity of 250 meter cube per day, is feeding the Suhar zone. And then we have Barka plants, Barka MSF, which is a call of contract. We have Barka 2, Barka 4, and Barka 5 feeding Barka zone. And then we have in Dhufar region, we have Salala 3 and Salala 1. We have in Sharqiyya zone, Sur 2 and Asila. And in Masqat zone, we have Ghabra 2 and Qarayat. Of course, as you can see, most of the plants are feeding Barka. So we have some water transfers coming from Barka zone to Masqat zone and Suhar zone as well. Now to meet the water demand from the regions, we have also supportive well fields. These well fields are mixed with treated water to meet the water demand. The biggest well field we have is in Al Khawd with a capacity of 46,500, which is the safe field. If you go beyond that, you are compromising the quality. So this is a brief on the well fields we have in Oman. Okay, moving on to the water demand planning. Oman is divided to 17 geographical zones. Each zone has its own water demand. Water demand is calculated using the statistics from National Center for Statistics and Information. The population data is used to forecast the water demand. After water demand is forecasted, headroom is added to decide on the water demand for each region. And then we have a 7-year statement that is updated every year. That is studied to decide on any plans related to any new desalination plants. Of course, this 7-year statement is updated every year, and it is forecasted up to 7 years. Now let's talk about the decision on the new desalination plants. It's depending on many aspects. To give you the conclusion, it is depending on the peak water demand. The peak water demand, which occurs in the summer months. This peak water demand is used as a value to design for any new desalination plants. Also, headroom is added to a water demand. Headroom is like a safety margin added to the water demand to make sure that water is available in case of any shortages or emergencies. Also, the interconnection between regions, as I have shown in the map, there is water transfers between regions. So this is also considered when planning for new desalination plants. Also, as I mentioned in the graph, available water from wells. Available water from wells also is a key factor to decide on a new desalination plant. And of course, the 7-year statement which is revised every year, and forecasting the water situation in Oman from this year up to 7 years, and this data is compared to the actual data we have. And that's it for me, and thank you for joining me.
Thank you, Engineer Kaula. It was an interesting presentation since on the start licensing of the companies and then water security, which I mean the calculation based on the peak and the headroom is being added and also the interconnection between the area two in case of emergency to help each region. So thank you, Engineer Khalil. And join me now to welcome Sohaila Al-Balushi. Sohaila is Asset and Planning Manager in Nama Water Service. And Sohaila from Nama Water Services, Assist Planning Manager, responsible for the planning scope in Muscat, South Batina, and Ad-Dakhliya, working in the full cycle of the project initiation, starting and the master plan CAPEX program, 3-year price control period, concept design, pre-investment appraisal, document financial modeling, and project charter. So welcome, Sohaila. The floor is yours.
Good morning, everybody. Thank you for being here. I'm Sohaila Al-Balushi, Asset Planning Manager from Nama Water Services. I'm so excited today to present Nama Water Services Master Plan and the CAPEX program for the upcoming 3 years, started from this year, 2025, up to 2027, to outline our strategic roadmap for growth, infrastructure developments, and other added values. So this presentation will give an overview on the areas served by NWS and or covered by NWS, the NWS Integrated Master Plan for the upcoming 25 years up to 2050, also the CAPEX program as a short-term plan for the next 3 years, and finally all the related benefits and added values associated with this CAPEX program. Currently, NWS is served whole Oman except Dhafar. So the 10 governorates is under NWS scope. The whole governorates in Oman, the 10 governorates is under NWS scope to provide water and wastewater services. We have produced water through the desalination plants and the well fields for around 1.2 million cubic meter per day. And also, currently we have 59 STPs with a full capacity of around 273,000 cubic meter per day. We have a total network length for around 24,000 kilometers in water, and for the sewer networks for around 5,200 kilometers to serve our customers. Our customers in water is around 798,000 customers in water and 251,000 in wastewater. Moving to the integrated master plan, in the past we have 3 master plans, 1 for water and 2 in waste water. And during 2024, we had a project for 1 full year to update and give a full review of these master plans to come up with the 1 integrated master plans. This study has been conducted through our partner, Sorika Muscat. The master plan was driven based on the main drivers, and the main driver is the Oman Vision 2040. It is our national vision, and it has a lot of objectives related to the water sector, mainly related to the coverage, increasing the connectivity, and reduction of NRW. And the integrated master plan was designed to be aligned with the Oman Vision KPIs and Oman Vision objectives. Also, we have our national strategy, which has been finalized and completed by the ministry in 2024, and all the outcomes from the strategy has been captured in the master plan. We have our own strategy and projects in Oman Water Services, which are already considered in the master plan for the upcoming 25 years. The master plan, it's integrated master plan, and it is for sure impacting the whole water sector because it's considered the whole water business and the NWS scope. It's very important for our stakeholders, for the water resources, and to sort out the environmental issues. It's improving the asset performance and asset management as well. It's impartial because it's based on the national objectives, and also it captured the whole water business as water, wastewater, and TSE. The project has been conducted in 5 stages. It started from the desktop study, and at this stage, there was a data collection, a meeting with the stakeholders, and analysis of this data, moving to the planning parameters and the preliminary master plan. Then in stage 3, it is a technical study. It's more about the water demand calculation and the hydraulic modeling. In stage 4, it's the investment model and the implementation plan, and it was more related to the financial part. And stage 5, it is the final master plan. The outcomes of this integrated master plan, or our master plan in summary, it includes 410 projects, 139 projects, 139 projects in water, 192 projects in wastewater, and 79 projects as a combined projects between water and wastewater, which cost around 11 billion Omani riyal. This is in line with our KPIs, or our national vision objectives, is to reach 96% as a coverage in water in 2040 and 75% in wastewater also in 2040. Moving now to our CAPEX program for the next 3 years, starting from this year up to 2027, and this is a short-term plan for the next 3 years to implement the projects as a price control period. We have 2 separated CAPEX programs. One is for water, and the second one is for the wastewater. So for water investment program for the next 3 years, it includes around 131 projects. Some of them are ongoing from the recent price control, and some of them are in the initiation and the planning stage. These types of projects include all projects as consultancy services, construction, networks projects, transmission, and all related water sector businesses. So we are expecting to have around 10,000 kilometers as an added network length after the implementation of these projects, and also some of the assets will be added as a pump stations or as a reservoirs as well, and we are expecting to add more reserves in our system for more than 2 million cubic meters per day. We are targeting around 25,000 customers as in the initial connection, with around 6% increase yearly. This is the total capex of this program is around 800 million Omani riyal for the whole projects. For the wastewater projects, from this year up to 2027, we are expecting to have 119 projects. Some of them are ongoing, and some of them are on the planning stage, and includes all the distribution systems, the main trunks, and the STPs. We are expecting to have a total network length for around 1,600 kilometers, and around 30 STPs will be added to the wastewater system. The initial customers, targeted customers, around 62,000, and by increased 2.6% annually. The total capex for this project is around 480 million Omani riyal. Of course, all of these huge capex programs in water and wastewater were mapped with the benefits related to the society and whole water and wastewater business. The benefits are the water coverage. We are expecting to increase our water coverage up to 75%. This is in comparison to the electricity accounts. And the wastewater coverage will reach around 31%. Also, there will be the in-country value and local contents added after the implementation of the CAPEX program for more than 190 million Omani riyal. As I said before, the number of connections in water and wastewater will be more than 180,000, and the network length will be around 12,000 kilometers in water and wastewater. The reduction in RW will be around, for the next 3 years, around 6%, as per, this is in line with the Oman Vision KPIs, and also we have our more aggressive KPIs internally to reduce more. There are also other benefits related to our CAPEX program, like the enhancement of water quality, because the CAPEX program includes the construction of some laboratories in different governorates to enhance the water quality. Also, some of the projects are related to the operational performance, like SCADA projects, reduction of NRW through the implementation of the rehabilitation program, and compliance with HSE requirements, which is very important, enhancement of the system resilience and water security. We have 2 interconnection projects to connect three different governorates together by a full transmission system. We have also the aquifer storage reservoir projects. This is the first project which will be implemented in this CAPEX program. The ASR project will be implemented. It's in the tendering stage to enhance the system resilience and the water security. Also, improvements of our asset database and asset information through some projects related to GIS survey and asset register. This is all from my side. Thank you for your attention.
Thank you, Sohaila, for this valuable presentation and information given about NAMA water services strategy in the next 3 years, which is, a collective effort for the potable water and also for the wastewater. So thank you again, Engineer Sohaila. And we welcome our next presenter, Cyril Plinton. Cyril Plinton will talk about strategic planning for water infrastructure, ensuring continuity and resilience. Cyril is, if I announce the name correctly, I hope so, a water engineer and country manager in Siroka, Muscat, with over 20 years of experience in water sector. His experience spanned from water planning and hydraulic study to a contract management and work supervision. Has contributed to a numerous master plan, France and Oman, including the integrated master plan for NAMA water services. He have a master degree in civil engineering, hydraulic and environment from ENS E3 France. So join me to welcome you. The mic is yours.
Thank you, Dr. Salim. Thank you, everyone, for coming, for joining. I am Cyril Bleton, and I'm very happy to present to you today one of the topics we treated during the Integrated Master Plan is the strategic planning for water infrastructure. Which button, you know? This one? This one? Yes, so I'm also the general manager of Soreca, Soreca Muscat. So Soreca is a consultancy branch of Veolia, and we've been operating in Oman since 2011, mostly in the water, but also in the wastewater, of course, and also in the energy sector. So what I'm going to present to you today is really deep diving. You saw those graphs just recently. So yes, we completed the Integrated Master Plan for Nama Water Services, which was a great project and very interesting project. And I'm going to focus really on the strategic for the water planning of the IMP. So first, before deep diving, we look to the past, and we look at the past 10 years, for which we have a nice data record and a very interesting water balance to analyze. So first, as Suhaila said, as of today, there's 24,000 kilometers of network for water only. And there's been a very significant investment in the past 10 years. It's been multiplied by 3. So it's from 8 to 24,000 kilometers. So it's a massive investment into the water development of the networks. In the meantime, what we can see on the right is a snapshot of the water balance over the same period, over the 10 years. So we can see that the production, the system input volume, so the water that's been put into the water system has been doubled, multiplied by 2. But unfortunately, the level of NRW has been multiplied by 3 in the meantime. So it shows also the level of effort that is to be taken at the same time as the network development for the asset management and NRW subject tackling. A bit on the same subject, over the same period of 10 years, the number of customers has been multiplied by 3, although the total consumption volume has been multiplied by 1.4 only. So this is important for the master planning to look backwards, to know where we are coming from, what's been the trend, and it's also helping us to know better and to understand better the current challenges of NAMA. So NAMA, sorry, one of the main challenges we could see on the water sector, on the transmission and distribution, is a very vast network, and it's scattered, sorry, an intergovernmental system. So it's, if you look at the picture, at the graph, on the diagram on the right, it's a vision with altimetry of the different governorates which are part of the interconnected system. And you can see that some governorates are very high in altitudes, and most of their water is conveyed from the coastal area where you have the desal plants. So there's always a bit of contribution from the well fields or some internal water sources. Nevertheless, you can see those orange arrows which are representing the water transfers which are intergovernmental. Why it is on elevation? Because we know as water engineers that to convey water is costly and high demanding in energy, especially if you go far or if you go in altitude. So this is an important matter to have in mind when we consider the water system of NAMA. It is very vast and it has a lot of operational channels. We can evaluate roughly that 50% of the water in NAMA travels more than 50 kilometers. So it has a high energy consumption challenge and operational challenge. So now that we have seen the past and the current situation, we have to look at the future. And to look at the future, we look at 3 particular aspects, okay? So same, okay, we look also to the production capacity. So it's the current production capacity. You can look at it on a holistic approach. Globally, the total water production has increased also. So today we are reaching 1.2 million cubic meters per day of production of water. Nevertheless, the
capacity of production of the main desal plants is higher than that, is 1.5 MLD in 2024, and we have new desal plants which are coming. So those main desal plants, they are contributing, but almost 90% to the water demand, because there's still a contribution of the well fields for approximately 12 to 10%. And those well fields are strategic. My predecessor presented it. Also, it's very important to keep those well fields. Even if it's not for the day-to-day production, it's strategic assets that are to be preserved and maintained and known better, because they are playing a key role in times of peaks or for the resilience of the system. Oops. The second important aspect that we will be looking at is the storage, because the benefit of water is that we can store differently from the electricity. So what we looked at specifically, it was the storage situation. It's a key resilient component for the water and for the strategy. Currently, for NAMA, there's 4.4 million cubic meter. So it's, if you look globally, it's corresponding to 64 hours of the water demand. Unfortunately, but it's designed like that, it's not very evenly distributed around the network. And in fact, we have the 10 largest storage sites, which corresponds to 50% of the total capacity. So what we've been looking at in the master plan is the distribution over the wilayat. Sorry, the graph is maybe not readable, but it's for each wilayat. We have assessed what is the number of hours of storage that is within the wilayat, so maybe a reservoir within the wilayat, or those strategic storage which are contributing to it. So we can see that some wilayat have less number of hours of storage, but this really depends on where you are, because if you don't have a storage, you may have alternative source of water which bring the same level of resilience. A third aspect, which is then going to the future, we look at the horizon 2050, where, as Suhaila mentioned, there's a forecast to have a population increase doubled by this horizon. So this directly converts into the future water demand, which is increasing. We also include the climate change impact, both for mitigation and adaptation, in order to have in mind to have a better and more resilient water system altogether. So also this was taken into consideration for the location of the future desal plant proposition. Then it comes to what we do with the current asset, the future demand, and the current situation. Okay, we worked on those three pillars that I've been talking about. So the desalination plants, the transmission system, and the storage distribution. There's really, for when we talk about the strategic planning for water for NAMA, it's really important to keep those three running together. It's like bringing stability. If you just consider two, your seat may fall, okay? It's really important. So we look at the storage and the distribution as the demand, and we need to bring the water to this area. Currently, most of the network is there, but in fact, the water demand is increasing, so we have to adapt those existing transmission lines and to propose new transmission lines or to upgrade the pumping stations. We also need to increase the volume of storage to bring the proper level of resilience. And we have to align those transmission systems with the desalination plants implementation. As we saw, we have some desalination plants which are under construction. And one of the most difficult challenges for an operator like NAMA is to align the new desalination plants which will come in operation rapidly. Over one day it comes in operation and start producing 300 MLD, and to properly dispatch this amount of water to the network, to the distribution networks. So this is why the tool of this simulation is very interesting. So we evaluate different solutions. In addition to that, with the idea of the resilience, we have proposed new locations for the future desalination plants to be closer to the population and to the demand, and also to bring resilience. In case, as we know, some environmental events can happen, cyclones, algae blooms, jellyfish, or pollutions. So the coast is vast enough and the population is spread around it. So we have proposed two new locations, one in Chinas, one in Musana that you see in white, and the associated water transmission infrastructure to be deployed progressively as the water demand is increasing and the need arises. So this is very important to have this three-pillar association. Oops. And then the master plan, but Suhaila highlighted it also very well. So I'm focusing here just on the strategic investments for the upgrade of the existing assets to meet the future demand and the future requirements in terms of demand, consumption, and NRW, because we have to integrate this. In fact, the master plan encompasses so a lot more subjects, including the upgrade of the existing asset, the rehabilitation of the existing asset from reservoirs to pumping stations to networks to reduce the level of NRW. Expand, but with a logic, so expand together water and wastewater networks and make sure that we're not putting too much pressure on the wastewater part of NAMA by overdeveloping the water and forgetting a bit the wastewater. So that's called the integrated extensions. And we have put by priorities all those projects. And then we have prepared maps by governorates so that NAMA can implement those projects by governorates and know what's the plan. It's very important to also know the plan so that it's also possible to share with the Ministry of Housing and the other stakeholders, which will depend also on the water supply. That's it for my presentation. Thank you very much. I want to thank NAMA, the team from the planning department, for their great support on this project, and also the team of Soreka. Some of them are here. So thank you very much.
Thank you, Cyril, for your informative presentation, especially about the continuity and resilience. You highlight, the water storage and the interconnection between the regions. So thank you very much. And that will take us to the next presenter. Our next presenter is Francisco Suruz. And he will talk about the finance model for water infrastructure, evaluating suitability and economical impact. Francisco has a degree in business administration and management from University of Oviedo in Spain. His experience includes more than 15 years in the field of international construction infrastructure. He worked as CFO in Eastern Europe, Poland, and Hungary in the civil construction and infrastructure sector, and continued his stay as a country manager in Poland, developing a business with opening of a new venture for the award and execution of a different construction contract. So welcome. Let's go.
Hello, good morning, everyone. Just to check. Okay. Good morning. Nice to meet you, all of you. My name is Francisco Suárez. I'm the regional CFO for Yesinima. Our company landed in Oman almost 5 years ago when we have been awarded for two key projects for us. That was Barca 5 and Gubra 3. I would like to make a summary. All of us, we are, familiarized with the investment and financing of these kind of projects. But I would like to do, a short introduction in order to improve our business, because at the end of the day, it's very important for us to work with all of our stakeholders and our off-takers, that in that case is Nama Water. So I would like to thank to all of you, Oman Water Week, for this Greenwich event, as well as to start talking about that the water is not just a resource, it's a right, a necessity, and it's a cornerstone of national security. For that reason, it's very important to do this kind of exercise, all of us together, in order to start working together. Talking about the clean water is a right and it's a challenge. Across the globe, access to the clean water remains a challenge, not due to a scarcity of the solutions, but a scarcity of the sustainable for financing. I want to emphasize that it's very important to combine what is related to water services and what is related to financing. Financing, at the end of the day, is something that we need to be careful, because it should be work together with the nations, it should be work together with the stakeholders, and should be working together as well with the lenders. We must rethink financing, not as a burden, but as a strategic opportunity to unlock growth, innovation, and resilience. All of us, we can be, let's say, familiarized with the typical financial modeling that we are having in our business. To finance the asset is the BOT, BOO, DBO, or DBFO, but it's important to highlight that more than the best financial modeling or the best investment strategy, it's important to understand where we are, which kind of necessities has the country, or which ones are the regulation and strengths of the country. For that reason, here we took the opportunity to work with all of our lenders that in all of our projects are based in GCC. This is very important to highlight as well the support from your banks, from Omani banks and GCC banks. Coming back to the financial instruments, it's very important to highlight as well that the public and private partnership is the key point in order to continue growing up together. Blended financing, leveraging concessional funds to attract a private capital is the key as well.
Bring better efficiency to providing a service. Not all PPPs work, so we have to be very careful. And as advisor, as I've been introduced, I've been working in this sector for 30 years, advise a lot of governments on how to do PPPs or how not to do PPPs. And it's important to realize that not all projects work as PPPs. So we have to be very careful in selecting the right project, the right characteristic. The size of the project matters. The time horizon matters, the market characteristic, and the market readiness. When I do advise government, I spend a lot of time hearing how the market will react, i.e. doing what I call a shadow bid. And that's what we did for Nama Water recently. We looked at how will the market react to these opportunities, how would they price them, how would they finance them, how would they operate them. So that's very important to go into the market with a well-prepared game plan. Otherwise, people will bid, or not bid, and if they bid, they may bid on assumptions that are not correct. What's important as well is balancing the risk. The private sector cannot take all the risks in a project. So you have to spend enough time to dissect the risks of a project and then make sure that these are the ones that are being transferred are the right ones. Otherwise, the private sector may not bid or they may price it too high. Typically, government should retain some of the risk in a PPP. Now, this is a lot of motherhood statements, but they're very important. And people might think this is very simplistic. It's not. What's critical is we need to find efficiencies that come out of PPP. Otherwise, why would you do it? You have to find access to financing. And we've seen a lot of projects Don't get to the market and nobody shows up because the financing is not there. The right size, the right lenders, the right equity players. So it's important to make sure that PPPs have access to the financing and financing instruments. As Francisco mentioned earlier, PPPs are long-term contracts whereby the private sector is taking life cycle risk on a plant. Typically in the water and wastewater project, we're talking about project between 15 years and 35 years, or even 40 years. So therefore, the private sector is incentivized to look at different life cycle solutions, not the cheapest EPC contract necessarily, could be more, but I'm saving on the maintenance and replacement cost. So all of these trade-offs are being studied during the planning stage and not delayed till year 5 and year 15 and year 25. Typically, and it's been well documented, if a project is done as a PPP, it's been delivered faster and on time and on budget, typically. The planning stage to launch a PPP takes a longer time, i.e. studies, going to the market, procurement stage, takes longer. But once you sign the contract with a PPP developer consortium, then the clock starts ticking, and it's usually, and it's been statistically, and there are reports on it that says it's faster than a typical procurement, but takes longer at the beginning. Ability to bundle is a very important characteristic of a PPP. Bundling different assets. Sometimes projects are too small to put them on their own, so you bundle them with other assets. That could be a way, or as well as looking at geographical areas. I've done enough projects in Canada where the municipalities could not do PPPs on their own. We did the regional municipal council for 6-7 municipalities. They went all to the market together and went and got PPP delivery that way. Obviously, the private sector has specialized. All the people from the private sector, they always innovate, look at technology changes. So the private sector brings that innovative approach, and they are there to be delivering an outcome. So these are some of the benefits of PPPs. Typically in the water and wastewater, and this is nothing new to you guys and ladies, you are paying a tariff. The tariff is made up of 4 components, typical 4 components for water projects, power projects, wastewater projects. And the 4 components are the capacity charge, which is how much I'm gonna to recover all my costs. There is a fixed operation and maintenance cost that I have to recover. There is a variable operations and maintenance cost that is linked to the volume that has been treated in case of water and wastewater. And then there is an electricity cost that is typically borne as a risk by the government. While it could be a pass-through, or it could be, but the government bears the electricity cost. The private sector bears the consumption of the electricity. As has been mentioned by Francisco and others, these are different models, the BFYM, BOTs. These are different types of public-private partnership that should be implemented if they make sense. On average, a PPP project in utilities is 25 years. And that's what we're recommending to NAMA to go into the market for the 3 STPs. I was asked to give examples of recent PPP deals in the region. I have 4 or 5 from GCC and 2 or 3 globally. I'm not going to spend a lot of time on them. As I said, they're all in the presentation deck. One of the few ones that I was early involved in them in Kuwait. It took a lot of time to bring to market. It took a lot of time to sign the contract, but finally it is in the market. It's being commissioned as we speak. So it's one of the biggest in the market as PPPs, 500,000 cubic meter of sewage treatment plant, and it's significant, and it's going to go online very soon. The first one that went to market was in Taif, and it's a smaller plant, 100,000 cubic meter, and it's being commissioned as we speak as well. And it's typically the government, in this case, is Saudi Water Partnership Company. I think the CEO was here yesterday who spoke at the conference. He is the one representing the government and in relation to the private sector who's delivering the service. It's been operational for the longest in the market in STPs in this region, in the GCC. So I picked it because of that. So it's a smaller plant, 100,000 cubic meter, but it's been operational for many, many years, and it's been working very well. There is one in the market that I'm working on. It's in Egypt. I picked it to talk a little bit differently than a typical STP. This is not actually an STP. This is a project I've been involved in for 15 years. Not the sludge part, but the actually Abu Rawash 1.6 million cubic meter of treated water. It's the largest in the region. I've been involved in the expansion of Abu Rawash for the last 15 years, and recently I've been advising the government of Egypt on how to go and do the sludge treatment plant as part of that. That RFP is in the market as we speak. So it's different than treating water or treating the sludge and what to do with the sludge and how to maximize the income to the government from the sludge and bring in the private sector who can innovate into that. So the whole idea is you have to find different solutions for different issues. You cannot find something that works in one country and say it's going to work in another country. This is a unique for Egypt. We're doing a lot of opportunities for fertilizers coming out of the sludge. May not be the same characteristics of fertilizer that will be in the GCC countries, but that's an Egyptian solution. I brought another example from Kazakhstan to show as well, in some countries, there are organizations that are funding projects that are different from banks. In this case, there'll be some donors or there'll be some multilaterals, World Bank and others who might be participating in it. And finally, my last example from the US, just to round up the globe here in terms of opportunities. This is purely private sector risk, and it is very much into like a long-term contract to provide water. So these are just some examples of how PPPs has worked. Here are some of the trends we see in the market. First, obviously, everybody is around here understands this issue of stricter regulatory environmental controls. And not only we have the authorities and we have the companies, but there is a lot of drive to make sure that we have very tight control over the environment. Technology is becoming more and more important. And when you do PPPs, you can buy that technology leapfrog faster than you can do it on your own. Because these companies that you're hiring are leading edge. They do research and development. So you're buying not only building an asset, you're buying as well technology, intellectual property for future technology advancements. We are seeing in the market as well a higher level of government participation, i.e. some financing that is coming from a government through setting up a special purpose vehicle where the government could be an equity player, or the government is providing certain guarantees, as will be the case in the sludge project in Egypt, because the sludge will not be enough to recover all the costs. The sludge revenue will not be enough. The government will be backstopping what will be the difference, as an example. What we're seeing as well in the market is the rising role of the private sector. I know there's a lot of private sector people here. I've met several of them throughout my career, and they're eager to do more business, but they have to do the right project. So it has to be the right project, the right characteristic of a project. From the latest work I've done in this sector, in the utilities and water and wastewater sector, there's a very high demand and appetite by the private sector to be involved in it. We just completed for Oman Water, as part of our planning for the 3 projects, an extensive market sounding. We spoke to 10 to 12 participants in the market, and they were all very interested, but they all said the same thing. Make sure it's the right solution, the right project, the right risk appetite. Finally, I was asked to make a couple of pronouncements about the projects we're working on. I'm glad I see a lot of my colleagues from Oman Water here who are working with us, and I'd like to thank them for inviting me to speak at this and thank them for their hard work for the last several months. I'm glad to say we've completed the feasibility study on 3 sewage treatment plants, one in Sib, one in Ansab, and one in Amrat. So I'm going to just share with you some highlights of these projects and tell you where we are on these projects. So as most of you know, in Sib, there's a current plant of 82,500 cubic meter of sewage treatment plant, and the whole idea is to extend it by 250,000, an additional 250,000 cubic meter. We have done the feasibility on it. We're at the last steps of the feasibility, and we are about, with the approval of NAMA, hopefully in the next couple of months, to launch the RFQ into the market. And the RFQ into the market will be for somebody, a private sector consortium or a company, to come in, take over the existing plant to operate it, as well as expand the plant into the future to bring it to a capacity up to 250,000 cubic meter. UNSAB is a smaller plant. Currently, it's the largest plant as operational. As we call it, the brownfield is 225,000, but the expansion into the greenfield is about 100,000 cubic meter. It's the same idea to bring a private sector firm to come in, take over the existing plant, and expand it by another 100,000 cubic meter of sewage treatment plant, and then over a long-term 25-year contract. The last one is a little bit challenging. It's a smaller plant. It's the Al Amrat, which is currently is at 18,000 cubic meter capacity, and a lot of you probably know about it, as well as the expansion is smallish. It's only 36,000 cubic meter of expansion, creates some challenges, and that's what we're looking at. Should we bundle this with something else to make it appealing to the market? And we spend a lot of time looking at that. So basically, this is what I wanted to share with you, that PPPs are something that work, but they have to have the right ingredients, and they have to have the right quality of counterparties, in this case, the government, and the other case is the private sector. And thank you very much.
Thank you, Ibrahim, for sharing this information about PPP project. Very interesting and informative presentation. Our next speaker is an added value to the project, we can say. Our next presenter will be Engineer Islam Saleh. He is a leader of the brine mining research group, Saudi Water Authority. He will talk about the sustainable management of desalination plant brines. Engineer Islam Al-Wazani holds a bachelor degree in mechanical engineering from King Abdulaziz University and has over 10 years of experience in water technology innovation, institute and research advancement. Throughout his career at WTIRA, he has held various roles, including reverse osmosis engineer, senior reverse osmosis engineer, researcher, and deputy manager of the research osmosis. His work focus on the design and enhancement of desalination plant system. So join me to welcome Engineer Islam.
Assalamu alaikum. Good afternoon, everyone. It's my pleasure to be here in Oman Water Week. Let's start by my presentation title, which is Sustainable Management of Desalination Brine Plant. I can return back. Okay. Achieving sustainable management of brine is no longer an option. It is a necessity dedicated by environmental, economic, and social responsibility. Today I will share with you some of our practices to handle the brine, and some of innovative solution could open a new horizon toward sustainable future. I will focus in two key areas. First one is brine disposal and environmental monitoring by ensure responsible disposal of the brine and preventing marine ecosystem. The second area, it will be brine reduction through resource extraction by turning the brine to a valuable resources and promoting circular economy practices. If we apply those two strategies, we will increase and enhance the sustainability of desalination plant. There are three major points we should consider before we discharging the brine back to the sea. The first one is salinity increase. I will discuss it in the next slide. Temperature increase. And this problem more related to the thermal desalination plant. And we can coming over this problem by mixing the brine from thermal desalination plant with the brine from the RO plant. Usually the brine from RO, it's only 2 degrees more than the seawater temperature. Also, we can discharge the brine in a discharging channel and give it sufficient time to cool down, or mix it with seawater before we return it back to the sea. Third point is toxicity due to chemicals. We need to moving toward more environmental friendly chemicals based on organics, not relying on traditional chemical which is based on phosphonates. Also installing sensors and monitoring system to make sure the concentration of those chemicals not exceeding the environmental limits. The mixing zone, it's the area where the dilution process taking place. We can exceed water quality standard within the mixing zone, but we should meet it at the boundary of the mixing zone. Based on our practice, we find out that 2,000 ppm or 5% is a typical limit for salinity at the edge of the mixing zone. With a typical radius varied between 100 to 300 meters. Also, the user working to improve the efficiency of the mixing between the brine and the seawater. We can increase the dilution by using a multiple board diffuser to spread the brine over a wide area. Also, we can increase the turbulence by using a high velocity jets. And the angle jet aboard diffuser can prevent the brine to sitting on the seabed. The location of the mixing zone and the direction of the diffuser should be located in a strong current area to improve the mixing quality between the brine and seawater. After controlling the discharge of the brine, the monitoring is very essential to make sure we're not exceeding the safety limit. One of our innovative solution is an autonomous service vehicle. We can monitor the seawater quality and the discharge brine quality, where we can collect the samples and measure some parameters remotely. The vehicle can measure up to 12 parameters like pH, conductivity, DOC, dissolved oxygen, chlorophyll, etc. We can also attach an auto water sampler to collect a sample from different depth. The auto sampler can hold up 12 samples at one time. Okay, moving to the second area, which is brine reduction through resource extraction. Our motivation coming from the quality of our brine, the quantity, and the concentration. We don't need to invest any primary capital cost because we consider the brine as a byproduct of desalination process. If we take overlook on the seawater content, we will find that 95.5% is a fresh water, and 4.5% is a salt. Most of it is sodium chloride, but there is a magnesium, calcium, potassium, and some rare minerals. There are abundant of high valent dissolved minerals in seawater, and it's getting more concentrated in the brine. Some of those salt and minerals are feasible to extract from the brine, but there is some factors affecting that, like market price of those salt and minerals, the concentration in the seawater, and the capital and operating cost to concentrate and harvest those salt and minerals from the brine. To make the brine stream valuable, we need a high purity products. How we can achieve the high purity? By concentration and separation. The nanofiltration technology play a key role in both the separation and concentration. In our dual brine concentration system, we take the treated seawater as a feed to the NF system. The NF system will divide the stream to two different streams. One concentrated with monovalent ion, and the other stream will concentrated with divalent ion. The monovalent ion will send it as a feed to the RO unit, which allow us to increase the recovery up to 53%, because we already get rid of the ions that causing the scale. After the RO, we will have the fresh water, and we will have the brine. Both the brine from the NF and the RO will send to OA RO system, osmotically assisted reverse osmosis, where we can concentrate the brine from both the NF and RO more. In the conventional seawater RO plant, usually the recovery is varied between 40 to 45%, and 55 to 60% will return back to the sea as a brine. But by implementing our brine mining technology, we will increase the recovery up to 65%, which is 40% more in water production. Also, we will have two concentrated streams, one with the high valent ion, divalent ion, and one with monovalent ion. The monovalent ion, like sodium chloride, bromine, potassium, rubidium, lithium, and the divalent ion, calcium, magnesium, and sulfate. By reselling those salt and minerals, we can offsetting the water production cost. Right now, we are in process to establish a demonstration plant at Hagal desalination plant. And in this plant, we will produce 6 tons of high purity sodium chloride and more than 100 kg of magnesium metal and 6 kg of liquid bromine. The plant construction work will start at the 4th quarter of this year. But what about the energy consumption? In this graph, we can see the relation between the energy consumption and salinity. The solar pond, it's consume around maybe 0.8 kilowatt per meter cube, less than 1 kilowatt. But the thermal crystallizer consume more than 60 kilowatt per meter cube. Our MPC system, membrane brine concentrator system, only consumes 16.75. But what is the advantage? It's not only the lower in the power consumption, but we can have a high purity product, and we can select what we want to extract. We succeeded to produce a high purity sodium chloride with purity over than 99.4%, which is suitable for chloroalkali industry and pharmaceutical and a lot of chemical industry. Also, one of our success stories is Al-Shaiba NF magnesium plant. Magnesium is very essential to human health, and the lack of magnesium have the same effect of smoking cigarettes. We have some studies with Al-Imam universities, and they already approve the effect of the magnesium in diabetes, blood pressure, and the efficiency of heart muscle. Al-Shaiba plant produce 400,000 cubic meter per day. And alhamdulillah, we succeed to improve the product water quality from a Shaiba plant by increasing the magnesium concentration more than 15 ppm. And this is done through a multi-stage NF system with internal dilution. The plant in operation since May 2022, and the cost to increase the concentration of magnesium is 0.01 to 0.02 US dollar. So it's like 1 to 2% from the total production water, total production cost. Also, we have a succeed demonstration plant to produce calcium carbonate vatalite type. There is a 3 different type of calcium carbonate: calcite, argonite, and vaterite type. The vaterite type has a high economic value comparing to calcite and argonite. It's used in different industries: paper, rubber, pharmaceutical, cosmetic, and medical. We need a 3 main components to produce calcium carbonate vatalite type: the brine from the installation plant, and the cement killing dust, CKD. It's a waste from cement factory, and carbon dioxide, and we can utilize a carbon capture technology to get the carbon dioxide. As so far, the calcium vatalite is only produced on a lab scale because it's not stable. It can easily change from vatalite phase to calcite phase. But alhamdulillah, we succeeded to produce calcium carbonate vatalite type with more than 98% purity. The plant capacity 50 ton per year, and it can store also 22 ton of carbon dioxide. Right now we are in process to start a commercial plant with 100,000 ton per year. Also, it can store more than 45,000 ton of carbon dioxide. Our work is not to stop here. We targeting more salt and minerals like potassium chloride, rubidium, magnesium sulfate, and magnesium carbonate. Also, we use high salinity water to grow algae. And this algae, we can use the algae cultivation technologies and get more product like which is used in the cosmetic and fish farmer and etc. This is the end of my presentation. Thank you for your attention.
Thank you, Engineer Qasim. I'm Isa. Islam for this presentation about the brine and how to make added value of the brine. Different product, different need, and transfer from a risk or environmental problem to opportunity, for mining such element. Allow me now to ask all the presenters to come to the board for questions and answer. Just going through, this session. The first presentation about desalination in Oman, an overview of a key desalination plant and their impact by Engineer Khawla Al-Barawani. Nama Capex by Engineer Suhaila. And also strategic planning for water infrastructure, Serial Benton. Also Francisco, financing model for water infrastructure, evaluating and economical impact, Francisco. Public-private partnership by Ibrahim Akawi, and brine water fertilization in GCC country, brine water mining by Engineer Isam. So we'll open now, for the question. If anybody have, question for our presenter, is most welcome to ask. And organizer, please provide the mic for all the audience. Yes, engineer. The mic here, mic here is first. Yeah, please. Here. Please introduce yourself and ask the question.
Yeah, thank you very much. This is Dr. Intasar Salimi from Oman Water Service Company. I have a question for Francisco or Abraham, perhaps. What is the best option of PPP framework in terms of contracting agreement that have lower risk to the buyer company as a government, and also a lower risk for the payment tariff for the customers? Is it like a long-term operation maintenance agreement, or lease agreement, or concession agreement? Thank you.
Thank you very much for the question. It depends. I said that in my presentation. So dissecting the project will give you that answer. I'll give you a generic answer to that. Typically, most of the water and wastewater projects or utilities projects are done under like a BOT type of an arrangement. Call it concession if you want to call it concession. But at the end of the day, the government is the off-taker. Especially in this part of the world. In Europe, it's a little bit different with deregulated utilities sectors. But in this part of the world, in GCC specifically, it's all under a concession type, whereby the government is the off-taker and buying a service, in this case, kilowatt hours or cubic meters of water treated or desalination, and paying for that tariff. What they charge at the end, the customer, is irrelevant. That's a political decision to subsidize or not to subsidize the utilities. Typically, these are 25-year contracts. Yes, there are some that are shorter, but with shorter tenor, it does not give you the best efficient life cycle solutions, because what we try to do in PPPs is ensure that the private sector has at least one opportunity to renew the asset, rehabilitate the asset. Typically, it has to be done over a longer horizon. It's at the end of the day, the tariff that makes the project bankable. Now, as far as risks and risk retained by the government, under a PPP, specifically and more particularly under what's called the project finance, not corporate finance, the government has a large role to ensure the sustainability of that company that was set up for the project called an SPV, Special Purpose Vehicle. In this case, the government or the government entities has to provide certain guarantees, not only payment guarantees, but termination guarantees. For whatever reason, the government has to step in, because at the end of the day, the plant has no value outside the remit of the plant to be producing water or wastewater or electricity. So it doesn't have any salvage value to go and sell it in the market. Unlike buildings or government offices, that could have some value at the end. So government has to step in through what we call a direct agreement to ensure that this project is sustainable, as well as to ensure that if there are any defaults by the private company, the government steps in and takes over the plant and pays the balance of the loan, for example. These are termination guarantees that come in over and above payment guarantees. Francisco, over to you.
Yeah, I fully agree with Mr. Abraham. At the end of the day, it will be needed to finalize in a detail which kind of volume of the project we are talking about. It's very important to understand as well the needs, geographical area. So I agree that we can provide a general reply, but should be depends of the needs of the country, of the taker, which kind of industry we are talking about, if we are talking about desalination, waste management, even though energy. So it's gonna depend. But I fully agree that it's very important to be focused on the needs and as well as the pre-financing in order to all the parties should be aligned and to work together. This is the key from my point of view.
Thank you, Francisco. Thank you, Ibrahim. Next question, please.
Hi, here. I would like to thank all panelists for their invaluable presentation. Dr. Abdel Nasser Mabrouk, consultant desalination and brine mining technology. My question, of course, goes to the Islam for his nice presentation and the good effort in Saudi Arabia for future desalination and how to use the technology for salt production technology. I have observed in your presentation using membrane brine concentration, you may reach about concentrate by membrane about 300 gram per liter. Actually, I have a doubt about this point because 300 gram per liter is almost you reach precipitation.
250.
200, not 300.
No. 250.
So now it's 250 because
yes.
Okay. Thank you to correct this figure. Because you almost touch the saturation limit. Very close to the saturation limit. And I think also even 250, maybe a little bit osmotic pressure will be high. I mean, so again, the pressure is...
The unit pressure, it's around 72 bar. Because we're using NF membrane, it's not RO membrane.
Okay, so a little bit lose somehow
yes.
In that case.
And we didn't have any scale event.
Okay, perfect.
Yes, because as you know, the NF membrane it's working different than the RO. So we're not reaching the polarization limit.
You are using NF as a brine concentrator or ahead
yes.
of RO?
Yes, okay. Yes. It's, we use it before the RO and after RO.
Okay.
But it's special NF type, not
I
the
know the structure
yes,
a little bit different for, I mean, maybe high flux, low salt rejection, that one. Okay, yeah. Thank you very much for this.
Thank you, Engineer Islam. Next question.
السلام عليكم ورحمة الله وبركاته. عبد الله أحمد الرشيد من إدارة أو هيئة كبار الماء من البحرين. سؤالي حق الأخت سهيلة. كم نسبة ال NRW في الووتر سيستم؟
تقصد في الوقت الحالي؟
في الوقت الحالي نعم.
تقريبا الحين في الوقت الحالي بالنسبة لي الووتر سيستم في عمان 37%. هي النسبة حسب الإحصائيات الأخيرة في نهاية عام 2024. وعندنا very aggressive target هذه السنة أن ننزل أكثر من كذا طبعا بكثير. على حسب national targets اللي هو العمان فيجن أن ننقص كل سنة تقريبا 2-3%. لكن internally we have more aggressive objective أن ننقص أكثر من كذا.
This is a distribution network or transmission network or both?
This is a whole in RW as a commercial and technical both.
السؤال الأخير. What is the process for using well water or whole water in the network? It is mixed with the destination water or direct pumping to distribution network?
Mainly it's mixed with the desalinated water, and it's used mainly in the emergency cases. We have some of the well fields, we are using it as a main source in some of the governorates like Al Boremi. But for the other well fields, we are mixing it with the desalinated water to have it as our source of water.
And the last question, please.
Okay.
How much the quality, or what is the quality of boreholes, or TDS, we say?
You know, it meets the Oman standard for water, and there is a regular check of the quality of the well fields through our quality department to ensure that it meets our standards.
Thank you. Next presenter.
Good afternoon. I'm Pawan. I'm representing Circulage 2 in Nepal. So my first question with NAMA is that case in the master plan, do you have any plan, and also related to Mr. Ibrahim, case there is a plan related to conversion. Generally the STPs are considered to be a cost center. So do we have any program or plan to convert that cost center to a revenue center? Any such of the initiative or technology improvement or investment model which NAMA is thinking of? And second question in the same pattern, is NAMA the future plan which has, is any plan to create any energy neutral plant into the new projects which are coming up? And then another question with Mr. Ibrahim is that you have suggested some of the projects which are being done with the NAMA on the PPP models. Is there any project in your view is coming out to be a produced water treatment segment where which is the water coming out of the well can be utilized to convert further into the growth or energy conversion? And again, that again comes to the cost center, to the revenue center model. So these are my questions. Thank you.
We'll start with the NAMA.
Yes, I might answer the first part of your question regarding the master plan projects. Master plan considered the centralized STPs for a large scale as for the urban areas, and also consider the standalone STPs for the the remote areas, and even for the small scale desalinated or the STPs to be a solution to increase the connectivity. But mainly for the urban cities and the urban areas, we have the centralized STPs with the stated capacities. For the how we can procure this STPs, now already we started to find different types of procurement model, like the PPP as Mr. Abraham presented. We started with the first 3 main STPs here in Muscat to be as STPs, and this is our direction, is to float all the big STPs with a capacity for more than 20,000 cubic meter to be for the private-public partnership.
Ibrahim,
yeah,
you want to comment?
I mean, your questions are more for NAMA. I cannot, these are policy questions. So unfortunately, I don't want to dive into this. I might get into trouble with my client here. So it's probably better for somebody at NAMA to answer the questions on different models that are being used. Apologies. I can talk to you about other countries, what they're doing in the West, but I cannot opine on NAMA.
Yeah, maybe I'll jump in also on the aspect of the revenues. For the STPs aspect, for example, what we've included in the master plan, for some of the biggest STPs to include anaerobic digestion and possible revenue coming from the gas and the energy that you can get from the biogas. There is also, for the energy aspect, the provision of land use to anticipate the solar panels. We can see it's widely implemented also for GS Inima and Barca in the desalination, but it can also be very interesting to be used in the wastewater treatment plants if the land use allows, of course. And finally, and maybe most importantly, is the TE, because today we don't really realize, but the wastewater treatment plant is not a water treatment plant, it's a plant where you produce water, which is fresh water, and this fresh water here in this country, it's gold. So today, it's not yet gold, but this TE is future gold, okay? And we know about this, and the quality of the treatment that is envisaged allows you to benefit from this gold for the sector, for agriculture, for industrial, and for other uses. So yes, the TE is really a big source of revenue in the future of the master plan and the assets.
Thank you, Sir. Yes, it is a gold. I mean, we have two aspects, I mean, out of the TE, which is, I mean, as you said, the treated water, and also we can produce an energy out of these STBs. Yeah, so we don't have much time for, I mean, question. One last question. I think somebody from the back or here.
Hello.
Okay, so I will give you the mic, I mean, for the last question.
My questions to Engineer Suhail al-Blushi regarding to the desalination plants in Oman. How many well fields here we have here in Oman? Well fields.
Yeah, we have.
So in case of if any circumstances or something like this, we can use the well fields.
Yeah, we have many well fields in Oman. I don't have the exact numbers, but the total capacity of the well fields that we are depending on daily is around 100,000 cubic meter per day. And all of these well fields are, in line with the Omani standards and drinkable, and it can be used for human uses, for a domestic use. At least maybe for each wilayat, we have a backup for us, a well field to be used in emergency cases with this total capacities of around 100,000 cubic meter. Yeah. Yes. This is one of our projects now, is the safe yield assessment for the whole well fields in Oman. Already we started with the 3 main well fields, 2 in Al-Buraymi, 2 well fields in Al-Buraymi, because Al-Buraymi as a governorate is fully depending on the well fields, and Wadi Aday as well. We have this study, and already the consultant started to do this water balance assessment and safe yield assessment for these 3 well fields. And also now it's in the tendering stage to float a tender to assess the whole water quantities for as a safe yield assessment for the other well fields as well.
Thank you, Engineer Sehela. By this question, we will come to the end of this season, of this session. The session about strategic and economic viability in water production, investment, and partnership. The session go through, water security, water project, PPPs project, and all other important and informative information sharing. So if you allow me to thank all our panelists for their effort, for their presentation, and for you also for your listening, and thank you very much.
Thank you, Dr. Salim, for the excellent moderation. And we invite you all to have a group picture. Then we invite you to give them the appreciation certificate.
Sure.
Please.
First picture?
أيوة, first picture. starting with Khawla Al-Barwani. Okay, please. Can one more picture? Sorry. Perfect. سهيلة البلوشي. سير بيلتون. فرانشيسكا سواريز. أبراهام عكاوي. Engineer Salam Saleh Al-Wazmani. Thank you all. Now we will have a break for prayer and lunch. We are starting the next session 2:30 inshallah. We'll meet you here again. Thank you for attending. صبر علي. أعرف إنه أحسن شخص يتحرك، بس خلنا أشوف كم كرسي هناك. We will start after 5 minutes, inshallah. Assalamu alaikum. We will start session 3. It will talk about enhancing water operation, resilient networks, emerging residents, and infrastructure integration. It will be chaired by Dr. Muhammad Al-Saidi, Assistant Professor, University of Technology and Applied Science. Please welcome to the stage.
Thank you. Assalamu alaikum. Good afternoon, ladies and gentlemen. Welcome to this highly anticipated session, Enhancing Water Operation, where we'll be talking about resilient networks, emergency preparedness, and infrastructure integration. I hope my voice is fine. Usually they say I'm lousy. Is that okay? Okay, thank you. My name is Muhammad Saidi. I'm delighted to chair the session today. Over the next 2 hours, we will be exploring innovative strategies and technologies that are reshaping the future of water management. From smart infrastructure to AI-driven solutions and sustainable systems. So we are privileged today to have an outstanding lineup, and I mean it. When I was reading their bios, I was stunned with their expertise. And we are lucky to have them today because this will explore the sector of water management from different perspectives. So we will be having speakers today. Each will bring a unique expertise and perspectives from across the water sector. And please allow me to read them out for you. And here I need to use my tablet for that. Mr. Benjamin Ernst, Director of Digital Operations at Zeus. Correct? Yeah? Thank you. We'll discuss the optimization of water networks in Oman. And then we will have Engineer Noura Al-Mandari, Investment Manager at Nama Water Services, will share insights on national strategic projects, management and construction planning with focus on hydrogen. And then we will have Mr. Mark Jarrett, Regional Head of Utilities at GF Course Piping System, will present on advanced piping systems for efficiency and sustainability. Then we will have Sarwat Nasser, Head of Business and Product Support at Wilhelmina, where she will talk about smart pump system solutions. And then we have Mr. Bora Halvaji. Correct? Thank you. My Turkish started to improve. Okay. And he is Water Industry Development Manager at Siemens. He will introduce an AI-based approach, which is very interesting, because I didn't know that it can be predicting the blockages in wastewater networks. And then later, we will have Dr. Slavako Velikov, Global Water Industry Director at Bentley Systems, INC, and he will be exploring also AI-based digital twins for infrastructure efficiency and resilience. Then we will have a talk by Engineer Khalid Lawati, who is the General Manager of Customer Experience and Metering at Nama Water Services, where he will speak about security of supply and enhancing customer satisfaction. And then we will end up our session with Dr. Atif Belhaj, International Sales Manager and Geospatial Technologies, expert at Bahar. I'm trying to spell it, but it was difficult for me to read it out. So excuse my pronunciation. Barthauer Software GmbH. And we'll discuss sewer network inspection using BASIS, which I think BA system, status at, and the AI-powered Sarida system, which I will be interested to hear about that more. So following the presentation, we will open the floor for the questions and have a panel discussion. So therefore, we encourage you to jot down any questions you may have and engage actively during the QA segment. So let's start with our first speaker, Mr. Benjamin. The mic is yours. Thank you.
Hello. Yeah, so we got a packed house at the moment, so I hope everyone's taking photos to tell all of your colleagues about all of the interesting technologies you're going to hear about this afternoon. Am I loud enough? I'm good? I'm good? Cool. So my name's Ben, and I represent Suez. I look after some of the digital innovations that put Suez among the most qualified companies in the region for water network design and operation, for desalination, and for treatment. And today I'm going to talk to you about optimization of water networks in Oman and in the Arabian Peninsula. And we find ourselves in the middle of the fourth industrial revolution. And just over the course of the current decade, in the past few years, the prevalence of artificial intelligence and digital innovation in our daily lives has exploded. Barely a day passes these days that we don't consume a service or buy a product or are exposed to some kind of a message that's generated and powered by these solutions. So it's remarkable when we look at water utilities across the world. Barely 25% of water utilities have really applied artificial intelligence in any meaningful industrial capacity. So I wonder, what is it that's holding us back? In a world where production costs are high, demand, of course, is growing, and water scarcity is still a problem, and environmental sustainability is more celebrated than ever and more critical than ever. What is it that's stopping us as an industry from enjoying the benefits of these technologies? So to answer this question, we had a look at some of the unique demands of this region, of Oman, of the surrounding countries. We wanted to understand some of the important technologies that can bring value to this area. So here, unique in this region, we find the desert dunes bordering on the lush wilderness, and that's right next to the urban environments. And in fact, Oman is almost unique in the world in its diverse geology and the diverse climate that comes with that. And how many cities in the world need to deal with the crippling drought followed only months later by devastating floods? And there are still 200,000 people in Oman without access to safely managed drinking water. And that's a focus of Oman Vision 2040 and the United Nations Sustainability Goals. So it's more important than ever that our investment is being spent in the right areas and that it's being spent efficiently. As a nation, we made a commitment to reach net zero carbon emissions by 2050. We recognize that the effect of global warming is affecting our country and that we need to respond to that. We know that over the coming decade, I should say, we're going to need more water production, we're going to need more clean energy, we're going to need lower cost energy, and we're going to need lower carbon emissions. So we looked around the world for cities that face similar challenges to Oman, and we looked for examples where they used optimization and where they used digital innovation to improve the service that they're offering to their population. The first technology I wanted to talk to you about today is media heuristic algorithms. Now, this is a very old field of artificial intelligence. It's about 60 years old, and there are about 400 water utilities around the world that are using this technology to great effect to improve on their water network design. Media heuristic algorithms take inspiration from processes that occur in the natural environment. They take inspiration from how animals solve problems, how nature solves problems, how chemistry solves problems, and they apply that inspiration to diverse fields like water network design. So for a successful optimization, we're looking for a hydraulic model of the network. We're looking for an algorithm that's been tailored over decades of operational and modeling experience. And we're looking for the scalability of cloud compute. And we also need the expert supervision of the hydraulic modelers that we have internally to the utility. And I'm going to put the process of media heuristic design in contrast to the traditional method of doing, say, a master plan design. So traditionally, when a water utility is designing their master plan, they're going to be presented with a limited set of designs to choose from. So in this example, we put 3 plans up there on the board. These are 3 designs, and the utility needs to choose the level of investment that it wants to make over the next 10 years. So our first design is the bare minimum. It solves the bare minimum of problems in the network, very low cost. The design on the right is the Lamborghini, the premium design. It solves everything, but it's out of your price range. And the solution in the middle is a balanced design. It's somewhere in between. And this is typical that you have a limited subset of designs to choose from. Now, I'm going to take these three designs and I'm going to plot them on two objectives. So here on this chart, the vertical axis is the performance of our design. It's the performance deficiency. That means that the good designs are low down on the axis. The worst designs are higher up. So we want those designs that are lower down. The horizontal axis is our level of investment. So it's how much CapEx and OpEx we need to spend over the 10 years, 30 years to achieve that design. Now, we're going to look at how the meter heuristic algorithm solves this design. Our hydraulic modeler has sat down and done 200, 300, 400 hydraulic evaluations to reach these three designs. They've spent a good amount of effort reaching these designs. And along comes the meter heuristic algorithm. So these evaluations in yellow, these are the automated evaluations. And they're not random, but they are intelligent experiments. Each one is learning from and improving on the successes and failures of its predecessors. At the end of that process, we select the best plans across that range. So now you have the best design that could be implemented for each possible investment level. Now, instead of having 3 levels of investment to choose from, you can choose any level of investment that suits your project. You can look at the shape of that trade-off curve and you have the data available to ask questions about the trade-offs that occur along that curve. You can ask, what happens if I can invest a little bit extra? What do I compromise if I spend a little bit less? Using that information, you go along and you can choose the level of investment that suits the project that we're working on. So Scottish Water in the UK used this process to design a wastewater network. They were able to produce designs in days instead of months, and they achieved a reduction of 12% on their overall CapEx and improved the environmental impact of the project by 20%. Here in Macau, they designed a potable water distribution network, and they were able to improve the non-revenue water by 20% with no further investment in CapEx. And then in Doha, they designed a stormwater network and they were able to demonstrate a 90% improvement in the flooding volumes. So, what do we know about meter heuristic algorithms? We can apply them to irrigation networks, to potable water networks, to sanitary networks, and to stormwater networks. They'll typically achieve a 5 to 15% improvement in the CapEx outcomes and a 10 to 20% improvement in the performance of the network. So, one more technology to talk to you about, and this is machine learning. Now, there are many applications for machine learning, and in this case, we're looking at this algorithm to help predict the asset failures that occur across the breadth of a water network. The algorithm takes into account all of the attributes that we have available about a pipe. In particular, things like pipe age, the material, the diameter, the manufacturer, the contractor that installed it, and the date of the installation. It takes into account the history of failures in the pipes across the network, and it takes into account the topographical and geographical information, like the locations of wadis, the distribution of soil types throughout the network. And it takes into account hydraulic information from the model, like history of pressure that has affected each asset. So with this approach, we go from a world of replacing whole DMAs at a time based only on complaint history to replacing those elements that are more likely to fail and more consequential when they do fail. And then we take those planned renewals and we package them intelligently so that each contractor, when they're going out there they're replacing a compact selection of pipes. This process allows us to be 40% more efficient than alternative approaches and 200% more efficient than just replacing whole DMAs. Now, when Denver Water did this analysis, they set aside a pilot area of the network and they monitored that network for 7 months. During those 7 months, there were 17 asset failures, and 16 of those failures were accurately predicted in advance by the machine learning algorithm. At WSSC, they were able to evaluate and compare a vastly greater number of design scenarios, and the solution that they settled on was ultimately 30% more CapEx efficient and improved on the community impact by 90% in their design. Portland was able to develop a renewal program that was 25% more efficient than the alternative approach, and using that approach they were able to increase the community benefits of the projects by a factor of 3. So what do we know about machine learning? This approach allows us to renew assets more intelligently than just using design life or complaint density or the risk-ranked approach. We're replacing just those assets in a more targeted fashion that are likely to fail and that cause consequences when they do fail. This way, it makes our investment more targeted and our efficiency is 40% better than any alternative approach. So, over the course of 15 minutes, we've looked at the unique demands of Oman. We've learned about a couple of key technologies that bring value here. We've learned about machine learning, and we've learned about meter heuristic algorithms. So next time you have the opportunity to hold a glass of water in your hands, I invite you to reflect on the investment and the governance and the care that went into making that glass of water possible, the continued investment that we'll need to make for that to be possible for our grandchildren, and the artificial intelligence that hopefully will make that task a little bit easier. My name's Ben. I'm from Suez. I hope you enjoy the remaining presentations for the afternoon. Thank you very much.
Very interesting presentation, and I'm sure that there will be a lot of questions for you. And what I like, the precision of timing. 15 minutes, lovely. So please welcome our next speaker, Engineer Noura. Just brief them about yourself, please.
Assalamu alaikum wa rahmatullahi wa barakatuh. Good afternoon, everyone. I am Noura Al-Mandhari, Investment Manager from Oman Water Services. And currently I am NWS Team Leader for Green Hydrogen Project. And I am delighted to welcome all in this presentation, which will be about National Strategic Project Management and Construction Planning. And I will focus mainly for Green Hydrogen Project. So as we strive to transition to low carbon economy, the green hydrogen has emerged as one of the energy solutions. So in today's presentation, inshallah, we will walk through the framework that will deliver this national project forwarded. We will see how the Oman Water Services Company will be one of the leaders or one of the national companies that will ensure the delivery of this project, and how the sustainable construction practices will deliver this project in our commitment. So let's start. The agenda of this presentation will include 5 major items. I will give you a brief about the vision of a green hydrogen project. Then we will move to the structure of this project and what the rules of Oman Water Services will be. Also, we will talk about the integration hydrogen with other national companies and the construction of this project, and what's the phases of construct this project. Also, we'll stop a little bit for the policy and regulation side, since the project is non-regulated business. And I think the most important slide of this presentation will be about why the government of Oman is insist on this huge investment, and what's the economic impacts to the country. So, the government of Oman has ambitious target to be one of the top leaders around the world of green hydrogen production by 2030. And for this national objective, we have 3 targets that we have to committed on. First target will be on 2030, and the government has to produce about 1 to 1.5 million ton per annum of green hydrogen. The other target will be 2040, and the government has to produce from green hydrogen about 3.5 to 3.75 million ton per annum by 2040. And by 2050, we will reach to 7.5 to 8.5 million ton of green hydrogen. And as you are aware that this production of green hydrogen will require certain capacity of renewable and electrolyzer. And from this table, you can notice that the capacity of renewable definitely will be almost double of the electrolyzer capacity. So for this purpose, 3 zones were selected for this green hydrogen. The zones are Duqm, Dhofar, Al Ghazar, with a total area of 50,000 kilometers. Why these areas? Because the availability of wind energy and solar energy. Priority number 1 will be at Duqm, then Dhofar and Al Ghazar. At Duqm will have 5 clusters. Each clusters will be designed for maximum 3 blocks. So in Duqm we'll have 5 clusters with around 15 blocks. In Dhofar we will have 10 clusters with around 26 blocks, and Al Ghazar with 5 clusters with around 12 blocks. And to approach the approved target by 2050, which we have to produce around 7.5 to 8.5 million ton of green hydrogen, we have to awarded 40 blocks from all these total blocks in 3 zones. So if we focus on 2030, 8 agreements are awarded in different 8 blocks. So we will able to achieve our target by 2030. 5 in Duqm and 3 in Dhofar. And the important thing that I want to highlight is that the market for green hydrogen will be export for certain markets like Europe and Asia. And a certain amount of this production will be utilized locally here in Oman. So what's the structure of this project? In 2022, the government established a new company called Hydrogen Oman, Hydrom, and the main role of this company to lead the green hydrogen sector. And the details of this role will be in next slide. So the production of green hydrogen will require infrastructure, and we adopt the concept of common use infrastructure. This common use infrastructure consists of 3 packages. Package number 1 related to power package, which is electricity and other assets. Package number 2 for hydrogen will include hydrogen pipes and storage tanks. And package number 3 will be for water sites and will consist of desalination plant and transmission pipeline. And who will build these 3 packages? 3 national companies are selected, okay, to be leader for each package. For electricity side, OTC, Oman Electricity Transportation Company will lead electricity side. For hydrogen side, OQGN will lead that part. For water side, Nama Water Services will lead the package. Actually, 2 packages for Nama Water: desalination plant and the transmission line system. So because this project has a different nature rather than our regulated business. It's almost will be non-regulated business. It's agreed that to establish SPV for each package. So will be a special purpose vehicle company for electricity side, other SPV for water side, and other SPV for hydrogen side. And these SPVs will own these assets, and on later stage they will do maintenance, operation, and any expansion network in the future. So one of the elements that will derive this project to success here in Oman, that we have clear sector structure. And all the rules and responsibilities are defined. So each company or each concerned authority know what's its rules and responsibility. For example, for designing policies and regulation will be led by Ministry of Energy and Minerals. The rules of hydro will be develop national strategy for green hydrogen, delineates lands for development projects, also manage auction process, awarded blocks for the developers, and in addition to that, support offtake agreements for the developers. The rules of shared infrastructure, as I explained, will be led by national companies, Oman Water Services, OQGN, and OTC. Providing logistics services will be led by concerned authorities like Port of Dokum, Asyad, and Public Authority of Special Economy Zones in Dokum. So what's the schedule of this huge investment project? Will be in different phases. Phase number 1, starting from last year, 2024, up to June 2025. This phase is led by Hadrom and with close coordination with the national champions or national companies. The outcome of this phase will be finalizing the master plan for target 2030, 2040, and 2050. Also finalizing of pre-feed for Dokum and Wafar. This is from technical side. From financial and legal side, we already start building our financial and economy model, providing the bankability principles and financial strategy. Phase number 2 will start, inshallah, from June 2025 up to 2026. And the main milestone of this phase will be completion of detailed feed activity, and will start FID activities, final investment decision. In addition to that, secure of financing and confirmation of bankability will be the main milestone of phase number 2. This phase will be led by national companies, inshallah, with close coordination with Hydro. Phase number 3 will start from June 2026 up to 2030. The main milestones is funding the projects of green hydrogen and start construction works, and up to 2030 we have to commission the assets and be ready to provide water quantity to the developers. And this phase will be led by the new SPVs that will be established for each package, in addition to close coordination with Hydrom. So, integrating green hydrogen project will require definitely coordinate efforts. As I mentioned before, this national project will be as a stone corner of the national strategy. And to put this vision is in a reality, we have to focus on what's called foundational elements to be ensured that we can committed and deliver this project by 2030, 2040, and 2050. So we have, if we start from the bottom, the investment, of course, significant funding is the backbone for any national projects. Moving to clear regulation, will definitely support the growth of the project infrastructure, as I said, common use infrastructure, and we will see later why we adopt this concept, what's the benefit of common use infrastructure, will be as a physical backbone of the project. So what I mean by common use infrastructure, this is blueprint of the project. Here we call downstream, and here we called it, we named as upstream. In reality, the distance between downstream and upstream is more than 1 kilometer. So we will start with here. Here we will build a desalination plant with certain capacity. The capacity should be confirmed by the developer, how much water, quantity of water they are needed to produce the green hydrogen. And this desalination plant will be operated by substation, which will be built by OTC company. From this desalination plant, we will build water transmission line, go upstream up to certain locations. And from that locations, the developers will construct their assets to take the quantity of water. The water will go to the electrolyzer, and from that electrolyzer, they will produce green hydrogen. Then the hydrogen will be transferred from upstream to downstream, here to storage tanks, and will be used even to export internationally to Europe and Asian markets, all to use as derivatives like methanol, ammonia, and other industries, all will used locally here in Oman. So why we adopt the concept of shared infrastructure? Because we are focusing on reduction of levelized cost of hydrogen. Also, it's create alternative for the national companies for revenue through the tariffs that will be agreed with the developers. Also will attract the FID through reduction of infrastructure risks, and also to develop ecosystem for infrastructure. So what's the rules for NEMA water services in this project? As I mentioned before, we have to deliver certain quantity of water through 3 stages. If we take, for example, a DOCOM, stage number 1 will be from 2026 up to 2030 or 31. We will construct a new desalination plant here. Here will be a new desalination plant in the north of port of DOCOM. From this desalination plant, we will lay a transmission pipeline to serve the awarded blocks. The green color is the awarded blocks at this stage, and here the other pipeline to serve this block. The length of this pipeline around more than 120 kilometers, and also will provide storage tank as security of supply. For stage number 2, we will lay another pipeline from here to serve the other clusters CO2, CO3, and also CO1, these clusters. And we will utilize the same corridor for stage 1 to lay this additional pipeline. And this maybe will need to make some expansion of the desalination plant. Stage 3, for DOCOM, we will lay other pipeline coming from other side to serve the rest of the cluster in DOCOM. For Dhofar, the same concept. We will construct desalination plant in Shuwaimiyya in the middle of Dhofar and Al Ghazar to serve both zones. And here we'll lay a transmission pipeline to serve these awarded blocks for stage number 2. Stage number 3, we will lay other pipeline. We'll lay other pipeline to serve other clusters, Z2, CO2, and CO3. And stage number 3 will also laying other pipeline to serve the rest of the cluster in Dhofar. In addition, we will lay other pipes to serve Al Ghazar. Here Al Ghazar will be more clear for you. For Al Ghazar, there is no clusters will be provided by water quantity in stage number 1 and stage number 2 because of the lack of infrastructure in Al Ghazar. There is no port in Al Ghazar. So we put priority number 1 for Ad-Dukum and Dhofar. But in stage number 3, which will be from 2040 to 2050, we will utilize the desalination plant in Shuwaymiyah and lay this pipeline to serve cluster number 1 and 2 in Al Ghazar, and other pipeline to serve the clusters 3 and 4. So the main chief milestone up to date, we already finalized the master plan for all phases. Pre-feed activity is completed for Ad-Dukum, and maybe by next week, Hiram will share it officially with us. And we also start working on Dhofar pre-feed activity. From financial and legal side, bankability, economic and financial model, financial strategy, risk allocations, how to mitigate the risks on the project, all are in progress with close coordination with other national companies and also with the coordination with the OIA, Oman Invest Authority. And maybe the main achievement for us that the first term sheet was signed on 29 of January from this year with the GEO Consortia. So what about the policy and regulation side? I already explained to you the structure for the sector. The project will be ring-fenced. And the license we get it from the regulator is light license. About the standard Nama water service, already we have strong and safety standards that complies with the environmental policy and regulation. In the next coming weeks, we will sit with the developers and we will see if there is any need of for any enhancement of our standards or develop new standards. This will be with coordination with the developers. About the permits, Hiram already take the lead to establish ecosystem for any NOCs or permits that will be required from the developers. So the developer no need to go for each concerned authority to take the approval or permits. So the main question why the government of Oman is insist to invest in this project. Because the economic impacts several sectors. For example, if we take the energy generation, the value chain will be for on solar panels and wind turbines, and definitely on electrolyzer. If we go for common use infrastructure, the value chain will be for all packages, hydrogen package, water package, and electricity package. What's the opportunities for this? Will be component and equipment manufacture can be shored. Raw materials can be developed here locally in Oman. If we go to the sector of hydrogen industries, value chain will be definitely for refining, steel, shipping, and chemicals. And the opportunities will be on the products can be exported or utilized here locally in Oman. In the side of green hydrogen derivatives and fuels, the value chain will be for ammonia, methanol, and other derivatives, and the opportunity will be that the Oman can be a commercial and logistic hub for green hydrogen. So this is the presentation, and I hope that I give you a clear picture about the rules of Nama Water Services on green hydrogen projects. Thank you.
Thank you, Engineer Noura, for this informative presentation. Usually, whenever you have a chance to visit a museum, for example, and to look into the ancient manuscripts, usually they refer to the water as purity, calmness, transparency, and secret of life. And what stimulates your thinking more when you come to the modern age, you will notice that around the globe, a lot of professionals are actually working to make that true. Humanity understands that the availability of water is an indication of wealth, fairness, and security. And a lot of professionals around the globe actually working on this. In such events like our events, you will be surprised with the amount of efforts are put to that drinking water comes to our table. So we will go thirdly with Mr. Mark to give his speech.
Thank you very much, and thank you all for being here. My name's Mark. I'm the head of the business unit infrastructure for George Fisher Corries in the region. I've been in piping systems for 43 years, since I was a small boy. The first 18 years in a foundry, making metal piping systems. The last 25 in plastic. I love metal. I say my heart is metal, but my head is plastic. Because sometimes plastic can do things metal can't. I want to give you a quick overview of sustainable piping systems and maybe treat it as a menu. If you see something interesting, come and talk to us, because I'm sure we can help on your projects. Quick introduction to George Fisher. I think it's important to give you a feeling of where we are coming from. A bit about sustainability and asset integrity, and then just some training, new training scheme we offer now in Oman, in UAE, for installers. The logo Plus GF Plus is very famous. It's known throughout the world for quality, sustainability, safety, security. The company is more than 200 years old. We were founded in 1802 in Switzerland. There are not many 200-year-old companies in the world, so I think it's important to understand that. And at the bottom here, we have been making piping systems since 1957. So we have a long history of making plastic piping systems. The company last year turned over 4.8 billion Swiss francs, which is $5.6 billion. Probably one of the largest companies in terms of piping systems in the world. We have four groups: piping systems, building flow, casting solutions, and machining solutions. Casting solutions, if you're driving Mercedes, Audi, BMW, Bentley, you're already using many components we produce for these companies. Piping systems is where I'm from, obviously. We have 2 billion Swiss francs, or $2.3 billion turnover last year. We are active in more than 33 countries, more than 40 production sites in the world, 8,300 employees. If we look at the map, we are global. We have facilities in America producing to American standards, facilities in Japan to Japanese standards, in Europe, obviously to ISO, European norm standards. But that's a breakdown. You can see Europe's still our biggest market. America's, Asia growing. The rest of the world, where we call Oman now, is still a significant amount of business for us here. Our businesses are focused on 2 sectors. Each of these sectors have impacts on our lives, everyone sitting here, industry and infrastructure. If you stopped and thought for a minute how many pipes you've used to get here today, you might be amazed. Imagine if they weren't there. It's something that many people don't realize. Ducting, cabling, water, it's all part of our life. It's important to understand the sustainability aspect of piping systems, because if we don't now, our future generations will be impacted. Our company is known as the #1 brand in engineering, piping systems for industrial applications. In areas like semiconductors, chemical processing, water industry, marine, data centers, food and beverage, energy, life science. All of these impact us all here. We are supplying key industries in this business. Another example there, you can see on the left, application segments that we're supplying. We supply automation solutions in terms of valves, sensors, for piping systems also. The area I'm specialized in is the utility infrastructure. We have water distribution, gas distribution, wastewater, stormwater, and industrial infrastructure solutions, providing a full range of products. And some of the applications you can see here, from water to gas to fire mains, these are what we are supplying for our infrastructure division. In November 2023, we made a big decision. George Fisher purchased our local partner here in Oman and in UAE, And we are now an Omani-based company. We have two factories in UAE, one in Dubai, one in Abu Dhabi, and one here in Oman. So we see a great future in this country. We see ways we can help and support the people of this country in providing sustainable piping systems. As a company, we contribute to sustainability. It's a word we hear a lot of, and I thought the other day, what does it mean, sustainability? We hear it every day. What does it actually mean? And I did a bit of Googling. Sustainability means that meeting the needs of the present without compromising the ability of future generations to meet their own needs. So what we're doing today should not impact our grandchildren and grandchildren's grandchildren in the future. Sustainability means balancing economic, social, and environmental concerns to ensure that resources are used responsibly and efficiently. Very important. As a company, George Fisher, we are sustainably managed. Our goals support United Nations Sustainability Programme. We have environmental product declarations. We are regularly assessed by independent bodies working in sustainability, and we contribute to 11 of the United Nations Sustainability Goals. So we are very much into this. You saw our map where we've got production plants around the world. We really care about what happens in all the countries we are working in. 3 years ago, we were voted one of the top 10 sustainable companies in the world. A big honor for the company. We've been following sustainability for many years, but this was a Wall Street Journal, a bit of research. We came in at number 9. That's a great honor for George Fisher and something we're still trying to maintain today. In terms of plastic pipe systems, we contribute very much to sustainability. A lower carbon footprint, the metal. So just by using plastic, you're already contributing to saving CO2 emissions, for example. Longer durability, 100 years lifetime, maybe more. Lower transportation, because the lower weight means you can save on fuel. We support green building standards. Materials are recyclable. So after 100 years, you can take the material out and recycle it into some other plastic product. We have all the life cycle assessment and environmental product declaration. So plastic on its own contributes very much to sustainability. If you look at the CO2 emissions, this is on a DN80 pipe, but you can see plastics are really at the bottom here. Sorry, this one. Polyethylene, ABS are much, much lower than the metal ones on the left. So just by thinking and adapting plastic into your projects, you are making an impact. Not that you might feel or realize it, but there is an impact there to be had. In our world today, there are many things that are driving development of businesses and people. Climate change, we all know and hear about that, but if you see here, climate-friendly cooling could avoid as much as 400 billion tons of greenhouse gases. Urbanization, air conditionings are expected to number 5.6 billion, but that will have a negative effect on the CO2 emissions. Water scarcity by 2030, that's only 5 years away. The demand will exceed supply by 40%. So it's critical we manage our water networks, because if not, this will be a problem. We won't be able to have a shower in the morning. It's coming soon, we don't realize it. Age infrastructure, another one. Water utilities produce 345 billion litres every day, cost of 39 billion a year. Just dripping away money that we need to do something about. Aging population and workforce, 150 million old workers have a pressure on social life. So we need to be aware and we need to focus on these trends that will guide companies and us in the future. Every piping system should be considered an asset. And the asset integrity of piping systems is very important. I've traveled the world in my 43 years, and everywhere I've been, I've seen this. Everywhere I've been. I've been South America, Middle East, Europe. You see wasted water. It doesn't need to be, but that's what you see. If you see a tap in the bathroom, it starts dripping, dripping, dripping. You can always turn this tap off or get it fixed because you can see it. But just imagine now this is not a tap, but it's a pipeline underground. Same amounts. I put it in litres in case you're metric. But this you won't see. This can go on for years and years and years and years until there's suddenly a new pool and the children are playing in the road in a new swimming pool. That's our issue. Until this water is visible, nobody cares. So we need to do something about it. As a company, we are producing obviously a lot of plastic piping systems, more than 100,000 products. If you think of a piping material today, we are making products from it or to connect to it. I say that because if you look at Dubai in the UAE, most of their network is asbestos cement. We don't make asbestos cement products, but we make products to repair it. We make every single jointing system you can think of. Someone said to me, well, what does that mean, Mark? It means that we can tell the truth. 200-year-old company, more than 60 years experience in plastic. If you have an application, doesn't matter what it's for, we are able to tell you which material is best and why. Because not always PVC is best, not always polyethylene is best. We have a lot of experience in helping people select the right material. And we produce full systems, pipes, fittings, valves, machines, tools. So there is nothing missing in the actual offering we can do. Different materials for different applications, full systems. Asset integrity, the typical iceberg, that's what we see. But behind the scenes are many things that can impact asset integrity. The application, I spoke about material. Do you really have the right material for that application? Is that why it fails every 10 years? Let's see, we can help. The quality of raw materials, the pipes, fittings, manufacturers, QA processes, all impact asset integrity. Non-compliant materials, we see many cases where there's been tenders issued, but the material supplied to the stores of the asset owner is not what was specified. It's a big problem. Site installation errors, this is also a major problem. People not knowing how to install, one of the key issues we have for asset integrity. And some owners' processes also not promote the security needed to guarantee asset integrity. George Fisher as a company, we are able to help along this path, prevent, save, sustain and succeed. If you take a typical project, there are different stages along the project, so I won't read them all out. And there's certain milestones as the project develops. And along that journey, there are several stakeholders that have parts to play, decisions to make, installers, distributors, and the key one, the asset owner. Now, we as a company can help in all these steps by offering services that not many others can do, such as making sure you first choose the right material, the chemical resistance properties, the performance lifetime. We can help support that. If you're engineering services, stress analysis, using software designed for plastic pipes. CESA 2 is designed for metal pipes, but we see many engineers using CESA 2 on a plastic pipe system. It's a different thing. Digital libraries, carbon footprints. We can give you calculations. If you change now to plastic, you will save X kilometers by plane or hundreds of trees. We have an online tool that will help you. Energy efficiency, cost savings, CSI specifications. Training we will come back to. Custom off-site production, NDT, non-destructive testing of thermoplastic pipes at site using ultrasonic NDT detection. The world first. Jointing technology machines, and once you're in operation, there's a hotline you can call if you have a problem. We have maintenance and repair products, process automation, pressure management, retrofit. We are now just introduced a new design of butterfly valves, dimensioned exactly the same as metal. So when your metal butterfly valve does not work, and that will happen, you can take it out and put a plastic one into place. So many things there, 25 things that can really help engineers today to make sure that the sustainability of their piping system reaches the required standards. And obviously pipes and fittings is the last one we have. They all fit in each one of these issues. We have solutions. And if you're interested, come and talk to us. We're in the exhibition. We can help, we can support, and give advice to make sure that your project does really work. Training. This is the biggest issue in plastic piping systems. We have a piping system that will last 100 years. We have products that are sustainable, CO2 compliant, but we still hear of leakages, failures, leakages. And in all the countries I've been, I've always seen this as an issue. And we as George Fisher offer very high-class training. It's something other manufacturers do not, unfortunately. And then there come issues with installation and leakages and failures that the asset owner has to pay for. Now, we have, as George Fisher, have just signed an agreement with the Swiss Welding Institute that offers third-party accredited training. It comes from Europe. We're offering it now in the region. There is an organization in Europe called DAC. It's Germany, Austria, and Switzerland. They have the same training course, all three of the countries. If you're qualified in Austria, you can go work in Germany or Switzerland. We are offering now for welders, contractors, installers, the same level of training, certified by VKR. And this, for me, is the most critical thing with plastic pipe systems. The courses are, let's say, it's been an issue for many asset owners in the region. We've now got this cooperation with VKR, so we have been trained instructors here. We have a training course. We're going to build one in Oman as well. That's coming in the next few months. And we will train people to Swiss standards. And I guarantee you will see savings of water loss. The reason the issues are very clear. Unqualified personnel carrying out welding. I've seen it in many cases in many countries. Poor and incomplete equipment to do the welding. Planning and calculation errors. Low willingness to invest in traceability. We have technologies that can tell you who welded that fitting, on what time, what date, what place. It's there, but not many people take it on board. Non-compliance of requirements of international service and standards, and indifference of quality, lack of awareness, and half knowledge. Oh, I'm an expert, I can do it. It's all issues that cause failures. Lack of regulation by asset owners is also a key one, because they allow anybody to come and maybe weld on their project. We don't need to do that. We must enforce training and education. VKR, this is the, I won't read it in German, but it's the Swiss Association of Plastic Pipes and Fittings, founded in 1981. They've trained more than 8,000 people in Switzerland, and we now have an agreement to offer the same level of training here in Oman. And I guarantee that you will see great savings in water loss if we do that. It's the same as the Austrian and German one. They have SKZ and Wi-Fi in Austria, same organization, and it's well accredited in Europe. When you do the training, you'll get a certificate, signed, stamped, and a QR code on the certificate. You can actually scan and read. It takes you to a website in Switzerland to check if that certificate is valid. Training certificate is only valid for 2 years, according to ISO. We have also a welder badge. So each trained welder will have a badge. This barcode can be scanned into the welding machine, which then puts his name against every single weld he makes. You have also the QR code on the side there to actually cross-check. So if you have inspectors going to project sites, you can check this guy is the right guy, he's been trained, and his certificate is valid. You have a unique ID number, etc. So it's traceable. And if you are traceable, you will do a better job, because otherwise you will have people chasing you for replacement, etc. So it is prevent, shine, save, sustain. It's need 5 steps. Prevent application errors, weld failures, and non-revenue water loss. Shine, training, education, the right specifications, the right machines and tools. Save time, water damage, non-revenue water loss, money, image. Social media today can be very naughty. Oh, there's another leak on my road. Oh, there's another leak here. People put pressure on the asset owners because of leakages. Sustain company goals, piping systems made from plastic pipe materials and corrosion-free. Succeed, ensure optimum performance to make the asset an asset and not a liability. That must be the target. So as George Fisher, just to conclude, we can help all along the route. If you're interested, please come and chat with us. I'm sure we can offer some things that you will be interested in terms of planning, design, the whole route around the project. Just 2 last slides. I can't even read that, but Al Gore was the whole movie in 2006, and I love these words. Al Gore was a vice president of USA at one time, but he's made a movie, and in that movie he said, old habits and old technology. It means predictable consequences. So if we carry on doing what we're doing today, we know our grandchildren will still have the same problem. He also said, old habits but new technology, new ideas. Now we can do something. Now we can change. Now we can dramatically alter the consequences. And remember, each one of us have an influence on sustainability. Each one of us can make a choice to change the things we buy, the electricity we use, the cars we drive. We can make choices. Every one of us. The solutions are in our hands. We just have to have the determination to make it happen. We have everything that we need to reduce carbon emissions, everything but perhaps personal and political will. So we might think ourselves are quite small, but we can all make an impact. And I love this last slide. Dalai Lama, if you think you're too small, try and sleep with a mosquito. It will keep you awake. Thank you so much. It's been a great pleasure to be here again in Oman. And if you have any questions later, we'll be pleased to answer them. Thank you.
Thank you so much for this interesting presentation. Just continuing on the story with humanity and water. Just excuse me, I have one of my students here and he will tell you that I love to tell stories because I think it break the terms. I hope I'm not that boring, but I try my best. To continue the story with humanity and water, usually people are trying always to find the smartest way to provide portable water on the cleanest. And I consider myself as one of the luckiest people where I could really see at young age in some part of the world where people, they had to carry the water to wherever they live, whether for drinking and other uses, our hygiene uses. To be honest with you, at that age, my main concern, I was very excited with the skills when they put the pots on their heads and they have to walk, got up, got down, without that water spilling. But later on, I noticed that there is a lot of efforts. Coming to the new age, we see that also humans continue trying to find smarter way to make water safer and more available. So we will continue this learning journey with our fourth speaker, Sarwat, if she is available. Yes, I have been looking for you since the morning. Good to see you at last. So she will be taking the stage and she will be talking, just to remind you, about smart pump system solution. Would like to stand up or use this? Whatever you prefer. The pointer is that.
Thank you so much. This one? Okay. I guess I can keep this. Should I turn it off? If I don't, I can keep it. Okay. Good afternoon. Thank you for the introduction. I'm glad to be here with you to share part of our experience when it comes to the water solution, and how we at Willow are working continuously to, we call it driving water efficiency through smart pump solutions. So my name is Sarwat Nassar. I'm head of business and product support for Willow Middle East North Africa. I've been with Willow for more than 9 years already. I'm a mechanical engineer by trades. And so today I'm gonna have a quick introduction about the company, focusing on sustainability, of course. And I'm gonna highlight one of our recent most product in terms of smart solution. And to better understand when we say smart solution, high efficient pumps, where it takes us into the technology. Okay, I need to move this. This is going somewhere, right? I'm not able to use it. Yeah, I'm trying to, okay. So Willow, we've been since 1872, one of the premium leader in pump manufacturing and providing water solutions. We've been present in the market with our solution in building services, water management, and industry. And today Willow has more than 9,000 employees all over the world. And we are present in more than 90 countries with more than 17 production sites. One of the recent one was the inauguration of the expansion of our factory in Dubai. We can see that being present in more than 50 countries by production site and representative office also in Oman is to be more closer to our customers and to be more adaptive to the region needs and demands. When we speak our strategy, definitely we are today coping with what we call sustainability strategy. Definitely the previous presentation was also talking about it, same as before. So in our sustainability strategy, we've been nominated one of the 50 best sustainability and climate leaders And we got also the German award since 2021. We've been receiving the German awards for Climate Protection Pioneer. Also, we also signed the pact with the UN Global Compact since 2018, trying to drive our technologies, our development in product, and even in our, let's say, supply chain, working environment, and factories as well, to cope or to have footprints with these 7 out of 17 goals. When it comes to the strategy that we have, we are building our strategy based on 3 pillars, which based on them also we have our planning going through up to 2030, let's say. We say creating, caring, connecting. When we say creating, we're talking about the innovation in our product. We make sure that the development of our product, whether it's the product itself or the way we are developing it, whether it's R&D or production sites, is moving towards decarbonization and climate friendly. Caring, we are caring about being transparent in our product emission, in our power consumption, and definitely connecting by whether the connectivity that we're gonna tackle today with one of our smart product, or connecting via the relations that we have and the impact that we're leaving with towards our customer and clients. So kind of the recent achieving towards energy saving, we can say like 2023, we still didn't receive the 2024 updates. So we saved approximately 2 terawatt-hour of energy by our high efficiency pumps usage. We've been nominated with the EcoVadis with the Platinum Award. We also saved 67 tons of old pump by taking back the pumps and doing the reprocessing of it. A 17% reduction in Scope 1 and Scope 2 emissions since 2020 with our smart factory, zero footprint factory we have in Dortmund, and also our recently inaugurated factory in Dubai is also Platinum LEED and moving towards having zero CO2 footprint. This is also one of the examples by being very transparent about our product. We have declaration for life cycle assessment of each of our products. We have also some of our new high efficient pumps being having the EPD verification. And we have also in our tools that are accessible for all of our clients, the life cycle cost calculation for any of the pumps, whether it's the retrofit project, caring about energy, cost saving, or whether it's a new product for calculation of CapEx and OpEx. This has been done. And definitely by connecting, we also say that we've been very active about we advocate cross-border cooperation with many of the governmental and public affairs networking. If we look more closer about the water management, we've been speaking about clean water and wastewater. Definitely, in order to be able to deliver a clean water, we care also about the collection of the wastewater. So the wastewater collection, disposal, treatment is one of the main important things that we have in order to be able to dispose the wastewater complying with the, let's say, regulation, whether local or global regulations, environmental regulations, and definitely a tertiary or more recycling of the water in order to be able to be reused in irrigation or other purposes is also important. That's why today we can say that in our WILO portfolio, we cared a lot about developing our product in the wastewater treatment. We see that we have products that are covering the biological treatment, the collection and transportation of the waste, the treatment of the waste, the sludge treatment, up to the tertiary level of treatment. The innovation in the product is not only about having most creative product, but also caring about being there with our clients in the sizing in the proper assessment, not selecting any pump, bigger is better, or most cost saving in terms of initiative price in order to save as much as we can for the client, but at the end we end up in having a running cost very high or non-effective product implemented. So if we have also some figures about pumps, since we're talking about pumps, which is one of our main products, we can say that worldwide electricity consumption by 2024 reached 27,000 terawatt hour. Any idea about how much pumps consume out of this total electricity? No, it's a little bit too much for pumps then, 10%. 10% is the amount of electricity approximately used by pumps. So if we calculate this and we consider that we're adopting new technologies in the pumps with saving energy, let's say we're saving 50% of it, it's equivalent of 439 mid-sized coal power plants. So this is kind of most of it. How we gonna save energy in pumps? It's definitely we need to develop on the hydraulic side when we speak about hydraulic efficiency of the pump, having more solutions when it comes on the protection of the mechanical components that are more suitable to wear. But at the same time, also we need to develop on the electrical side, on the motor side, on the proactive maintenance, preventive actions on the pumps, not only on the pump itself. So in the wastewater transportations, our main challenges are when it comes to the sewage network. This is an example, for example. In Germany, we have 576,000 kilometers of sewer network, and 2.1 billion people worldwide are connecting to sewer network. We know that some areas are still not connected, which is worse, but even with the sewer network available, we have many issues and many challenges. And on top of that, all the waste that we go to the sewer network are not controlled. Whether it's a public use or private use, we can consider 500 tons of wet wipes, for example, in Sydney, are thrown every year in the water sewer network. So when we think about the challenges, we think about 3 points. I will, so maintenance, failure of the sewer network, the equipment that we're using in the sewer network are being exposed to unfamiliar material that are running there. Then we have the downtime of it. We have the power consumption, the maintenance, the replacement. All of these are challenges for us in order when we're thinking about how we need to develop our product. So if we're gonna think reliability, energy efficiency, connectivity, these were the main pillars that were the drivers for us when we start thinking about how to develop more into the wastewater sewage pumps. When we say reliability, as we're talking about pumping station, we need the pump, let's say, not to auto-function, self-function, but we need a very low downtime of the pumping station because it's a continuous inflow of sewer network. We need also that the pump won't be subject to clogging or wear in the mechanical component or need to be changed on a very short term. Then we need the running time of the pump to be robust. When we speak about energy efficiency, if we're talking about big pumping stations, we need to also understand that there is peak load, there is partial load. If the sewer networks are combined sewer networks with rain and waste, then we also have a high fluctuation of inflow and outflow. So we need the pumps to be operating at their optimum conditions in order to avoid overconsumption of power. And when it comes to the connectivity, pumping stations, definitely, we know that the pumping stations and the sewage treatment plants connected into SCADA systems. We need to be able to control the systems not to be present on site and into the pumping station all the time. And at the same time, we need to do a proper monitoring, and we call it preventive maintenance. Not only wait till let's say the problem is happening, and then we have to run there and try to fix it. So these are the main three components to develop the pumps. So in our technology, when it comes to the sewage submersible pumps, we introduced our new pump. We call the pump Rexa Solid Q. Solid Q is coming from the hydraulic design of the impeller with the Nexus intelligence, which is related to the connectivity of the pump. So we spoke about reliability. So this pump, I'll talk a little bit about regulations. So in the sewage systems, if we talk about regulations, European regulations at least, we still don't have, when it comes to the motor side, any regulation on the motor efficiency level. But if we look at the high efficiency, coping with sustainability, we need to be there. Even like in 2 years, I guess, there will be ERP regulations talking about submersible pumps, motor, but we are already there. We are introducing our permanent magnet motors for the pumps with IE4 and IE5. It is already controlled by an external VFD since it's a permanent magnet motor. I'm going a little bit too technical. And then this is one. When we talk about the connectivity, this pump, we call that it's a smart pump because it has its own brain. So it's a processor built in the pump where it will gather all the information, whether operation, running current, flow, and the readings will be also communicated via many features of communication and connectivity, either cloud, Bluetooth connectivity, building the original BMS systems that we have on the building, and so on. And when it comes on the reliability of the pump operation, we're talking about some features that we call self-cleaning, anti-clogging detection. So these pumps, as we said, they are pumping sewage with wipes, solids, and many other components. So they are very subject to clogging. When we say clogging, it means that the solids will get stuck in the pump and it won't be able to run, but the motor will keep running. So I'm gonna be consuming motor energy for wasted energy, and then the pump motor will overload. It's gonna need replacement, downtime of maintenance, all of that. So if we talk about the feature of the non-clogging, let's have this small video for the pump. First of all, hydraulic-wise, on the pumping systems, we speak always about hydraulic efficiency. So the higher the efficiency, the less I'm consuming energy for these pumps. So we developed what we call Solid Q. It's a very innovative hydraulic design of pump, of impeller for the pumps. It's providing higher efficiency above 80%. And the material is basically cast iron, and it's available in many other material with some special coating also to increase the smoothness and the efficiency. So when we say intelligent system solution, we are speaking about, this is one of the main features of this pump. These pumps, they operate in dry as a pumping station. The size of these pumps, they are available only for pumping station application. We're not talking about building services, residential solutions. So they operate in parallel. One of the pump can be the master pump and can lead the operation of the 4 others with interconnectivity between them. And when we say the non-clogging detection is that the pump, when it detects that there is a risk, you see this is the impeller, the inflow. So when it detects, it's gonna be reading current. So high current with the algorithm that the pump has will give 2 notifications, either a risk of clogging or some other mechanical components needs maintenance. So it will do a self-cleaning. It will stop running, it will do a self-reverse spin cleaning, then it will run again, and it will keep monitoring this until and we can, let's say, set how many trial the pump should have, because before it gives an alarm for us as a maintenance or facility manager to go and do the maintenance or call out for a maintenance that the bearing of any component of the pump is down, okay? So this is one of the features that give us preventive maintenance and definitely less downtime of the pump. When we talk about high efficiency, energy efficiency or energy saving, these pumps also being connected to VFD, running on partial and high flow demand, they are able to continuously detect at which duty point of the pump or at what power consumption the pump is running based on the level of flow in the main intake tanks. Based on that, the, let's say, algorithm or the brain of the pump will save these information. It will collect data, and based on this data, based on the level sensing in the tank, it will adapt the optimum speed on which the pump should run in order to provide the best efficiency point at this level of flow. So let's say if the flow is at the maximum, then it will run at a certain speed, but then while detecting that it's running at a medium flow, it will run on another speed. And it will keep monitoring the speed via the VFD in order to run at the high. This mean, what does this mean? If I have a pump that is running always at the highest speed and I don't need it, then the motor is consuming power more than it is needed. When it's running at the optimum demand, then I'm consuming exactly what the pump needs, and I'm providing higher hydraulic efficiency if I'm running at lower speed of frequency. So this is the second point. Then, and all these monitoring features are being done by the integrated Nexus Intelligence. So we call it Nexus Intelligence. It has this microprocessor, and on top of that, we have the feature of the pump that can be, as I said, there is a pumping station of 4 pumps. They can run all in parallel, and one of the pump can be the master monitoring the others. On top of that, just one second. Yeah, so the connectivity between these pumps can be done also by, like the pump, if it's running at partial load, then it will reach the peak load, then it will give the order for the second pump to run, and they will balance. So they will be running together at the same partial 70%, 80%. Then when the system is shut down and it has to run again, so we have the redundancy. So the master pump will give the order for another pump to run. All the connectivity is going to the main collecting, it's either our Wilo Cloud connectivity, Bluetooth connectivity, and the monitoring of the system is here. We can read power consumption, we can read flow, we can read amperes, and then we can read pressure as well. On top of that, there is also usually when one of the also most important thing when it comes to the pumping station is that these pumps are handling sewer. It's not something or a place that we like to be there even for maintenance. So the monitoring of these pumps, it's very important. I need to monitor the temperature of the motor windings. I need to monitor the vibration because vibration affects the operation and then there will be failure. I need to monitor the leakage because we know that these pumps at some point can be submerged or can be running dry. So I need to monitor if there's any leakage between the hydraulic side and the motor side. So usually if you think about any sensor, I need to have a cable, then I need to have a connectivity to a relay. When we talk about digital data interface in our pumps, we are having all these monitoring and preventive sensors all together connected to one processor and one external plug. Okay, so we can have up to 10 single wires or all the monitoring sensors gathered in one external plug. A quick calculation on how these pumps are also being part of the energy saving or running cost as well. We can assume like standard sewage pumps with the standard conventional vortex hydraulic impeller can go up to 50% of efficiency hydraulically. Then we, on top of it, we have the also conventional asynchronous motor that is as per the current regulation, with the energy efficiency level 1. It again goes up to 82% in motor efficiency performance. And then on top of that, we have the VFD, which is the 97. All of it, total efficiency of the pump goes to 40%. On the other side, if we look at our new developed pump, the solid Q hydraulic can provide a hydraulic efficiency of 75. Even with some special coating, we can go up to 78%. Then the IE5 permanent magnet motor is reaching 92.3, and the same VFD of 97. We are among 67% total efficiency of the pump. So a quick calculation on a retrofit. So we did it on one of our stations in Germany. We installed the regular conventional pump compared to the high efficient solid Q pump. And like annual energy cost saving on the running of the pump was approximately 12,000 euro. We're talking about one pump for 1 year. How come about pumping station of 6 pumps running together and many other pumping stations for the running years? And this is a small video just to end with, which is one of our references in Germany. I'm not sure if it's gonna work. Oh, I'm sorry. Should I do anything to make it run? Okay. But there is no sound, but it's fine. So this is an existing pumping station in Germany, and in this station in particular, there is in this city, it's a mixed sewer network. So they take the rainwater sewer network and the sewage together. So we know in summertime the inflow will be less than the third of the total inflow in winter season. The issue also was as the same as we're talking about, the wipes, the solids, the unforeseen particles running into the system. So it was a retrofit project where we installed our Rexa Solid Q pumps. You can see this is how it's installed, and then it has, let's say, the downtime of the station went to a maintenance needed by twice or 3 times a year, and the monitoring is done remotely. So thank you so much for your time. I hope I was not very much boring, but thank you for your time.
Thank you so much. You can keep it here.
Yeah, but it's sliding. I don't know. Yeah. I guess here.
Thank you. Thanks. Just be close, so because we will have a panel discussion. Yeah, thank you. Okay. Continue with the human and water story, or no need? Usually, humans, when they think there is something precious, they try to protect it. And if you notice, most or a lot of our technologies these days is about protecting water sources, whether in or out. Now we will go with Mr. Bora, and I think he will be talking to us on some of these protection skills for sewage water, I assume.
Thank you for the introduction, and good afternoon, and thanks for staying for this presentation. Yeah. I think this is wrong set of slides. Can we check? No problem. Sorry for the technical difficulty. This was actually last year's slides. Yes. Still, I can talk about it. Yeah.
Oh, you look younger anyway.
Yeah, it's old picture. Unfortunately.
Just be waiting for Hassan. He is coming to
Yes. Yeah. This is the new one. Yes, correct. Thank you very much. So today I'm going to speak about innovative application that we have created using AI and machine learning, new technologies, to find blockages on the wastewater networks. But before we start, I want to talk about a little bit on the drivers for this application that we have created. First one is, of course, climate change, which is increasing the unexpected weather events. And we are seeing more and more frequent rain events, even in Middle East. For example, last year we have received a heavy rain in Dubai, and there was a lot of flooding events, which was not expected. Urbanization is another driver. Cities are growing, population is increasing, and digital technologies, of course, now available for us, and we are able to create new technologies faster, and we can innovate faster to cope with this kind of challenges. Also, we are seeing new regulations coming from the governments, enforcing the environmental protection. Also, service availability is very important. So the utilities or the network operators for the water companies, let's say, need to adjust their operation based on these trends, enforcing their applications. So the challenge I'm going to talk today is how we can identify sewer blockages before it's happening. This is an issue, first of all, increasing with the water companies, as they have a limited resource pool for cleaning the networks, and these are not visible before you have the weather event or rain happening. But the first reaction for such problem is usually we can put a sensor, we can maybe measure the level, and then we can put kind of a threshold alarm. So whenever the level is increasing and reaching to a threshold, flooding threshold, we can send somebody there. But this is not that easy. Actually, the targeted use case having a lot of different ways to appear. First of all, like in combined sewer system, there is always flow, which is happening due to sewerage. And then whenever we have the rain on top of it, we have the combined flow, which we need to understand how it's going to behave. Many failure modes can happen and cause a flood. This can be blockages due to upstream or downstream, or clogging on a screen, blinding screens. And then we can have a lot of false alarms due to complexity of the operation and lack of monitoring. So when we see this problem, actually we try to approach on a different angle using with new technologies. First of all, you are seeing 3 levels that we identify. First one is monitoring. Of course, we need a sensor on the network that we are installing inside the selected manholes or critical points. Usually this is a battery operated RTU, because in these networks there are no other infrastructure like electricity or communication. So battery operated RTUs with IP68 combined with a level sensor is a good solution, which can sustain the operation for a long period of time and very easy to install. In many cases, we can install one sensor less than half an hour. And then we are sending this insight, the level information, to our application. We are creating the insights using AI and machine learning technologies. And impact, as you see, we are able to identify 90% of the issues correctly. And sometimes we can identify the blockages even 2 weeks before it is happening. And we have large deployment in large cities. It can scale up quickly. One example is we have 5 million inhabitants in one city using this system and successfully deployed. If we go deeper inside the technology, there are actually 4 stages. First one is the sensor, second is the connectivity, third one is the rainfall or the weather information coming into the application, and then last one is our application, which is called SIVA blockage predictor. Sensor, actually, I'm part of Siemens. Of course, we are recommending to use Siemens sensors always, but we are not mandating our customers to use our sensors only. We are always saying that we are buyer of the data. If the data is accurate and coming to our application correctly, we are able to use it. So we are not mandating any type of technology also. You can use radar sensors, ultrasonic sensors, even the contact level sensors are possible to use, and it can be integrated to the system. Second layer is the connectivity. As I mentioned before, we are usually using battery-operated RTUs, but if you have any other means to operate or collect the information from the sensor, it's okay for us. Any type of connectivity technology is okay. Usually we are using 4G or IoT technologies. I know in Oman, LoRaWAN is very popular. LoRaWAN is also possible to use. But the important thing is that we need to use something compact, easy to install, and ready for such operation, because where we are installing is inside the sewer, and it's a hazardous area, and it's a very hostile environment. Third one is the platform. So we have pre-integrated offering for the weather platforms, if it is available. If it is not available, we are able to install rain gauges for a specific area. This is just to get the information about the rainfall, which is a great effect for the behavior of the asset. And this information will be integrated to the application. Also, integrating to other platforms are possible, because whenever we are giving insights, maybe our customers want to utilize these insights on the different applications, work order management systems. These are also possible, and we have flexibility around this. And last one, but maybe the most important one, is the SIVA blockage predictor application, which we are using the real-time data and the analytic capabilities and AI and machine learning, combining all this information into one and creating AI-based alarms, predicting the blockages before it's happening. So let's go deeper to the system, how the system is working, how the machine is understanding the events before it's happening. As we said, rain information is one of the drivers for stormwater networks and wastewater networks. We are getting this information and we are using artificial neural network models and predicting the asset level, learning from the historical data and the reading from the level sensor. So for each asset, we are creating a unique model, and the behavior is always predicted. And this prediction is always compared with the actual asset level coming from the sensor. This comparison actually is compared on a fuzzy logic system and creating insights for the operator to understand the state of the network. This is a little bit complicated, but I'm sure if you give your attention, you will be able to understand, because this is the base of how the machine is predicting and creating the flags for future blockages. Here you are seeing 15-minute data over 2 weeks on an asset, and the solid line you are seeing is the actual water level, And the dotted line is actually the predicted level by our system using the model that we have trained on the particular asset. As you see, we are coloring green, the left-hand side, and this is according to our system. There is no need for an alarm. Even the actual level is above the spill level. Maybe some spill is happening, some flood is happening. We are understanding that this is due to heavy raining event, which is happening on that duration, and we are not raising a flag, because avoiding false alarms and creating the correct alarm is very critical for a limited workforce, which is trying to maintain thousands of assets on a rain event. But as you see, there is no rain, and rain is actually the blue line on the bottom. There is no rain on the right-hand side, but the predicted level and the actual level is not matching. There is elevation in between. So for us, this is the alert. This is the alert we need to create, because even there is no rain, even we are under the spill level, it's not flooding, nobody's calling you, but it's going to block soon. So you need to go there and clean it before it's happening, okay? So what is the difference with the traditional approach? If we have a traditional SCADA application or alert, we will have the above picture. Okay, we will have 3 false alarms when it is raining. Maybe you will go there, but you will not find anything because it's the normal behavior. Your guys are wasting time on the wrong location, wrong time. But on the right-hand side, there is no alarm. There is nothing, no pressure. Your guys are sitting in the office, maybe doing nothing, and they need to go somewhere and clean it. They don't know. So this is what we are trying to change on the operation with a small application. And this application actually, when we created together with our customer, we shared the results with a third party. And this evaluation has been done by University of Sheffield. And we have shared 21,300 days of data for 38 assets. Independently, they have checked, and they have confirmed that we are 3 times better than traditional systems, and we are able to find 90% all the issues on the network. And 97% of alarms are correct. And these are checked by the field crews going to the site and saying that, yes, this is a correct information, correct alarm found by the system. So what does it mean? We can find 80% more blockages. For an analyst, they can be 30% more effective than the previous statistical method they use, okay? So one person can find 30 times more effectively the blockages happening. And 67% of the blockages detected earlier than the previous methodology. So for the end user, it's for different roles. Usually we are hearing these sentences from different personnel in the end user. So if somebody is working on the installation, they are finding this application to install very easy. They don't need to call a supervisor or any Siemens person to come and check. They can do it by themselves. Operational analysts are more effective. They are more informed. Blockages are happening or going to happen. And maintenance supervisors are able to spend more time fixing the right problems on the right time, and they can understand the real-time position of their network easily. And of course, reporting is very easy for the management level, because everything is recorded on a digital application, and you can create your KPIs and present it to your management easily. That's all from my side. Myself, Bora Helvacı. This is my business card. If you want to know more about this application, you can contact me. Thank you very much.
But this is very interesting. He was sitting next to you. technology is demanding. Okay. Just to know if our discussion that if we want to exchange information, usually we are more attracted to visual presentation and term technologically appealing than actually talking to the person next to me, which is interesting as the human behavior is evolving. Anyway, we have our guest, Dr. Slabako, if he's available. Yes. We will be eager to hear your presentation. Dr. Slabako, basically, he will talk about exploring AI-enabled digital twins, if I'm not mistaken. And this is what catches me. Twins for infrastructure efficiency and resilience. So, Doctor, the floor is yours.
Thank you, Dr. Mohammed, for your kind introduction. So, good afternoon, colleagues. I hope we can still, keep the energy high in the room. Thank you very much for the invitation for this presentation at the Oman Water Week. It's great to be here as well. I've been coming to the region more than 35 years, and I've seen tremendous improvement in the water infrastructure in the GCC countries, including Oman as well. So I'm working as a global water industry director, almost 20 years with Bentley Systems. We are a technology vendor, software company, and around 35 years in the industry. So my agenda for today is really a brief introduction regarding the company, what are the business challenges that we see here in the GCC region and including Oman, of course. Some of the solutions I will be talking about that owner-operators, water companies like Nama Water and the engineering consultants are utilizing in the region. Some of the capabilities, AI-powered, everybody's talking about nowadays, including Bora, regarding artificial intelligence, and some case studies from the region, but also globally as well. Brief introduction to Bentley Systems. So we are a NASDAQ-listed company, more than 41 years in operation. 5 Bentley brothers basically established this family business and successfully brought it to NASDAQ in 2021. We have more than 5,000 colleagues working also here in the region. Our headquarters is based in Dubai, and we are serving from there the GCC countries together with partners in the region, including Oman. We are heavily investing in R&D technology, obviously, and we are working with universities and young engineers in order to advance the water infrastructure in the world. Recently, we acquired a very interesting company, which is called Cesium. You probably heard about it or not. If you didn't, so any Google Map application that you're opening on mobile phone is basically based on Cesium. And this brings a new dimension to our digital twins, which is basically city-scale digital twin. Any type of projects during the design, construction, but also operation and maintenance can be created with a high fidelity data and visually interacted, being a water network, being a building, being a STP, being a pumping stations, etc. So this gives a really acceleration of the digital twins technology. We're operating in this infrastructure sectors, so transportation, obviously, so roads, rails, bridges, tunnels, everything linked to mobility. In water, I color it with blue, which is very important, which is the focus on this conference as well. Energy, which is crucial. We have seen also a very nice presentation regarding the energy transition towards hydrogen, decarbonization, and city-scale industrial solutions as well. What are the key challenges that we are facing in the GCC countries and seeing, for example, United Arab Emirates, seeing Saudi, seeing Oman developed throughout the years? Still, we are struggling with non-revenue water. So that's number one. Fix the plugs. There are so many technologies, so much, to do still. Yesterday, we were discussing also with Nama Water, they are using some of the modern drone technology in order to detect leakages in the transmission mains based on temperature, based on wetness of the soil, etc. So it's great to see that this is going down, but world-class utilities are having less than 15% in terms of physical losses, I'm saying, because there is a lot of non-revenue water, which is commercial loss, apparent losses, digital water meters, which are not properly calibrated, etc. Around 60 million live in GCC countries, which is highly stressed water countries as well. And there is, of course, we have seen the capital investment programs in regarding desalination, etc. But just to give an example, if we fix and bring the level of water losses in Oman only by 10%, we can substitute one large desalination plant in the region as well. Energy is very high. I think Seureka from Veolia presented that the energy pumping schemes here are very high in terms of, and Hungary in terms of energy, because we have peculiar elevation and we are transporting water more than 50 kilometers to every customer as well. So we are spending a lot of money on electricity, and optimizing the energy is key. The global water demand is projected to rise about 60%. Of course, we want to enjoy our life. We want our swimming pools. We want to wash our cars. We want to, not to compromise, let's say, on the safety and security of our living. So that means a lot of water will be required till 2030, which is just 5 years away. There is a 15+ billion necessary in terms of USD dollars. So in real, it will be divided by 2.5, roughly, so 7.5 billion, in order to keep the infrastructure running basically in the system. A brief overview of our Bentley product, Water and Solutions. We are saying that we are solving the water, sewer, and stormwater engineering challenges today, but keeping in mind the long-term planning. And obviously everything starts with the strategic planning, master planning, and I will be speaking about that as well, and some case studies from the region. When we look at the water and wastewater infrastructure, these are the key domains we are covering. So treatment plants, it starts with water treatment facilities, desal facilities, obviously, large pumping stations, but also STPs, reclamation plants. We are treating the water and reusing for process industry, for recharging the groundwater, and also for irrigation. Water distribution, potable water distribution, which is key. Wastewater collection systems. Storm water, Oman is also flood prone. You have seen many floods throughout the years, and last year as well we had a water up to 10 meters here in Muscat as well in some places. And finally, water resources in terms of dams, reservoirs, and groundwater resources as well. So we are covering all of these software solutions in order to plan, design, construct, and operate and maintain this critical infrastructure. And our foundation in the software that we provided is basically digital twin technology, and I will explain what does it mean. Digital twin is basically a digital replica of the physical infrastructure that simulates the behavior throughout the complete life cycle, from planning, designing, multidisciplinary design, engineering, structural, geotechnical, hydraulic, etc. Then constructing it, obviously. We also use that digital twin to construct in time and with budget, to simulate risk of delays, etc. When we construct it, we hand it over to operation and maintenance. That digital twins become apparatus for predictive maintenance, preventive maintenance, etc. And finally, decommissioning, and the infinite cycle goes, of course, so always there. I would like to show you a couple of case studies. This is a case study from Public Utility Board in Singapore. They are very advanced utility. I wanted to show you different maturity levels of different companies. They're having around 6,000 kilometers of underground infrastructure and very well equipped with sensors, pressure sensors, flow meters, intelligent hydrants, but also acoustic loggers as well. So what to do with this data? What to do, basically, we put a digital twin, which is using some AI technology together with our simulation, OpenFlow's water jams. And this is just how deep learning models are created based on flow data, but also acoustic data and simulation data. That's the added value we are bringing into the digital twin. And this technology is now implemented in our operational digital twin, which is called WaterSight. So it's a web-based platform which can monitor, operate, and provide decision support for any type of water network, wastewater network, or sewer network, or storm network as well. So what are the outcomes? They have launched this interesting digital grid project, and we tested it obviously on false positive and real leakages as well. So heating rate is above 80%, and it's very hard to achieve this type of accuracy based on, for example, satellite images or other leakage detection technologies. So we can very accurately pinpoint the geographical location and the size of the leaks into the network. Another example, this is a Tuas water reclamation plant, also from the region. What I wanted to show you, this is the biggest bioreactor in the world. They are treating a large amount of water which is recycled. And of course, sometimes it's a negative connotation of treating sewer water and then using it for other purposes like irrigation or processed water, etc. But they are using it to also recharge the groundwater aquifer, and this is an example of digital twin, so digital model of the complete constructed wastewater treatment plant, which is now in operation. Multi-billion-dollar investment. This is one example how, for example, our construction management software was used to track the construction progress, also track health and safety issues, where to put the crane, which parts can be fitted or not. So all of this stuff can be simulated even before construction as well. This is another example close to the region here. So from the National Water Company in Saudi, so ILEF, a Saudi consulting company, used water jams in this case, our digital model, hydraulic model, to create a digital representation of the strategic model in Riyadh. And this is very similar what Seureka presented. So working with NAMA, they have created and calibrating a model, hydraulic model, to present a good digital representation of the reality of the network, what is happening. And then you can use this model to improve efficiencies, to compare different scenarios, and even to put it in operation, that model becomes a live model, which can give us a lot of insight and information. So this was done in NWC. This is a very interesting one. Everybody probably recognizes this. So this is one of the digital twins we implemented for Abu Dhabi Yas Marina Circuit, the Formula One. A lot of tourists and a lot of colleagues are visiting this. So imagine the amount of the demand spikes and the amount of pressure which is there. This is just one example of analyzing the risk of water hammer, transient analysis. Once you have the digital twin, you can analyze where the water hammer might damage the pipes and properly protect them with air valves, wash valves, hydropneumatic tanks, proper variable speed drives we heard from the pumping presentation, etc. This is another case study from home where I live. This is Evides, one of the biggest water utilities in the Netherlands and one of the leading, I would say. So they implemented complete digital twin for wider city area of Rotterdam, 2 million plus people. And this is a live model, so for those people who wants to see this in action, we have a small booth there, so if you would like to see a real demonstration, I can show you how they are using this type of technologies in order to improve the network, to optimize the network, and ensure long-term water for the Dutch citizens. This is an interesting one, city of Paris. Before the Olympic Games, you remember last year the Olympic Games, this in Montmartre area, complete digital twin implemented in water side, which is live, combining SCADA data, combining hydraulic model, combining GIS data, work order management data. And because many tourists are coming, you know, with 10 buses coming in one place, so imagine the demand and the chlorination demand, water quality demand on this. Without a digital twin and proper forecasting and managing the water supply and demand, it's even impossible for the operator to get that intelligence. And this is done automatically by the digital twin. Another interesting case study, this is the largest utility in the world, colleagues. Sabesp is a Brazilian-based water operator, basically, so serving, this is Sao Paulo, mega city, as you can imagine, about 30 million people live there. So providing a new water and new sewer services, it's almost impossible without simulation and creating a digital twin and if-else scenarios. So they've created a Integra 4.0 program, they call it, such that they can manage the water resources in the complete Tietê River, taking into account the water resources, taking into account the water supply, the wastewater and the stormwater integrally. And of course, one of the key savings and outcomes I want to stress here, we saw some of the techniques like detecting blockages. So with the digital twin, real-time information, you can simulate and detect the blockages, detect the sewer outflow, which is coming, for example, to the sea and to the river. Also reduced work hours, significant amount of work hours, because it's not only the return on investment that we can measure with this type of projects. Our management would like to see return on investment in monetary value, but we would like to see return on value. Productivity increases, we adopt new technologies, youngsters are learning artificial intelligence, etc. So raising the level of skills is also very important, which will return on the longer term as well. Just to summarize my talk, we have more than 10,000 customers around the world and a lot of using this type of technology. So what are the potential Oman water infrastructure benefits we can gain? So reduce of the non-revenue water, as I mentioned, improve energy efficiency through optimized pumping, scheduling, and pumping operations, reduce service interruptions, which is also important, public image of the company and the happiness of our customers at the end of the day. Someone will speak after me regarding that topic as well. Reduction of the sewer blockages and improved capital decisions. I'm glad to see that we are investing here more than 1 billion riyals in key capital projects for the water infrastructure, because water infrastructure is basically a critical infrastructure, is the interface between the people and the planet with the water resources. And without proper water infrastructure, it's difficult to sustain the economy, sustain environment, and basically sustain the life. So visit us at the booth if you would like to see some of this technology in action with a live demonstration as well. We are there with 4 colleagues, so Rua, Sajan, and Mohammed and me. We are there and happy to receive you. Thank you very much.
Thank you, Doctor, for this interesting presentation. And I think it raised a lot of questions. And I think a lot of people will be asking you a lot of questions later on. So before the last long-awaited presentation, we have Engineer Khalid Al-Lawati. He will come to speak to us about security of supply and enhancing customer satisfaction for water, if I'm not wrong.
السلام عليكم. Okay, my name is Khalid Al-Lawati from Nama Water Services. Today I'm going to tell you a successful story. I'm not here to do any marketing for any product, anything. I'm from the client side, but I'm going to present a successful story of an AMR, smart meters, okay, on behalf of my colleagues, some of them that are here, and on behalf of our partners as well. I will not name them. Oh, okay, fine. Okay, the facts before 2019. It's a true story, and that's why I hope it will be interesting and not very boring. Before 2019, we used to have very high operational cost. I'm talking about the meter readings, the mechanical meters. So we used to have labor-intensive process, safety risks. You know, we used to have more than 300, 400 people reading the meters all around Oman. Now, we have nobody with the AMR. We used to have safety risks, so the meter readers, they go and read the meters. There are a lot of risks involved in that. High rate of estimated reads. Before 2019, the estimated bills used to be more than 40%. And of course, that's also because of the inaccuracy of the reads, and then hence the inaccuracy of the billing. Again, external challenges. We had COVID-19 impact and extreme weather. As we said, now Oman having many floods, rainfalls. So that's also in COVID-19. You don't come to my house to take the reading because you will give me COVID-19, or I will give you COVID-19. So that's why during that period, most of the bills were estimated. The low collection rates, of course, if the bills are estimated, then the rate of collection will be very low, and the payments will be delayed. Lack of data accuracy. Before 2019, if you see a water bill, the name is wrong, the address is wrong, the contact number is wrong. Okay, so basically, even the reading is wrong. That's before 2019. No monitoring. We don't know the behavior of the customers. There is no monitoring system to monitor the behavior of the customer, the consumption of the commercial, residential, industrial, all types of customers. And of course, high NRW. Commercial areas, and that's also a revenue impact. Okay, after 2019, as of 2024, I'm talking about December 2024, the NRW percentage changeover, you can see in 2022 from 40%, December 2024, 37%. And I'm sure you know that it's very difficult to reduce the NRW, okay, in such big country like Oman. I'm talking today about all the governorate except Dhofar, because Dhofar, there is another company, government company managing Dhofar. Percentage of actual bills. In 2022, we used to have 80%, and now our actual bills are 92%. So our estimated bills are only 8%, and our aim this year to go even below 5%. The total accounts up to date, the AMR, we have more than 703,000 AMR meters, accounts, serving more than 3.5 million customers. And the non-AMR, 35,594. And by the end of this year, let's say by mid of this year, it will be less than this. Because we had two projects. One project is in Muscat from 2019. We started the rollout in Muscat. I'll go to the journey. But before that, we had a pilot in Sandam. And now from 2024, July, we had the project in other governorates in Oman, except Dhofar. I will not keep saying except Dhofar. Okay. The observation, the NRW percentage improvement, increase in actual billing, efficient water management, better revenue collection, and operational insight, more automated operation. This is all through the AMR, a technology that automatically collects meter reading without requiring manual visits, and by using the advanced management infrastructure. So we have two-way communication. MDM, the meter to the MDM. The journey in 2019, we started the pilot in Sandam, only 10,000 accounts. After the successful pilot, in 2019, we started the project in Muscat. More than 320,000 meters. Then in 23, we started, implementing the prepaid, or working on the prepaid. And actually it was implemented in March 2024, which was the official prepaid launch. And this is unique in the region. No GCC country is having prepaid, in the water service. They have electricity, and we have both. We have electricity and we have water. In July 2024, as I mentioned, we started the rollout in the regions, the other governorates, and now we reached more than 95%. Our target is by end of May to finish, let's say, 99%, okay, because there is no story without challenges, which I will come later. AMR benefits. What are the AMR benefits? We have two types. We have the benefits for the company, for the utilities, and we have for the customer. For the company, we have the comprehensive data collection. We have a big, giant, data bank with us. And we are now thinking how to utilize this in our operation, in our expansion, network expansion, in our master planning, we are working with our partners, with our colleagues, on utilizing this massive data. Even we are trying to include now, we are working on the AI solutions. The Internet of Things integration, device connectivity, data analysis, streamline operation, automation of the process, resources optimization. We can't say that we will avoid visiting the sites, but we minimize going to the sites. So that's why we have the resources optimization. Improve revenue collection. As I said, our billing accuracy is more than 94%. Our collection last year was very high comparing to 2023, sorry. Support for digital transformation. As you know, Oman Vision 2040 is calling for a digital transformation. And our company, the company started in 2020 or 2021. It's basically new. I didn't go to the introduction. It's a merger between Haya Water, the wastewater, and Diyam, which is the water authority. So since the merger has started and we are working on the digital transformation to comply with Oman Vision 2040. Reduce water losses, leak detection, efficiency improvement. Now we are having also a pilot project we are going to do with the same vendor. We are going to have different types of meters. We selected a region where we will do a pilot project for 200 customers. And in that, normally, the system gives you the leakage downstream of the meter, inside the houses. But in that project, we will come to know if there is a leakage, upstream of the meter, so in the connection. So that basically will measure the vibrations, will measure the pressure. The pressure is going down, means there is a leak in the house connection. For the customer, of course, accurate billing, real-time usage monitoring. We have the application, Nama Water application. In that application, if you open the application, you will see your house consumption on hourly basis. You can see all the alerts, the dry pipe, the leakage, everything in that application. And not only that, it will also come to your phone, an SMS. So the system will generate an SMS and send to your mobile. Reduce estimated bills, enhance water conservation awareness. And this is an example from the application about the monthly usage of a particular customer. AMR impact examples, I'll give 2 examples because the doctor is saying I have only 5 minutes. Okay. Positive consumption growth. So if we compare between February 2024 and February 2025, the positive consumption has increased for more than 55,000 accounts, which is 9.2%. And the zero consumption, the zero reads decreased by 21.7%. We know that the mechanical meters are not giving the accurate billing or the accurate read. And also, most of these meters, after 1 year, 2 years, become very slow. So that's also a source of NRW. In the smart meters, we have sensors. So that's also, measuring the drop of water. And that's why the positive consumption goes up and the zero consumption, because of all the faulty mechanical meters, now with the smart meters, the zero consumption is going down. Okay, how the AMR works, it's a bit technical here. We use the meters. The meters, we are using the LoRa 1 network. The meters send the data through the LoRa network to the LoRa network server, okay, and then to the MDM. And it's two-way communication. This is for both, for prepaid and for the postpaid. We started in 2018 with 23 gateways, and in 24, we end up with 345 gateways. Still, we're having some issues in the communication, few, maybe 2,000 to 3,000 meters. And we are also working on improving that and installing more gateways. And this is, I'm talking all over Oman. We have also our control center where we have the dashboard. Our people are sitting there and they monitor everything about, about the meters and about all the customers we have. You have the map there, Oman map, and you have the green dots. The green dots means the meter been replaced to smart meter. And the red is still not replaced. So all the leaks, all the alarms, all the consumption, everything can be seen in that dashboard. So that dashboard or that smart meter control center is centralized monitoring and management, proactive network maintenance, streamlined rollout, data-driven decision-making, and incident management and rapid response. And I think this is also, this is unique and it's one in the GCC. These are some types of the meters that we use. The bulk meters and the DN15. And for the prepaid, we use only the Baylan one, the Turkish one, so far. So for the prepaid, the benefits for the customer, advance payment, leakage protection. So if you have 10 riyal as a credit in the prepaid, and if there is a leakage, you are losing only the 10 riyal. But in the postpaid, you might lose 1,000 riyal if you don't know about the leak. For the utility provider, we improve the revenue collection. We are getting our money in advance. That's why we are encouraging people to have the prepaid. Operational efficiency as well. So we started in July 2023 with 500 prepaid accounts. And now, as of today, we have more than 25,000. And this is only in Muscat. We are going to launch the prepaid in the other regions by end of this month, inshallah. Okay, and this is for the prepaid. It's almost the same. How you do the top-up from the application or from the portal. You can do the top-up. And, it's reflected in the meter, not in Riyal Omani, but in meter cube. We have some challenges. We have the system integration. MashaAllah, unfortunately, in Nama Water, we use many, many systems. So integrating the smart ops with other systems with operation, with billing, it's time consuming. So far, we managed to finish maybe, let's say, 80% of the integrations, and still we have 20% to go. Training of the employees. We have a team travel to all the regions to train all the staff all around the country. And, because it's a new thing, it's not easy to train all the staff in one session. So we need to have a team free all the time to go and train the staff. The communication, as I mentioned, the signals, the communication. If the meter is inside the chamber, if the meter is inside the house, it's very difficult, to communicate through the LoRa system, and that's one of the challenges we face. Customer acceptance and engagement. We always go and meet the governors of the regions, and we ask for their support. We explain the challenges to them, and we ask for their support with the consumers, because some consumers, they refuse to change the meter. They know that they will pay. The meter is free, but they know that the bill will be, increased by maybe more than 30%, which is true. Execution, we have the challenges. You can see that skull there, the old meter. You see the pipe, rusted, both sides. So from our side, our operation takes care. But from the customer side, most of the time they refuse to replace the pipe because it's an additional cost for them. And of course, there are other also HSE, let's say, risks. We have meters in the wadis, we have bushes, we have this. يمكن في جن ولا شيء. Okay, so this is Oman. Okay. In future, we want to have 90,000 prepaid meters by 2028. Now we have more than 25,000. Our aim to have 35,000 by end of the year. And for the postpaid, in the coming 3 years, we are planning to reach minimum 850,000. So now our prepaid represents 33% of the total accounts. Our aim to, to reach 15% minimum by 2028. We have, as I mentioned earlier, massive data, and that's why we are working on the behavior analysis and future expansions, and we are thinking what we can do with this, data for future. And all, at the end, all this for the customer satisfaction. These are some of the alarms that you receive in your mobile application. Okay, this is from the meter, and you will receive it in your mobile application. Okay, these are some of the ongoing enhancements. We are rebranding our 36 branches. Our, old branches used to be like a small caravans, old buildings, but this is our new identity. We are also working on our website. We are also working on outsourcing the call center. And we are also redesigning our application. And that's all. Thank you very much, and thanks for coming. Shukran.
I try to give him his time because this is usually a topic targeting everyone of us pocket. So we all eager to know more, how much we need to pay Khalid by the end of the day, and if it's accurate billing or not. Not you personally, I mean the company. Thank you so much, Engineer Khalid. It was an interesting presentation, and I assume there is a lot of questions will be later on. And our final presentation with Dr. Atif. The floor is yours.
Okay, hello everyone. Today I will presenting sewer network inspection using basis status and artificial intelligence powered Sarida. What I will present today, it's a joint solution from Bartower Software GmbH, from a company from Germany, with ASIC and Dr. Stein and partner. It is an AI-powered sewer inspection system coupled with Stein algorithm, transforming the way inspection are done faster, more accurate, and more reliable as input to establish an accurate strategy for reparation and rehabilitation using basis status. Sewer system face big challenges: aging infrastructure, tight budget, human error, data silo, and environment risks. Sarida use artificial intelligence to address all of these, detecting leaks before they happen, saving costs, and improving safety and communication. Sarida system supports operator and engineer by simplifying complex data and speeding up decision making. It reduces error, save times and money, and help prevent environmental hazards by spotting issues before they turn critical. Sarida combines two components, Sarida Edge and Sarida Portal. It covers the full inspection cycle, from planning to AI-supported analysis to data sharing, all in one connection ecosystem. The portal is secure, cloud-based platform. It manages the full inspection process, from video storage and project management to AI-based defect detection. Built on Microsoft Azure, it ensures secure data exchange with all stakeholders. The workflow between Sarida and Buzz platform, Sarida Video is fully integrated into Buzz, so the user can use this solution friendly. There is nothing to make as parameter or to do. With just one click, inspector can automatically detect condition using AI and get a complete overview of the video footage. Once logged in through your Bar Tower sales partner, you can run video analysis directly in Buzz. The system highlights all defects visually code them automatically and keep everything in one place. So there is no switching between tools. As of standards and norms for Sarida, we use Q2 2024. These are the defect classes by Sarida AI. The system is continuously updated to include more type and improve detection quality. Sarida Edge is the real-time AI assistant. It analyzes video as they are recorded, giving immediate and standardized feedback. Once connected to the internet, videos can be uploaded to the portal for further AI processing and 3D visualization. Here what the real-time video analysis look like with Sarida Edge. The system tracks and classifies issue live, helping inspector act quickly and confidently. As use case, we try Sarida portal and Edge with Berliner Wasserbetrieb, a company of water of Berlin. In this use case, Sarida analyzed over 1,000 pipes for Berliner Wasserbetrieb in just one day. It gives their team high-quality structured data faster than ever before. Okay, now we are diving into the world of strategic asset management for sewer network, powered by basis status. This system, developed by Bar Tower software and fortified by Stein and partner algorithms, is designed to help municipalities and utilities preserve the value of their infrastructure through proactive network management. By leveraging advanced data analysis and planning tools, basis status ensure that sewer network remain functional, efficient, and cost-effective over the long term. At the core, the basis status is a robust data foundation. The system relies on master data and inspection data to assess the condition and structural integrity of sewer network. Master data includes key details like sewer type, material, diameter, year of construction, cover height, groundwater level, etc. Inspection data, on the other hand, is gathered from optical CCTV, especially from Sarida, adhering to common standard like EasyWow or DWA or the European standard. This comprehensive data collection ensures accurate and reliable assessment for the basis for all subsequent planning and decision making. Okay, let's take a closer look at the strategic rehabilitation. It begins with data validation, where master and inspection data are checked for accuracy. Next, assets are clustered based on shared characteristics like material, age, and location. This is followed by condition and structural assessment, which determine the current state of the network. Using this information, the system calculates the survival probability for each asset and identify the optimal rehabilitation strategy. Finally, the results are outputted for operational planning, ensuring the seamless transition for strategy to action. Before any analysis can begin, the master and inspection data must undergo through validation process. Okay. One of the key features of base status is its ability to cluster assets based on similar aging behavior. This clustering considers factors like material, year of construction, nominal diameter, and location. Once clustered, the system generates survival functions for each group, predicting how long the asset will remain functional. Okay. These curves are created using configurable database query and are evaluated to ensure accuracy. If necessary, the system adjusts the cluster formation to better reflect the aging behavior of the assets. Base status also provides forecasts of the probability of aging. This forecast calculates the transition probabilities of assets moving into different conditions and substance classes. Over time, it also estimates the remaining useful life for each asset and provides an overall depiction of how the network will change in the future financial year. To help users make informed decisions, the system allows for comparison of forecast results. They give 3 or 4 forecasts. Once the strategy is implemented, base status allows for its evaluation. User can compare the development of condition and material classes, the average age and remaining service life of assets, and the distribution of remaining service life. The system also tracks the progression of fees, maintenance costs, providing a comprehensive overview of the strategy effectiveness. In summary, base status offers numerous advantages and benefits. It's an intuitive operation and consistent user guidance make it easy to use, while its integration with other basis applications ensure seamless workflows. The system provides realistic assessments of damage and risks, enable economical renovation decision. Most importantly is support the long-term distribution of investment, ensuring the sustainable development of sewer network. Thank you for your attention. For more information, you can access our website for more brochure and more information. Thank you.
Thank you, Dr. Atif. And I think you might stay here because I will be asking all the presenters to come on stage, please, for a panel discussion. Dr. Atif, please have a seat. There is a mic in most of the chairs, if not all of them. Sorry? Yeah. Could you please check if all of them are working? I assume. Yeah. Dear audience, the floor is yours. You have been hearing a lot, and I think this is your time to speak and to tell us your thoughts. All the presenters are happy to listen to your questions. If you have any questions, we will be more than happy to listen to it. And I think everyone is interested to give an answers for that. So who would like to go first? حسام توزع المايك على الأودينس. زين. Anyone who is interested to ask questions, please raise your hand. Yeah. Please say your questions to whom exactly?
Yeah, sure. Thank you so much for the presentations. My name is Bakr from Flawless. My question is for Benjamin Ernst. This is a question on the presentation where you presented your system for prediction of failures in the pipelines. Can you maybe expand a little bit more on the technicalities of what data you use, what type of modeling that you use, and like, do you do hydraulic analysis, for example, or is it like condition assessment? Can you expand a little bit more on that? Thank you so much.
Yeah, great. So thank you for the question there. The technology at the core of that solution is a machine learning approach called random forest, which focuses on grouping assets into classifications. So once we discover those meaningful classifications within a data set, you can draw deductions off of observations made in other parts of the network and then generalize those to all of the assets, even those parts of the network where you don't really have complete data. So that allows very powerful decision making and allows you to make observations like when Abdul Karim, specifically as an installer, when he installs pipes after 4 p.m. in the afternoon, those have a higher failure rate. That's a very specific deduction. So the types of data that system takes into account is everything that we know about a pipe, all of the data sets within the organization, within the water utility that you can get your hands on. You can feed those into the algorithm. And some of those turn out to be consequential and some of them don't. And the algorithm's able to sort those out.
Any other questions? Thank you, Benjamin. Any other questions? Yes, please.
Okay. Anyone want to ask a question? Because I have 3 or 2. I will start with the youngest one, Mr. Mark. Mr. Mark, when we talk about plastic, we know plastic, they are not healthy or environmental things. But from your concepts, you're saying that they are safer for the environment. Just can you explain
I think
more?
the plastic we are talking about is engineered plastic for specific applications. The plastic we read about in the news are the plastic bags and the bottles that 3 people throw in the road. It's 2 different materials. So our plastics are engineered to suit a particular application. So that's mainly, we don't see these things floating around in the sea, not very often anyway, unless a ship sinks. But plastic bottles, plastic bags, yes, I agree, they are health hazards.
What about end-life disposal?
Sorry?
End-life disposal.
End-of-life disposal, most of the plastics we manufacture are recyclable.
So you can reuse
So a plastic pipe you could turn into a cool box.
Okay.
Except for example. So you have the possibility to recycle that plastic into other
and keep it with you for longer in the system.
Yeah.
Lovely. Is that answer your questions?
Yeah, it does.
Okay.
The second one to Mr. Vilyukov. Yes, you presented in your last slides very promising numbers. You're talking about 50% reduction in water losses. What is the duration of that 50% reduction in Oman?
Thank you for your question. So these are numbers extracted from many users around the world. And normally the non-revenue water program is a 5 years program where there are a couple of steps or components. So first is division of the network in district metered areas or zones. Then second is, of course, pressure management, which is basically reducing the pressure, calming the water to an optimal level. The third one is active leakage detection. We go and find the leaks using these technologies or any other technologies. And the fifth one is long-term asset performance management and adjusting the asset management strategies. So when I say, 15% reduction, that doesn't happen overnight. It's a program which needs to be properly executed by the company with an executive commitment and proper budgets as well.
Thanks. The last one for Mrs. Sarwat. In your wonderful pumping stations, you only mentioned the example of wastewater. That one is applicable for a water system also, because as we mentioned,
earlier presentation, we are talking about 50% of our water is transported from Muscat, from coast to the mid of the country.
Yeah.
So is there a visibility to use it in the water system?
Thank you. When it comes to the technology on the motor side, we have some also innovation on the pumping station. So we're talking about transfer pumping station, lifting pumping station. We have some new technologies in the borehole pumps, but these borehole pumps also with pressure shroud can be used for lifting stations. We're talking about hydraulic efficiency higher than 85%, for example. And we're talking about innovative technologies in the cooling method of the motor. Also permanent magnet motor with higher efficiency. So when it comes to the clean water side, there is no risk of clogging. More of the pumps are surface pumps, so we care more about the enhancement in the hydraulic side of things. So we developed some coatings that are drinking water approved. We have materials that have ACS drinking water approval, motors with higher efficiency, more detection on the monitoring of bearing, vibration. So all over, we're there in the monitoring, and more like also it comes aligned with all of us when it comes to the system itself. So the pump is one item of the whole system. So whenever we care about the proper hydraulic modeling, we avoid any surge, the hammering, proper sizing, we care about the suction, the NPSH, we will avoid any better risk of failures in the whole system and more enhancement also for a proper selection and optimization in the selection as well and the design of the pumps itself.
Thank you. Done with the questions? No worries. Anyone else? Yes, please. There.
Hello, Mutassim Saadi from Oman Water Services. My question to Ms. Noura. You talk about the renewable hydrogen energy, which can be produced here in Oman. Is it going to be aligned with the main source of income in Oman? As you know, that the main source of income here is oil, so it's going to be aligned with that, or it's going to compete that? The second question I have, when we talk about hydrogen, we talk about clean energy. So producing the hydrogen, it might come with some certain waste, especially from desalinating water. So have we put this in our consideration or not? Thank you.
Thank you for the questions. And if you can, Engineer Noura, also add to that, elaborating his questions about the momentum impact of the projects, whether national level or global level as well, adding to this question.
Okay, thank you for your question. I will start with the second question. Can you repeat it, please?
Sorry, I'm just saying that when we talk about hydrogen, it should be like it's a clean energy. So the main idea of producing hydrogen to have clean energy, but by producing hydrogen itself, by desalinating water, what I know, I'm not a technical person, but what we know that there are some certain waste that it's being produced by desalinating water. So if it's true or not, then...
Yeah. Regarding the hydrogen, we have several types of hydrogens. We have gray hydrogen, green hydrogen, pink hydrogen. The government is approved to go for green hydrogen. The source of green hydrogen, that will be desalinated water, and the water will be separated. As you know, it's H2O, so we'll separate hydrogen from oxygen. Why we go for green hydrogen? Because there is no zero emissions. Currently, Oman produce gray hydrogen in Sohar, but with gray hydrogen, it's a little bit 20% of this production of gray hydrogen has emission. So the government approved the national target to be zero emission. So we go for green hydrogen. And the source of water will be a desalinated plant as per the Oman standard specification 08/2012. Okay, and the first question, please, about the
income.
It's not like it's we're going to produce hydrogen as an energy, but our main income here in Oman is oil. So is this going to compete the oil industry?
Yeah, currently, as you said, the gas and oil is the main source here in Oman. But I think when we start with the green hydrogen, with the economic impacts, maybe I didn't present all the economic impacts at this level of the project, since we are in initial stage. I think yes, will be maybe aligned with the oil and gas sector.
Thank you.
Okay, can I just add one comment about the desalination waste product? I'm not an expert, but 2 years ago we were approached by NEOM in Saudi Arabia, our casting division, asking us if we wanted to buy green magnesium. Apparently from the waste of a desalination plant you can make green magnesium. It might be something for your team to investigate, because there's another source of income there, but I'm not an expert, just a comment I heard 2 years ago, and they came to our headquarters and asked if we want to buy this magnesium, which is a byproduct of desalination.
Exactly, in the brine. It depends about the, with the difficult waters, usually it's a high level in the brine, so it can be extracted.
Yeah.
That was a smart approach, yeah. Thank you. Yes, please.
Thank you, everybody. My question is for Dr. Slavko. So you mentioned an interesting ROI studies and figures that comes from the digital twin implementation. My question is around what are the common challenges that your clients faced during the implementation, and what makes Bentley platform and Bentley unique in overcoming those challenges?
Thank you for your interesting question. Indeed, you know, this is implementation of digital twins and digital technology is basically a journey. It's connected also to people's management, change management in the organization, because implementing digital twin takes a lot of effort for intercommunication between different departments. We sometimes have various silos. For example, the AMR data that engineer Khalid presented could be a separate silo compared to the SCADA data, compared to the modeling department, compared to the leakage department. So the first step is bringing all of these people talking together. Second step is, of course, combining the existing data. There is a lot of data out there in the utilities which is not properly 100% utilized. Sometimes we call it dark data. And the third, there should be always a commitment from the management. So without commitment from the management, this digital twin implementation is doomed to fail. We sometimes make a joke, we have more pilot projects in the water industry than certified pilots in the aircraft industry. Yeah. So always pilot for 6 months, then it stops, there is no momentum. So there should be a commitment, top-down and bottom-up approach as well.
Well said. I think this answers your question. Any further questions you have? Good. Mr. Ward, this is questions for you. If I can ask you these questions. Could you please elaborate more on how AI-driven systems, because you mentioned that about environmental disasters and how they can be prevented, but you went there briefly. Could you please elaborate on how this helps to avoid environmental disasters with sewage system? And could be human behavior could be an added element to that AI-driven algorithm, or it's a neglected factor? So if you can touch on that, it will be great.
Thank you for the question. Yes, there's a certain extent that we can avoid disasters as long as the hydraulic capacity is enough. But we should not see the dream of one software solving the infrastructure problem. Exactly. So, but what we can do, as using digital technologies, we can record the events properly, duration of the event, how it is happening, when it is happening, and under which condition is happening. And then we can learn from this event easily on the digital recording, and then we can make this investment on the infrastructure on the right place. So, and then I think this is touching to the human behavior as well. we can give the confidence to the consumers, also the people who are living in this area, that all these events are taken care of by government or by the water utilities into consideration, and they are trying to fix it. Because if you are not doing it for many years and it's happening in every rain event, or they are flooding all the time, people are getting frustrated and they are thinking that they are not taken care of. So this is the human element part of it.
But if we take it, for example, a seasonal unexpected events, for example, if we take Muscat case,
yes,
usually in average, and let's hope it's not happening, but in average between 7 to 10 years, usually we have an event of hurricane, which is usually unexpected.
Yes.
So in terms of infrastructure investment, to have that huge capacity for probability of an unexpected event, one might happen once every 10 years, then it will be a problem. Now, how can AI could help me in this?
Yeah, this
because
is
I think this is a question for any operation engineers, I think, in this.
Yes,
in this
it's not an easy answer,
Yeah.
for sure.
It's easy, I won't ask you.
And it's the strategy of the governments usually, how they are willing to invest on infrastructures. But of course, this type of events, if they are recorded and if we have a certain understanding of what is the frequency, and if we are able to predict better in the future that is going to happen in this place, at least we can warn the people. Maybe we cannot invest the infrastructure just for one event, but maybe the prediction can generate better alarms or early alarms for the people to get their prevention.
What about mitigation on the system network itself?
Yeah, also mitigation plans can be done. So actually there are endless use cases whenever you have data and analytic capabilities. It's, you know very well probably that it is starting with an idea.
Yes.
And then with data mining you find the right data and then put on the analytics perspective and then create insights for decision makers or investors to take the action. So this is our job, to give them the insights, and then the decision-making process, little bit on the political side.
Okay. Thank you so much. Any final questions before I ask the last one?
Maybe I can add something.
Yes, I was planning actually to ask you, but anyway,
coming
you can
back
answer,
from
yes.
the wastewater, so I think because in many countries, Oman, and even I've been to Europe and America, many countries, what they do normally, in case of any emergency, they open the sea outfalls. Yes. They close the STPs and they open the sea outfalls because, wastewater network is more expensive than water network. Water network is pressurized, but wastewater is driven by gravity. So it's, the excavation, and this is more expensive. And that's why you cannot afford to have a 3-meter diameter pipe. Okay, and also there are technical issues as well because you cannot have a stagnant sewage that will cause odor and cause other problems as well to the public. And that's why I agree with Dr. Muhammad and I agree with you that we cannot have over-design because of one event in 10 years. That's why normally we open the sea outfall once we see that, or we forecast a hurricane or a cyclone. We open the sea outfall. We take the approval from the Ministry of, from the Authority of Environment, and we open and we have that approval. Even in Nama, we have the approval. In case of emergency, we open the sea outfall, and then we quantify the damage later on. But we open the sea outfall, so we don't damage the city, we don't damage the STP. So we, have a potential damage for the sea environment.
As a precautions,
yeah.
Yes.
Okay. Thank
Lovely.
you. Sorry for it.
No, exactly. That's very good. The question is yours. You might keep the mic if you like. You want to add?
Just one more point on this. Actually, this is the practice for everyone. But the idea is today we have to accept that we have a limited hydraulic capacity, and we have to make sure that this hydraulic capacity is available all the time. And we are ready for the event coming up. So that we are trying to do, but everybody is doing the same practice as you're saying.
Lovely. Engineer Khalid, the question is you for smart trading systems. You were presenting in your presentation that it is easy to collect the information. The question was, could you please elaborate more on smart customer feedback? So customer feedback, because It is the smart reading system AMR are actually presented to enhance the customer experience with gaining commercial benefits. Now, could you please elaborate more, because I had these questions with multiple people about the smart customer feedback and correction approach. If you could explain on that.
Well, let's talk frankly, Yani. The customer will not be happy if you are increasing their bills. Yeah, but that's only at the beginning. So gradually they will digest and they will know that, okay, this is their actual consumption. And I can tell you with the smart meters comparing with the mechanical meters, the increase or the increment is minimum 30%, which is true. And we tell the customers, honestly, yes, your bill will be higher than before, because with the mechanical, that was not the actual consumption. So at the beginning, yeah, there's no good satisfaction. But with the time, like in Muscat when we started in 2019, there were many, many complaints. Many complaints, yeah. But now, if you see the list or the complaints we have is going down, the trend is really going down. So, yes, at the beginning, not very good satisfaction, but with the time, the customer, he knows that he's getting the alerts also for the leakage. He's getting the alerts if there's a breakdown in the system, in the network. He is, informed 24 hours. He's getting the real-time data.
You mean it's more transparent?
So more transparency is there. Yes, exactly. But of course, with the pocket, if it's affecting your pocket, you won't be happy at the beginning.
Exactly.
Yeah.
Thank you so much, guys. Please join me to thank our guests today. I think, Hussam, there is some certification for...
Thank you, Dr. Mohammed Saidi, for the excellent moderation. We would like to invite you all to take a group photo. Then we would like to invite Mohammed Saidi to give them appreciation certificate. Are we done? Starting from Benjamin Ernest. نور المنذري. مارك جارت. ثروة نصر. بورا هلبك. دكتور سلافكو. خالد اللواتي. and finally دكتور عاطف بالحزم. Thank you all for attending this day. See you inshallah tomorrow morning.